see. All right, we're live. I think it's live. Nice. All right, I'm gonna do a ton of coding interviews today. Bring my. We got a packed calendar. What do we got? Gonna do DP coding with Alpha for the next hour. Then I'm gonna chat with a freshman. Ali, what's up? What's up? Then we're gonna chat with a freshman, help him figure out his CPSC courses. Then we're gonna. Well, I got my YC friend coming on at 3. He's gonna talk about how he got into YC at like 20. Get like a 500 grand. How he got in. What else? Alpha, you ever want to join YC?
Nah, dude. Like the thing I'm making from scratch, I'm realizing like if I actually have to make something from scratch that's like super fault tolerance and all that stuff, it's a lot of work.
Yeah.
Like I feel like for me, it's just better to kind of like I'm in the stage of my career where I want to learn from people.
Yeah, it makes
and then
sense.
maybe later on I'd be down to do some other thing. But yeah, I definitely don't have enough experience to be like a 4-person company, or I wouldn't want to do that kind of thing.
Now. That makes sense.
Like once I'm like a senior cracked or whatever, like 5+ years experience, I would consider it. But for now, yeah, definitely.
What do you think you need to learn? Like what are you focusing on these days for like actual coding skills? Outside of LeetCode.
I mean, I definitely like from doing this like site for my brother thing, like I definitely don't know too much about deployments and like and also like cost, right? Like in an enterprise company, all the stuff is set up. You can use whatever you want. Now it's like literally I can pick what I use and I can pick how much it costs.
Yeah.
I don't know like anything about that. So that's kind of interesting to learn. Like what can you get away with on a free tier? What do you got to pay for? Things like that.
I see.
Like I said, like I made like an email client on the thing that I made it, and I think there's only like 100 emails a day. So I wasn't sure if I'm gonna like get over that or not, or what's gonna happen.
Yeah.
So right now I'm just kind of testing, and if it breaks, it breaks, because it's not like enterprise. There's like no risk if things fail. So. Yeah.
I see. All right, let's work through some. Oh shoot, I didn't send you the link. Let me send you the link. Put it over here. Generate. I'll send it to you on Discord. Faint, what's good?
Yeah, there's definitely a totally different experience with like you being an enterprise company with a bunch of things there and you doing stuff yourself. Like I wouldn't want to do that at this point in my career. I'd like to have stuff set up so I can focus on
just focus on just straight coding. You can learn it too working on your own startup, but
but I don't want to right now, I guess. Yeah.
Is it overkill to study DP optimization for Meta, or just doing a few top-down? Meta specifically doesn't ask DP questions. They say it. They say that online, and when you interview for them, they send you a document on what kind of questions to expect, and it specifically says, don't study DP.
All right, so I don't think I can paste pictures, right? So I'm gonna see what this pastes, and then we'll go.
Wait, let me start the video. 1 second. 3, 2, 1. Hey everyone. So today I have my friend Alpha, and he's putting me through a more advanced dynamic programming interview. So should be fun. Last time we did some of the classic ones, so today we're gonna ramp it up.
Yep. So yeah, we're gonna do 2 to 3, and then second or third question, I kind of have some different ones, and I can ask you what you prefer.
Sure.
So we'll start with this one. Let's see what it looks like I can't paste this.
Wow.
All right, let's go to this one. And so this is actually a hard on LeetCode, but I don't think it's a hard. It's more like a medium. So
okay. So, all right. Let's just break this question down. Let me move myself to the middle. So, is audio fine, by the way?
Good for me, but yeah, I'm just listening to you on like the Google Meet thing.
Stream, is the everything good on the? Okay, it's good. Sounds good. All right, so we're gonna break down this question. We got the first example. We're given an m by n integers matrix. Return the length of the longest increasing path in a matrix. from each cell, you can either move in 4 directions, left, right, up, or down, and you may not move diagonally. So let me take some notes here. Wait, let me wrap this in like the 3 codes.
Okay.
So I can have my notes here. So yeah, we're given, so this is 1 right here. We're given 9, 6. We'll work through the first example. They're saying the longest, what we're trying to do is grab the longest increasing path. So we just need to, so it's saying the longest is 1, 2, 6, 6, and 9.
Mm-hmm.
Other paths are like 1, 6, 8, but that's 3. And it needs to be strictly increasing, or no?
Yeah.
Okay.
So, yeah.
Needs to be strictly.
Yeah, that also makes the problem easier. So, yeah.
Okay. So it needs to be strictly increasing. So it goes 1, 1, 2. So this path doesn't work. And then, yeah, it needs to be increasing. So what I'm thinking right now, so the result here is 4. If this was like 6, the answer would be 3. It'd probably be like 1, 2, 6, or it could be 1, 6, 8, or 1, 6, 9. But it just needs to follow any path. So what I'm thinking is the brute force solution is we would just do a backtracking algorithm. So it needs to be brute force is a backtracking algo. We're pretty much, we'll loop through every single element in this array. And if we hit a specific, or for every element, we'll try to see for every index, or for every row column pair, we see longest path we can make there, right?
Mm-hmm. And how would we keep track of, in this case, like when we backtrack, how do we keep track of like what we saw already, I guess?
Well, we'll like have a path, and we add to that path. We'll like pretend we start at 1, right? We start at 1. We'll add to the path, and maybe we'll store like a scene, and we'll add the rows and columns to the path of scene. That way, pretend we had like 0 here, and we start at 0, 1, 2, then we get to 6. We don't want to pop 0 back in there anyways. Base. But like, we might not need to worry about that because we know it's less than for sure. If we ever got to this element, we know we're only looking at values that are higher, so it would kind of disqualify.
Yeah, like, is
neighbors.
it possible to get a loop? Like, is it possible to go in a chain and
Not really if we only recurse based on increasing values. So we might not need a scene set.
And so with backtracking generally, so if you try to get like every path, do you know like roughly the time complexity of that? Like maybe not for this problem, but just like a rough.
Probably
time complexity of backtracking.
it's definitely going to be an exponential algorithm, but we can probably memorize it. So we can figure out the longest increasing path from every index, and then cache that. So it'd be like a 2D array. So we'll have a DP row and column, and it's gonna tell us this is the largest or longest increasing for row column combination. So pretend that we cached it, right? Pretend we've already captured 6 and 9, and we figured out the longest here is 2 if we start here. Pretend we do 0, 1, and it recurses, and it gets to 6. It doesn't need to finish it off. We can just return that the longest path here is 2 and add it to our length of the current path. So we get 3 plus 2 is 5. And then we also store this as well. Like, if we do a DP on row and column, we know the longest increasing for that specific row and column. We could just early return, and that will sort of speed up the algorithm.
Right. So what would be the time complexity of that? Like if we cache results.
I think it would be around O of n times m because let's see. It'll be around. It will be longer than O of n times m, but I don't know how to calculate that because, well, it'll at least be n times m, right? But then we're gonna multiply for each element. We're gonna have to perform that backtracking algorithm, but it won't be that inefficient because it'll eventually cache. So there's like it's multiplied by some t, but I need to figure out how long that t might actually run. Does that make sense?
Okay. Yeah. So let's just start coding it, and then maybe once you code it, then we can go back and I'll ask you like based on your code.
Okay.
Or, yeah. So yeah.
Cool.
Let's start coding it.
So let's start with we're given a matrix and then the output. So we're given a def what is this called? Longest increasing path. We're gonna be given a matrix, and we're gonna be given a we're pretty much just gonna return some return. Let's return 0 for now. So what we're gonna do is we need to return the longest path.
Mm-hmm.
So pretend we were running this on print. Like this. We're gonna run it on like this matrix at first.
Sure.
Test 1. And I think I modified it, but 0, 1, 2, 3. 1, 2, 3. So the result here should be 5.
Let's see. Yeah. Yeah. That's good.
So we'll be given test 1. Print matrix. Make sure this function is working correctly. Oh, shoot. Okay, cool. So what we're going to do is, let's see. We're given this matrix. So what I said is we're gonna want to loop through each element here. We're gonna want to loop through each element and try to do that backtracking algorithm on each element, or the DP algorithm on each element. For each row or column, we're gonna ask what's the longest path that we can get there, and we're gonna return the maximum of that starting. So we're gonna say, what's the longest starting from here? What's the longest starting from here? Because we don't know which one, where's the start of the longest path.
Mm-hmm. Yeah, makes sense.
So we're going to go for row in range length of the matrix. That's going to give us the rows. For column in range length of the matrix 0. That's going to give us the columns. And then we're going to perform some DP algorithm here. What we're going to do is we're going to have our result here. We're going to try to maximize. So we're going to start with a float negative infinity.
Mm-hmm. So
what we're going to do is we'll say result, or DP result equals, we're going to call the DP function on the matrix. And we're going to pass in probably like a start value. But first, so I'll figure that out in a second. But what we're going to do is we're going to update our result. And we're going to take the the maximum of the current result and the DP result. So the way we're going to break down this DP is we're going to have our base case that we're going to probably handle memoization. Handle if it's already in cache. I mean, like if it's not in cache, we're going to recurse. Otherwise, recurse and store best result in cache. So we're going to break it down into these steps. So we're going to be given, we're going to be given the row and the column. And then we're also going to need to know, I think that's all we need to know right now, the row and the column. So what we're going to do is, what's the base case is like if the row is less than 0. So first we need to capture out of bounds cases. I'll handle that in the base cases here.
Mm-hmm.
So I don't have to handle like looping through the neighbors smartly. But I'll do if the row is less than 0 or the row is greater than equal to the length of the matrix, return 0. And I'll do the same thing for the column here. So if these are out of bounds, if the row, and then we'll also say if it's out of bounds, we return 0. If the matrix at the row and column is not equal to, we need to give it some target. Is not, if it's less than or equal to, because you need to be increasing the target, we return 0. So that way, I mean, we don't want to keep looping. Like when we store here, we're gonna add 1 to our best result. But what we're gonna do is, if the matrix at the specific row and column is less than the target, then we want to. That's also a base case. If it's greater than, what we're gonna do is we're gonna return 1 plus like our best result, right? But what we're gonna do is we're gonna loop through our neighbors, so we're gonna get, or we're gonna also store our cache here, or our DP array. But if row column in cache, return cache row. Is it making sense so far?
Yeah, I think this will actually work. I think this is fine. I was gonna ask about like the target. Do you need it in the cache or not? But I think this works. Yeah, I think this works.
Or like we could even be smart with how we loop into it. Like we might not need to do this, but we could just like loop only if the conditions hold. So we can be like we can grab our neighbors. We'll just define some array here. Like row column. So we can look up, down, left, and right. So we'll go up, we'll go row minus 1 here. To the left is here. Down is here, and then, so we can look up, to the right, down, and to the left. So we can do for name row, name column in the neighbors here. Maybe what I'll do is I'll just add these. I won't add these in the base case. I just won't recurse if they're not in there, so I don't have to pass in the target.
Yeah, that's fine. Well, let me ask you just like a side thing, see if you know this one. So if you did put the target in the cache as well, if it was row column target, what would be the space complexity there, do you think?
If I had the target in there? Well, like the target is gonna be changing, right? So it's gonna it's gonna basically turn into like a 3D DP question because the cache is holding 3 parameters.
So if I'm on a cell, like let's say I'm on
where are you? I'm following you now.
Okay, yeah. Let me scroll down. So let's say we have this test 1. Like let's say we're on this cell. What can the target possibly be?
If I'm on 9? Yeah, we could have came from 0, we could have came from 4, we could have came from 9. So we could.
Right, so how many values can the target have?
Maximum 4.
Yeah. So what you're doing is fine, and this is like probably the approach I would take, but if you did actually store the target in the cache, it's important to recognize in these DP problems, it can't just be like any value. So it's not going to be like 3D DP. It'll be like row times column times 4, which will be basically the same thing.
I see. Okay, so it's not like it's not messing up the space too much. Like it's still the same space.
But I would take the same approach you're going with now, so it's totally fine. So
okay, cool. So if the neighbor row right here, Jan was good. No, we'll continue here. We continue here. So we say if the matrix at the neighbor row and the neighbor column is less than or equal to target, we just continue to. We don't want to go through that.
Mm-hmm.
Otherwise, what we're gonna do is pretend there's no longest path, like they're all 9s. Is the result still 1? They're all 9s?
Yes.
Okay.
Should be 1 for that, yes.
So what we're gonna do is we're gonna do best result float negative infinity here. So what we're gonna do is best result equal, or what we're gonna do is like the max or the best result here. But eventually we're gonna return that here. But what we're gonna do is we're gonna do we're gonna actually store in our cache the row and a column equals to like the best result if we start from our neighbor.
Mm-hmm.
Something like this. And actually, we're going to want to store this in a tuple. Cache it here. So, okay. How do we do? And then we're going to call the DP here. We're going to do DP. And we're going to pass in the matrix, the neighbor row, neighbor column, and the cache. So, yep, that's going to do the recursive function for all the different neighbors that are valid. And then we pretty much just need to do the same thing here. So we just pass in well, we don't have target here anymore, but what we're going to do is instead of target, we say matrix row column. So matrix here, we're going to pass in the row column, and then we'll just pass in like an empty. I mean, do we care about the cat? Or I'm just wondering if we need to keep the cache out here. I think we need to keep the cache, a global cache across this whole iteration. Because if we, because if we store the results.
Yeah, like what would happen if you initialize the cache here? Like if you just say like, every time I call DP from down here, I'll make a cache. What would happen?
Then like the cache will get cleared for every iteration we waste, like pre-computed results.
Yeah, exactly. Yeah.
So matrix.
Yeah, so every time you go through the matrix, you're gonna build the whole thing again.
Mm-hmm. That's gonna be a waste for sure. So we have cache right here, and then I think literally this code might work.
Okay. Yeah. Yeah. Let's not focus on running it on LeetCode. Let's just see how the examples go, and if the examples are good, we'll call it there.
Key year 0, line 52. If the row column in cache, okay, cache. Negative infinity. What did we maximize here? Best result. Maximizing here. Okay.
Yeah. So can you see what could happen that would be problematic?
Okay. Let me look through this code. So we're looping for every row in the matrix for every column. We're doing DP on our matrix row column. We're passing in our cache. The result, assuming the maximum is higher than this. Yeah, like if it even can't, like if it can't get any of them, the float will be negative infinity here. So like let's just say 0. So
Okay.
that's the worst case. 0 means you can't like we are at one element, but we can't get to any of the neighbors. So that's gonna be 0.
Yeah, makes sense.
Nice, cool. That returned 5.
Okay, so let's try a couple more. Let's try example 2 and maybe some other things that you could think of that would be like tricky, I guess. And we can
What about that? How's that? That makes sense. The solution there, like
Yeah, no, what you said makes sense. Yeah, so let's try example 2 and let's see if you
okay.
can come up with anything else that is like, or let's try the rest of these, I guess, and see if you get the right stuff.
Let's
And
do.
then yeah, if you could think of some other thing that you didn't test for, that would break this, then that would be good.
So if we do this breaks. Okay, that returned 4. That's good.
Mm-hmm.
Just like, I mean, we could start result at 0 here instead. Like if they give us empty.
Yeah. Yeah, that's the other thing I was going to say that would break is if you pass in an empty matrix, your stuff would break. But I think this handles everything now. So. Okay, yeah, cool. Okay, yeah, so what do you think about that one? I don't, like, it's, like I said, it's a hard on leak code, but I don't think it's, like, that difficult, so.
Well, yeah, I think that was a interesting one. Yeah, it was, I think it made it easier that it has to be strictly increasing for sure. So.
Yeah.
But yeah, I think it's definitely it's a good question for sure because you can't just backtrack it. I'm pretty sure TLE.
Yeah, with TLE, yep.
But yeah.
So you recognize that like backtracking wouldn't be the best because you can't have a loop. So yeah, exactly, and you can cache results.
Yeah, like the part that I was thinking about is okay if we do DP, the one thing too though is like we also need to know what elements were used. Because if we store a cache, right, the longest that it can go from there. Like it also took some path to get that result. But the reason why it's strictly increasing is the main reason. Yeah, I already knew it was DP, so that's the thing.
Yeah, so maybe if I didn't say it was just like you can do whatever you want, then maybe someone could land on a backtracking solution, and then I'd probably have to say like, can we do better?
Yeah.
Because backtracking would work, obviously, but
it'd just be super slow.
It would be exponential, and if the matrix is big, yeah, exactly. Let's
Yeah,
try.
I think it's a good question. Like it's different because you have to loop through each of the indexes and try to go from there. So.
Yeah.
All right.
Let's try one more. Let's see how this one goes.
How long was that? 24 minutes.
Yeah, no, I do think that's like a pretty solid medium. If I had to rank it, I don't think it's that difficult. Honestly, this one's harder, and this one's a medium as well. So, in my opinion, anyway, we'll see how it goes.
Okay. So we're given a set of distinct thoughts on AlgoMap. What's AlgoMap? Never heard of it. Okay, let's read this though. Alright. We're given a set of distinct positive integers nums. Return the largest subset answer such that every pair ij of elements in this subset satisfies this. Answer I. So for every I and j, if you mod them, you get 0. The values. Like either one, like this one divides j perfectly or j divides I perfectly.
And there was also a daily problem like a few days ago, so if you've done it, we can do something.
No, I don't do the daily problem.
Okay.
I should probably start, but I'm lazy to do those.
I mean, it's not necessary. Like unless you're like making videos on them, you can do whatever you want. It's not like it's better than something else.
Okay, so we're given there are multiple solutions, return any of them. So 1 and 2, give us. Okay. This is interesting. So the largest subset is 1 and 2 because 1 mod 2 is equal to 0.
2 mod 1 is equal to 0.
2 mod 1.
So it can be one or the other.
1 and 3, like return the largest subset answer such that Like here, what I'm trying to figure out is why is it not, like why is 1 in 3 not there? Isn't, if you do 1 mod 3, that equals to 0, isn't
Yeah, so
it?
they tell you one and three is also valid.
But why not 1? Oh, okay. So the output can't be 1, 2, and 3 because 2 can't mod 3.
Yeah, exactly.
2 can't mod 3. So what I'm thinking is, that is a good question. Let me think. Like at a high level, this is what I'm thinking off the. Like, it's a bit skipping ahead, but what we're gonna like, what I'm thinking is we want to be built. Well, first off, what's the brute force?
Mm-hmm.
I mean, it would be brute force would be generate the subsets, like all the possible subsets. That's already pretty inefficient. O2n.
Oh, I see. Literally make every single one. Yeah, you have to make every single one, and then you also have to double check them for validity.
Yeah, and then
So
like
it'd be like O2 to the n times n or something.
yeah, exactly. Validate each one.
Mm-hmm.
But
Yeah,
what
definitely not an acceptable answer. Yep.
Like what I'm thinking is maybe there's a solution like this, like where we like hypothetically try to extend some subsets. So we have like some subsets where we know the length of those subsets, and we have like some hypothetical subsets. And then we know like some hypothetical subsets that are like that are marked by something. Either like it might be some value that encapsulates like who can extend this subset, right? Subset and size of the subset. So pretend we have one. We have no subset, so maybe we can start a subset with just one.
Mm-hmm.
As a count of one. Then we see 2. I mean 2. Which subsets could it extend? It could extend probably this subset. And it could start its own subset too. Something like this. Then we still have 1.
Mm-hmm.
So 3 comes in. 3 could pretty much extend this subset. It'll create its own subset with 3. But it'll be a size 2. Then it's kind of like the max of what we see there. Like what we can do is we can try extend. Like we can add it into subsets. Let's see. Yeah, something like that. But then pretend there's a 6 that comes in. Like we'd want to, the answer would actually be 1, 3, and 6. Or like pretend there was 9 instead. The answer would actually be 1, 3, and 9. So what I'm thinking is that's sort of my intuition for the problem.
And so let me ask you, like, so when you're saying like 6, like how do you know where you can add the 6? Like how did you know you can add a 6 here? Like what are things you consider, I guess?
Probably what I would consider, one thing is maybe the largest value in there. If it could divide that.
I see. So you have like an increasing subset, and if your new number can divide the largest value, then you can add it in. And why is that? Why like if I had an increasing subset and my subset can just divide the largest value, how do I know the rest of them would work as well? Can we have a counterexample, or does that just work?
There might be a counterexample because if the largest value is 9, pretend the largest value is 3.
Mm-hmm.
No, that might just work. No, it might work if the largest value can divide my largest value or something like that. Or like pretend I'm looking at 9.
Mm-hmm.
Like if something could divide 3, it could also divide 9, I'm pretty sure. Because then you could just multiply it out by 3. It's like some math there that might make it work. Like if something is divisible by it can divide the multiple, then it could also divide. Like if 9 is divisible by 3,
Mm-hmm.
maybe from transitivity, I don't know, if 9 is divisible by 3 and something divides 3, I mean, you could just divide 3 times. Like it could break this up. Like if it can break this up into like what into terms, like you know what I mean?
I see what you're saying. So if you had a 9 here, if 9 can divide the 3, the 9 can divide the other numbers because each number is a multiple of the one before, I guess.
Or yeah, like well, if the largest element here can divide the new number we're bringing in, all of the numbers under it can also divide it. Yeah. Because it'll just divide 3, and then like it'll do that x more times.
So if we tried to add another number here, like what would we check for?
First we'll sort these elements. Sorry. We'll sort these elements. These nums. But the number that we're gonna try to extend is like 3.
Like what's a possible number we can add? Like let's say we have this array. What's another number we can add after this that would work? Like how do we know exactly?
18.
Yeah. Okay.
Yeah.
So because it divides 9, it divides the other numbers because each number is like a multiple of the one before.
Yeah, exactly. I think that would work.
Let's see. So if we go with this approach, like let's say we're just keeping track of subsets. First of all, do we need to know like what is this, the count or the length of what does this number represent? The length, I guess.
The length, yeah, the length. These are the lengths, so this would be 3.
Okay. And so your approach is like once I'm on some number, I'll just try to extend every subset I have by checking the last number. So like let's say we have like a big array and we're close to the end. How many subsets can we have already? Like if we do that approach where we just take our number and we just check like does it extend every subset we have? Like what would be the time complexity for that?
Well, we can just check our multiples. Like wait, let's see.
Right. But for every subset we still have to check the number, right? So if there's like 1,000 different subsets here and we're on some number.
Mm-hmm.
Like let's say we have 1,000 numbers and we're on number 1,000. How many subsets can we have already? Like can we have 1,000? Can we have way more?
Yeah, we can probably have like 1,000 if we just choose really like a bunch of prime numbers, something like that.
I mean like worst case. Yeah.
Can you repeat the question? I'm a bit confused of what you're asking.
Yeah, so if we just have like a bunch of numbers here, right? Like 1,000 numbers, and we're on one of the last ones, and our strategies for every number, let's just compare it to all the subsets we already have. Once we're on this last number, like how many subsets can we have already?
Well, we're not gonna like what we're gonna store is like if we can extend multiple one, we can have as many subsets like
I guess let's just walk through like the dry run for this case, for this 1, 2, 3, 9. Like how would this work?
Like
how many would we?
What I'm saying is it could either be exponential the amount of subsets if we're gonna store every single one of the subsets, or it could just be if we find a smart way to remove subsets once we extend it, it could just be like O of n size to look.
Yeah. So is there a way we can make it like with this example? Let's try to figure out a way to not store every subset, because here like we can have 1, we can have 1, 2, we can have 1, 2, we can have 1, 2, 3, we can have 1, 3, and so by the time we get to this 9, we can have more than 3 subsets, right? We can have like some exponential amount if we store all of them. Like 1's a subset, 2's a subset, 3's a subset, 1, 3, 1, 2. You see what I'm saying?
Yeah.
It's not like linear. So how do we optimize that?
Wait, sorry, could you repeat that part?
Yeah. So for example, like if we just store all subsets, like 1 could be a subset, 2 could be a subset, 3, and so on, right? 1, 2, 1, 3.
Yeah, that's exponential for sure.
So by the time we get to the 9, there won't be 3. There might be, like a lot. So if we take that approach where if we just, even if we're only comparing to the last number, if we compare our 9 to every single subset we've made to see if we can extend it, that's still going to be exponential, where essentially for every number we have to compare it to some exponential. So that might be like n cubed or some whatever. So can we optimize that where we don't have to compare it to every subset?
What I'm thinking is like if we could extend one, we can delete the other one too. So pretend, let's start with 1, 2, 3. Let's start with, let's say maybe we have a hash map. And then first we have 1, and that gives us, I mean, that doesn't work because it needs to be returned large. Like, does 1 just work? Or if 1 would return 1, the subset of size 1. I mean, it needs more than 2 elements, right? At least.
It can be 1, I guess, technically.
Okay. So we have 1.
Like if we have an array of 1 number, we'll get 1. So yeah.
Okay. So let's like loop through this right here.
Mm-hmm.
And this is one where I can't think of a top down right off the bat. So if we do 1, pretend we have 2. For 2, we could extend. If we have 2, we could extend. We could extend 1. But how do we know that? Well, we could loop through all the answers here. And then we can go 2. 2, we can, for 2 we can get it to 2 elements, right?
Okay.
Oh no, but we need to output. Do we need to output? Oh, we just need to output the size. Okay.
No, we need to output the whole subset. But let's say we only needed to output the size. How would we do that? Like, let's change the question a little. Like, if we just needed the size, maybe we can do the subset as a follow-up.
So if we need to output the size, we do 2 and 2 right here. When we have 3, we can loop through the values here and see which ones we could extend, and then we can add 3 and then 1 here.
3, 1.
Or sorry, 3, 2, because we could extend 1, but we'll try to extend like the largest one that we're divisible by.
Okay.
Then when we get to 9, but yeah, it will be like a O of n squared algorithm. And we do for 9, right? Who can we extend? Well, we can 3 can divide us. So if we add 3 there, or we can get to like 3 here. Right? And then we just return the maximum of this. But we'd still have to loop through all these values.
Right, so what would be the time complexity of that?
O of n squared, pretty much.
Yeah. I think that's good. And then, so I'll give you a small hint because we've only done top down. So for rare problems, bottom up is actually better. So whatever you prefer, I guess.
Oh, for array
Most
questions,
of
you're
the
saying?
times-
For array
What was
questions?
that?
Array questions, top down
Not
is
necessarily array, but kind of like with this approach, for every number, you're checking your output you built before. So if top down makes sense, you can do top down. But in some cases, bottom up like just intuitively makes more sense, which I would argue this is one of them. So, but if top down's easier, we can do that as well.
Yeah.
So yeah, I guess
Does
bottom up is literally just like, you build an output like you were saying, like basically what you described. So
do you think this solution is gonna work, or we're going the right direction here for O of n squared? That's we can.
yeah, no, I think this is literally the solution. Yeah, so I think it would work.
But this will just return the size, right? Not the actual output.
Right. So I'm saying let's code the size and let's do like a follow up.
Okay.
The actual thing.
Okay,
Yeah.
sounds good. Yeah, this is a good question. Is this medium?
Yeah, it's medium, but I'd say this one's harder than the one before. For sure.
Okay. To get subset size. We're given nums. We're given a distinct positive nums. Return the largest subset answer. Okay. So what we're gonna do is we're gonna be given like we're gonna have a path map. This is the same or subset map, and we're just gonna return the largest value. We're gonna store the longest or the largest value of each one, and like the size. Maybe we can use a default dictionary. Or no, let's just do this for now. But what we're gonna do is like for num in nums. Like I said, we're gonna sort nums first. That's important part. So we're not. That just helps us like we know. Like pretty much, it helps us get into allow us to just compare. Like when we're looking at a value, we know all the subsets that we're trying to extend are less than it, so we could just do one equation there.
Yeah.
So for num and nums, what we're gonna do is like if we're gonna also loop through all the elements in this subset map. So all subsets equals dot keys, I think.
Okay.
So this is going to return the elements in the subset, like 1, 2, 3, 4. Sorry, let me just list this out. So now we're gonna loop for num in nums. What we're gonna do is like, is it actually is for subset key in is divisible. We're gonna take the subset key, which should be an integer. Hopefully, let's see.
Yeah, I think it just stores as a key in Python or as an integer already in Python, even if it's a key. So I think you're good.
So we're going to say is divided by the current num equal to 0. And we're gonna have our best result here. We're gonna try to maximize it, right? So 0. If it's actually divisible, what we're going to do is we're going to do best result equals the max of the best result here. And what we're going to do is we're going to grab all subsets. That subset key plus 1, because that's like I'm extending it.
Mm-hmm.
And then we'll say subset map equals the best result. Subset map of none. Something like that. So we sort the nums. We're looping through all the keys. So let me just walk through the example and then I'll try to catch anything breaking in my code here. But what we're going to do is we start at nums equals 1, 2, 3, and 9 here. And let's start empty here.
Mm-hmm.
So we start at 1. Now it's sorted for num and ones. If for all subsets, there's no subsets. So it doesn't even loop through here. So 1, the best result should actually just equal to 1 here. Right. So we're trying to maximize.
Yeah.
So 1 equals 1. Okay. And then when we get to 2, for 2, the best result here, we're gonna loop through all the keys. So it's gonna loop through 1 here. So is 1 divided? Can 1 divide 2? Yeah, that's divisible. So we could extend here. So if we print the map, we should add like 2. Should be 2. So let me print the subset map. Let's just see if it it creates the right subset map. Print sub. Alpha, you still there? Or your dog?
Nah, yeah, I just have dogs in the background, so I muted my mic. Still there. Okay, so do we have the right thing? Not quite.
Subset of num equals the best result. All subsets of the subset key. Okay, let's print it for each iteration.
Sure. Like, I think you're on the right track. You just have some syntax stuff.
1, 1, 2, 1. Okay, when we put 2, if the subset key, let's just make sure it's actually going into here. It should in the first one. Okay, it's not. So if the subset key mod num, what's the subset key here?
Yeah, I think you'll figure it out from here.
1 divided by 2. There's no remainder supposed to be.
You did 1 divided by 2 instead of 2 divided by 1. So you just need.
Oh yeah, you're right. Yeah, 1 divided by 2 is 0.5. That's the remainder.
Mm-hmm.
The keys are not.
You have a comma here.
Oh yeah, you're right.
I don't know if you have anything else, but the keys is not subscriptable.
Oh, also. Oh, I just need to turn this into a list.
So you can just do for key in dict. That would give you all the keys too. You don't need this.
Okay, like this, right?
Yeah, and you get rid of that complete. So subset maps just be your map.
Yeah. Okay. This one. All subsets not defined. We just just fix this.
Yeah. Okay.
Oh,
Yeah, you can just iterate through keys. Okay. Okay, I think we have the right thing now, right?
Yeah. Returns the right result there.
Mm-hmm.
So what I do is actually we'd have to do some copying.
Yeah, so what are your thoughts of how we can get the actual path? And we can't, remember what I said, we can't store every subset because there's just way too many. So how can we kind of efficiently build a path?
It in here.
I think your stream's like lagging in your.
Oh really? Am I?
Yeah, stream is like frozen. Yeah, I think
Wait,
stream's
let me check,
frozen.
let me
Your
check.
voice is lagging.
What the heck? Okay, give me a second. Stream, is everything good? Probably tweaking. Yeah, stream rate. One sec. Like, this Wi-Fi is trash out here. Okay, it's lagging. Okay, give me a sec. Let's wait until it's good. Good thing I recorded this too.
Yep.
See if it's still live. I'm gonna pause the recording.
Seems like it's live to me.
You can join my.
You get that guy too?
Yeah, I get a lot of commercials. I noticed that if you have like ad block, I don't know if YouTube does or something, it like turns it off. I mean, I don't know how ad block works, but yeah, I noticed when you go on like YouTube, like your ad block will just get turned off. Like
Interesting.
they can do it, I think somehow. That's kind of funny. But I think you're good now.
Everything good now? Okay, how's my voice now?
That's good.
Let's see. Sick. Okay. Let me start the recording. So what I'm thinking is maybe we store the subset here. Like in a tuple, we say this is 1. When we store 2 here, we figure out a way to extend it.
Yeah, so is there a way we can like not store the whole subset everywhere? Because they can get really long and we want to store them everywhere and that would also be expensive. So is there like another way we can kind of store like what's the minimal information we need to be able to build this?
What if we just store who we extend? So we extend 1. Then
Yeah,
we could just
exactly.
we could just like rebuild it after.
Exactly. Yeah, so let's go with that. Where like we just keep storing who we extend and then we
Yeah.
rebuild at the end. Yep.
Holy crap. Okay, this question is good. So if we like extend 2 here, like pretend
Yeah, I think this is a pretty good question to be honest. And this is a medium, so yeah, I
That's a
don't
wild
think it should be a
medium.
medium.
So what we'll do is we'll say it'll just be tuples and we'll be like we'll extend nobody like this ourselves.
Mm-hmm.
This one will extend 1, like our largest. Here we'll extend 1, which is our largest. Here we'll extend 3.
Yeah.
And then when we
then
build,
how would we rebuild?
probably we'll just like keep following it. We'll be like, okay, this is, we start with 9.
Mm-hmm.
Start with 9. We could return the list in any order, right? 9. And
I mean, you can just reverse. That doesn't matter.
That's true. We grab 9, and then after we grab 9, we grab 3 here, and then we get the element 3, and then we grab who this extends, which is 1. So we get that. Like we just do a while loop.
Mm-hmm.
So best result. But here we need to store the best result is gonna be equal to 1. Like none, something like this.
Mm-hmm.
Let's see. 1 none, and then so the best result equals if and let's see. Okay, we just need to extend this part. So the best result is a tuple now, so we can't just do this. But we can clean this up in a second, but I'll add a second loop. We'll say if the subset map or maybe we'll just start this with like 0. But the best result is 1. Oh no, we can do 1 here. But if this result is greater than or equal to, or if it's less than equal to, like we don't want to extend it if it's not best than our best result. Right?
Mm-hmm.
Otherwise, we'll do best result equals, what we'll do is subset map here.
Mm-hmm.
And then who did we come from? We came from this subset key. And then we'll store that in the best result here. But now we need if the subset map subset key. And then we just need to best result 0th element here.
Mm-hmm.
So we're comparing the values, then we're good. Let's see how that prints out. Print subset. Still none here. Subset key. If, okay, let me figure this out. If the num, so we're looping through numbers and numbers here. We're given the best result 1. We're given none. If we're looping through the subset keys, which is 1, 2. If it's divisible by 0, if the subset map, and then we grab the subset key, we grab the 0th element. If it's, let's say if it's less than, oh no, we're not plussing 1, are we? Best result?
No.
Yeah, we have to best result. We have to add 1 here.
Okay, makes sense.
I think that should work. Damn, there's like an off by 1 here.
Mm-hmm.
Is it less than? If I trace it, it'll probably work. But okay. Let's see. Where did that fail?
63.
Subset. Oh no, it's up to 0. See what I'm doing here? Okay, there. Now that works.
There, yeah, nice. Okay. No, yeah, I just didn't want to look into it too closely. Like from here, it's basically just like debugging. You get the idea, yeah.
So what's our best result? Print subset map. Our best result. I mean, let's just find it. Or best. Let me think about it now, because now we just need to rebuild the subset.
Mm-hmm.
I mean, we could do one pass to find the best result, and then like do a while loop.
Yeah, exactly. Like we could just find where to start from and just kind of do like a chain.
Yeah, so we can best result. I mean, we could store that here too. We can just store.
I see. Have another
Start.
variable.
Start is equal to like none and none. Or
Okay.
we'll just do like float negative infinity and none.
Mm-hmm.
So we'll say if the best result, like the 0th index, is greater than start at the 0th index,
Mm-hmm.
we'll start from this one instead.
Yeah, that makes sense.
Then we'll just like print start here. We could like keep 3 and 3, and we'll say while start.
So we need the key as well for the 3 and 3, right?
The key.
Yeah, like because the key, or you got 3 and 3, but what value was that? Like you need to know that it starts with a 9. Or you
Yeah.
could compare values or something, I guess. You could do
That
that
makes
too. You could
sense.
like say like this is the value I need, whatever key gives me that. Let's go with that. Yeah.
But okay, if we're given 3 and 3 here, that doesn't tell us much, just the value and the actual key there. Then we need to store another value in here. Result.
Yeah, we need to store the key.
Yeah, best result. The num here. Num here.
Okay.
I have to keep running this one, 3, 9.
Yeah. Okay.
We'll have a result.
Mm-hmm.
We'll return our result, and we'll say while start 1 actually exists, we'll do result dot append start the value start. So the second index, we'll say start equals subset map What are we storing in the subset map? The keys. So
Yeah, I mean, I think if you just traverse through the keys, that will work.
start 1 like this.
Like 9 will go to 3, will go to 1. So you just start can just be the key. 9, 3.
Oh wow, start is. Oh no, because it's off by 1. Then we'll just do start at 2.
Okay.
That just captures like when it dips out the.
No, yeah, I see. Yeah, okay, looks good. And then you just reverse. Yeah, I think the actual problem asked for the numbers in the same order as in the array, but that's like 2 more minutes of code, so we don't need to do that because all the numbers are unique. You can just store the index or whatever. That
Oh,
part,
okay.
who cares?
Nice. Reverse.
Okay, yeah. Okay.
Yeah, that was actually low-key hard. Let's see, 139.
Mm-hmm.
That's they're different than the DP ones I've ever did.
Yeah, so that's what I kind of wanted to do this one. So I was either gonna do this one or like a regex. A regex is top down, but it's just like pretty complicated to get all the edge cases.
Mm-hmm.
So yeah, so for some problems you will realize that like bottom up just makes more sense. Like I'm just like iterating backwards or something. So then bottom up makes sense. Also, this one there's the tricky part of like rebuilding the path, which is pretty rare.
Rebuild the.
Like they don't just give you a number. So yeah, usually the way to rebuild the path is you figure out like what's your end, and then you cache everything else, and then you just do like you basically do like a DFS or whatever, like
Yeah.
towards the front. So that's how you would do it. So there are some problems they ask you that where they're like, don't just give me a number, give me the entire path of like the best thing, and that's how you do it. You like split up in 2 parts.
Damn, I need to do this question. Any advice on how did that session go?
Okay, so let's see. So the first one you were able to do basically no hints, I feel like, which is stuff you've done before. This one there was a lot of new stuff thrown at you, right? Bottom up you haven't done, and rebuilding the path. I feel like with the hints you were able to do it. I think this is honestly a pretty hard question. Like I said, it's a medium, but I think if you've never done bottom up or not often and never done this kind of thing, I wouldn't expect you to get it. So I'm pretty happy with what you did with the hints, and I feel like if you see it again, you can kind of be like, oh, I've seen this kind of thing. The really common question you get asked is like longest increasing subsequence.
Yeah.
Which is kind of like this, and then you would also do that in bottom up, because it makes more sense, and you kind of do the same approach. You don't store the entire path; you just store like, what am I building off of?
Nice.
Yeah.
Yeah. No,
So,
there was a bit of math involved too. It's like the divisor thing. I had to do a little bit of thinking for that.
Yeah, that I feel like if you just do enough leak code, all the mod stuff you just learn. Like I learned like modular arithmetic, all the like tricks. Yeah, like you're gonna be pretty good at that if you just do a lot of leak codes. Like I don't think it's like advanced math or anything. So
nice. Yeah. No, thanks for that. That was a really good session. Let's do another one like next week, or we'll just go even harder.
Yeah. So I think probably I'll just get some like really hard ones.
Really hard.
Yeah.
Where do you?
So the problem. So a lot of the problems is you will just not be able to figure out the state, and if you can't figure out the state, then we're kind of stuck. So I'm going to avoid those, but I'm just going to find ones with a lot of edge cases. Like the regex one, for example, has a lot of edge cases.
I see.
So that's a pretty good one.
Nice.
But yeah.
Where do you think I'm at with the DP? Could I pass a Fang?
Yeah, I don't think they're going to ask you this kind of thing on Fang. Like,
this one's too hard.
They'll ask you like coin change or whatever, or any of those, and those you can do fine. So I think this is like more advanced.
Nice. What about for advanced? Like, is this a pretty hard one or not? Like, or there's even harder ones?
I'd say it's a pretty hard one. Like I said, the harder ones are this. Basically, the way DP gets hard is the state gets really hard to figure out. It's not something obvious. It's not like an index. So those are the hard ones, and also some, you have to optimize space or it'll get TLE. And those are like that. That's like the really hard ones.
I see.
Yeah, pretty rare. I don't think you get asked. Like, even if you know how to do it, the time it takes to code it, even if you know how, it takes, like, too long for an interview, in my opinion. Unless you're, like, a competitive programmer or something, so I don't know if they're, like, testing that. But, yeah, I think this one is kind of probably the hardest I'd ever be expected to get asked something.
Nice.
So if you can do this one, if you can, like, redo it fine, and so it's pretty good.
Cool.
Yeah.
Yeah.
All right.
Cool. Thanks, Alpha. Let me know. Yeah. Just message me when you want to do stuff on your side too. If you want me to do more front end on you or like.
Yeah, no problem. Like... Yeah, we can definitely do some more in the future.
All right. I'm gonna stop this video.
Later.
All right. Sounds good. Talk to you later. Peace. Legend. Yo, chat. How did I do? What do y'all think? Higher? Weak higher? No higher? Lean higher? What's the chat saying? Everyone drop their ratings in the chat. Alpha, what are you giving me? A lean higher, higher? 4 for sure for the first. What about second? Strong higher? Nice. Yeah, I just need to keep practicing DP. Those math, I'm getting a little bit better at those math ones. I don't think I could have solved this question a month ago. This is a good question. Okay, for our next session, we're gonna be working with a student to build their course. Largest divisible. Have I done this question? Okay, how would I do this? Return. Let me just like add my code here and see if it works. Yeah, I'll add that code real quick. But it doesn't say that, right? Why does it say keep them in order? Oh, it's good. Yo. Alright, this is good. This is good. Alright. That was fun. That was fun. Everyone should go try that question now that you see the thought process on it. Rafi, what do you think? That's that's harder medium than I've seen. I've seen easier hards in that question. It's not here. Yeah, if that was an interview, that would be crazy. Okay, let me get on the next caller on the chat. Yo, everyone, at 3 PST, I got my YC friend coming in. 3 p.m. PST, so we're gonna just chop it up with one of the guys. Who's, he'll introduce himself. Yo, next caller, hop in, hop in. Sick. Yo, what's up, man?
Yo, what's up?
Yo, can you hear me?
Yeah, I can hear you. Can you hear me?
Yeah. Chat, everything, y'all can hear him? Let's see. Yo, chat, everything good? Let me check on my own thing.
All right, bet.
You can hear him? Sorry. Chat, everything good? Wait, can you say something? Yeah, we'll be good.
Hello?
Alright, perfect. Alright. So what's your background again? You're in school. We need to figure out what courses you want to let's talk about what we want to do with this session. We have 45 minutes to like iron out everything, answer all your questions. I know you had a bunch, so might as well just do it in one shot.
Sure.
Just give me context, and you could anonymize it and stuff too. Like we could just talk in.
Yeah, sure. So, I'm currently a high school senior, and I'm committed to college next year, and I'm basically just trying to figure out how should I obviously college will be very different because I'm living on campus, and I'm trying to figure out like how can I optimize my day to make sure I'm like doing all my work and like which courses are relevant and like which ones will help me like like with jobs and like which ones will it's like I don't know. I'm just like I have like a lot of questions. I'm also a little nervous. I'm not gonna lie.
Yeah, no. This is perfect. Perfect. So you're committed to college.
Yep.
Is it like a target school or non-target school? Because that also will inform what we need to do here.
I'm pretty low income, and I got a full ride to Northeastern, so
Wow.
I'm committed there.
Nice. And it's a pretty good. How's the comp sci program there? Or what did you get into?
Undergrad, I think I got into CS and math double major.
CS and math.
I think they're. Yeah, I don't know like exactly like how accurate the ratings are, but I saw it wasn't terrible for CS.
Okay, CS and math double major. Is it a party school or not? Because if you're living on campus, it's gonna affect your study plan. Do you party?
I've heard like there's parties on the weekends. Yeah, I go out sometimes.
All right. Okay. So it's a party school. Like if you went to USC, you'll be partying like crazy. You might not even have your weekends to even study.
Right.
Not really, but okay. What's kind of your goals? Because I mean, you're still a high school senior. Why did you even want to take CS and math?
Well, I mean, I live in Silicon Valley, so hearing like from my friends and my dad, like obviously like CS is like a very lucrative major, but also yeah, I've been interested in video games. Like it's obviously like, or it's like stopped a little recently, but I still like very much enjoy computer science. I've taken AP computer science, like the Java one at school, and then I've also taken a DSA course in my school, and so I know like a little bit about CS, and I've really enjoyed it. So I'm definitely looking to take a few more classes in college and stuff.
Okay, you've done leak code questions?
Not really. I mean, honestly, I've done like I wanted to start doing leak code, but I tried a few problems and they were like a little difficult for me to understand.
I see.
I mean, the homework that I've done for my DSA course is usually like we learn like an algorithm or like a data structure in class, and then we implement it using like different like things that we've already done before. And so like solving like these leak code problems was like definitely like a step in like a different direction. It was a little hard for me to grasp it.
I see. Okay, let's see. You're taking at AP computer science, so you have some fundamentals. You know, simple while loops for like syntax.
Yeah, yeah, definitely. But I only know this in Java, and I feel like a lot of people like use Python or like C++ plus plus or some sort of other language. So I'm also debating whether or not I should learn a different language.
I think you should definitely learn Python for your programming interviews. I've just seen if you're gonna switch early and before you start leak
Mhm.
coding, learn Python. Python is, I mean, all machine learning languages. Like if you want to get into ML, it's
Yeah, I was
Python.
definitely thinking.
Like every company's requires some Python knowledge. I feel, especially if you want to do
Mhm.
like AI. Even hedge funds, if they're not using C++, they're using Python. Every company
Okay.
uses Python to some capacity now. I don't know any company that doesn't because of AI. So yeah.
All right, I see.
And like if you're gonna do coding interviews, I've seen just really good engineers fail their interview because they had to use Java and they just get slowed down. So I would just make sure to use Python like right off the bat. Learn Python.
Okay. Yeah. All right. So
Yeah. What's your
I mean,
questions?
the thing. Well, yeah, because I obviously am interested in CS, but I also really, really like math a lot, and I
Hmm.
was debating like whether or not I should try and get like some sort of like get in like invested in quant or something like that. But I heard it's like very hard to get into, and also I don't necessarily go to like a target school for quant, so I didn't know if it was worth it to sort of shoot for it or if I should just try and stick with CS.
I think it's possible to shoot for it. Well, with quants, first off, you just need to make sure you pretty much have a 4.0 GPA to land the interview.
Mm-hmm.
And if you have you have the CS and math background, I think you'll be able to land interviews. Like I landed interviews at a quant before, and so have my
Oh,
friends. So it's possible to land the interview. It's more about just passing the interview. So if it's an option you want to
okay.
go, it's doable. I know people who worked in quant, and usually they're good at math. Like the ones who got in,
Yeah.
they're pretty good at math, or have done math
Yeah.
competitions.
Yeah, I haven't actually had the opportunity to do any math competitions, but I've been like studying a lot just by myself recently, and I've really been enjoying it.
Like what do you study when you're studying math?
Uh, like I've been reading like textbooks. So I read like a linear algebra one a month
Wow,
back, and now I'm reading like a differential equations one right now.
wow.
I'm taking a discrete math course at community college over the summer just because it's required to like for CS obviously, and it's also required for math because you need to know how to like formulate proofs.
Hmm.
But yeah, I mean, I honestly I feel like I've talked to a lot of my friends about it, and because like obviously I'm a senior and my friends are seniors, and they're just like they don't really like do that much. And I was honestly confused because I was like, oh, if you're going to college, like why would you not try and make use of all of the resources and like take difficult classes? And then I don't know, it was a little interesting.
Yeah, or what? They're not using what much? Like they said, they're not using math
Like,
much. They're not.
they're- well, they're not like I feel like when you go to like college, like shouldn't like the idea should obviously like oh have fun and try new things like obviously, but
Yeah,
like I've also been thinking like I kind of want to take like difficult grad classes just to like learn a lot as well, so I can be prepared for like these sort of interviews.
don't. Yeah, for sure. I would say what you should do is literally take if you're if you know you're interested in math and comp sci, and you're only interested in math and comp sci, there's no point in like taking options that you know that you're not interested in. Like
Yeah.
when I took my degree, I think I took like 26 comp sci classes, and I like
Mm-hmm.
four math or five math. Like most of my degree was straight just comp sci math classes, or like
Yeah.
I didn't take any options. I took the minimum like three or four options. So
Yeah.
I enjoyed it. I liked school because I liked all the classes I was taking. So I think what you should do is try to make it so that you try to have your schedule set up so that you can take as many of the advanced courses as you can. And in order to do that, you need to make sure you hit the prerequisites as fast as you can. Because for the higher level courses, right, they usually require some prerequisites. Maybe databases requires Java,
Yeah.
like the first two comp sci classes, right? And
Mm-hmm.
maybe a third one. So what I do in the first one in 1 year, like your freshman year, literally try to look for all the courses that are prerequisites to those advanced courses and try to get them done as fast as you can. Like do not
Right.
stretch them out. That way it frees up your last 2 years for taking all of the advanced courses. That make sense?
Yeah. I agree. No, I understand. I think with their math department too, they're actually very relaxed with like being able to skip courses. So as long as you like ask them and say like, "Hey, I've already taken this course before," and like even if it's not at a community college, but like just saying like, "I've taken this course before," they're usually fine with just skipping it. So I think this summer I'm just going to spend a lot of time probably learning Leet code as well as just like taking math courses so I can accelerate a lot.
Yeah. Yeah, I think yeah, like Farzan is saying, just taking the hard rigorous classes. I think if you want to be really good, you want to be the best engineer you can be, you need to challenge
Right.
yourself. Take if you can already do a DSA course, you already studied, you're good at it. Take the more
Yeah.
advanced one. Take distributed algorithms or something. Take even more advanced algorithms too. Just push it to the
Yeah.
maximum that you can get it. I mean, there's a trade off here, right? Because you also need to trade off like keeping a high GPA in order to get the job that you want because GPA does play a
Mhm.
factor if you're trying to get into quant.
Right.
But in the long run, if you so you need to balance having a high GPA. But if you think if you feel capable that you can take all these hard classes, still get good marks, and take all the hardest courses you can possibly take, I would push myself all the way to the limit
Uh-huh.
there. I feel like you're in
Right.
that state, like you're already reading differential textbooks.
Oh yeah. Yeah, I am.
So yeah, I would say yeah, take all the prereqs and yeah, push yourself to take all the advanced rigorous classes.
Hmm. Okay.
I mean, cause
Wait, and
okay, an
oh,
option, right? An option is you can pay to take an option for $600, some random option, or you could pay to take some advanced algorithm class for $600. They both cost $600, but one is literally gonna help you get a job at Fang, and one really won't.
right.
So what's it called? I mean, like you get way more value out that $600.
Yeah, absolutely.
So social
Um,
developers
I had
saying yes, social developers saying the same things. Like, unfortunately, what he's saying is true. I did not take anything above Cal 2. I think he's talking about Cal because it's hard as is. Now he's considering getting a master's in mathematics. Yeah, I think just push yourself. Obviously, don't obviously balance. You know yourself better. Don't push yourself to the edge where you hate your life. You hate computer science, everything. Right? It's all about just
right.
challenging yourself a little bit harder each time. So when chess masters are getting good, they're not playing grandmasters right away. They're playing someone that's slightly better than them. So you know where you're at and just adjust yourself, but just make sure that you're just not taking courses that you know you're easily gonna get A in.
Right. Yeah. I had a pretty general question about CS, I guess. Like in general, like I feel like on resumes, like obviously you include like or you don't have to, but like you can include your grades, your relevant coursework, you know. But there's also like the whole projects aspect, and I was just wondering if you could explain that a little more. Like what makes like a project, and like what are some good ideas? Because I haven't done any yet.
Yeah. Well, projects is the way you build your portfolio, right? Okay, pretend you're an artist and I want to buy painting off you. You could say all of the paintings, like what skills you know, right? Like, okay, I know how to use a pen, I know how to use a canvas. You could say all the different
Right.
things you know, but if I don't see your artwork, what it actually looks like, I can't make a real judge on you there. That's at that point,
Right.
right? So that's exactly what it is with computer science. You can say, "Oh, I've took these classes, I've worked these companies, I did X, Y, and Z." But first off, when you work at companies, you can't really publish that work. So they can't really see
Hmm.
that. And if you're a new grad or you're just in school, you don't have work experience. So you need to show people your work and prove that you've done stuff. So that's where a project comes in hand. Usually you build a project, you'll put it up on GitHub, you'll have a link to it, and people could literally look at your code and see how you write the code. They could explore the repository and see exactly everything you did there. And yeah, they
Hmm.
get to understand like how you write code. And I don't know, even people don't really even do projects, honestly. So if you
Really?
do projects, you'll be ahead of at least 60 or 70% of people. A lot of people want to do projects, but they can't get themselves up to do it. Honestly, it's not that easy to just go up and do projects in your own time.
No, yeah, that's what I was doing too. Because for my data structures class, like we have a final, and like we have to write a project, and he's like trying to teach us. The teacher's trying to teach us like how to make a website. So he just taught us how to do like front end in HTML, and now he's teaching us the back end in like Node Express JS, I think. But like, I mean, I don't know. I mean, like, how do you like choose like what type of like project you want to make? And I
Yeah.
guess like since I'm trying to do quant, would I do something like relating to like stocks or like yeah, the stock market as a whole? Would that like help
Yeah.
me stand out?
So, yeah, I never really did much on quant, but what I would do
Hmm.
there is I mean, you would have the way. So think about projects. When you're doing projects, you can do projects in two ways, right? You can figure out projects that are going to help my resume and definitely do those as well. So when I'm first starting out, I'll be like, okay, I want to apply for full stack engineering roles. What are some projects that I can do to help me land software full stack roles? What okay, then I work backwards from there. Okay, if I want to get a job as a full stack engineer at Meta, what do I need to learn? Probably React, that they're using React. Let me build a React application. Let me
Okay.
build a simple React application, and then also just make it complicated. Make it more than just a front end. Make it talk to a back end. Make it talk to a database. Deploy your code, right? Now,
Okay.
now you pretty much know how everything works end to end. You know how a website works end to end. You have a front end, you deploy the front end. You have a back end that's deployed as well. Front end is talking to the back end, making API calls. Is deployed on something like AWS. That's you kind of know everything from end to end there, and you understand that. That's really employable. Hiring someone who knows the life cycle of a website is very employable because pretty much everything is a website these days. Facebook, Instagram, like
Yeah.
all these things are websites or applications that are on the web, right? In some cases, you might
Yeah.
have to even ChatGPT. There's a like you need to understand how ChatGPT fully works. You need to understand how the front end is talking to the back end, and there's obviously the models and stuff underneath. But I think when you're first starting your degree, you need to build. You need to like when you're first getting into comp sci, you need to focus on breadth over depth. You need to
Hmm.
understand how software is built from end to end and kind of like be able to visualize that. And then if you want to focus on a specific part, then you could focus in on a specific part.
Okay.
Yeah, I kind of went on a tangent. Did I answer your question there?
Yeah. No, I understand.
So okay, actually, let me get back to it. So, okay, so pretend I was working on full stack. When I was in looking for jobs, I was looking for quant roles. I was looking for computer vision roles, and I was looking for just like regular software roles. So for the regular software roles, my projects were full stack projects, like a portfolio website, and then some other websites that I built in school, and all of them were full stack. front end, back end, deployed on AWS. Those are my general projects I put for when I'm applying for full stack roles. For my computer vision roles, I want to get a job in a computer vision company. So I did a internship as a machine learning engineer, and I was working on computer vision models, and I also did research on it when I was in my undergrad. So a lot of the bullet points I had were very specific to that for computer vision, and I didn't include any of my full stack projects. I just had a bunch of computer vision projects. So I had a specific one for that. Then I was also doing some quant. I was trying to apply for quant roles as well. So that I tailored a bit more too for quant. So yeah, I had some projects where I was doing like I took like some big data courses, and we were like trying to predict stocks and using like MapReduce and stuff to parse stock data. So I included everything related stock market related projects on that. So I had 3 variants, and I would send each one to the company to help me get a better result.
Uh-huh. So what you would do is you'd have like different versions of your resume, and based on like what type of engineer the company was looking for, you'd send them a different version. That was just,
Exactly.
like, more.
So pretend I'm applying for a Node.js role, like a backend role, right? And then I don't even include any projects that involve me creating a backend. Don't never even mention the word Node.js or backend once. And then somebody else puts it in, and they're like, okay, they built a simple to-do list backend, played around with Next.js, built a backend in Go. Like, those are their 3 projects. Like, who are they gonna take, right?
Right.
They're gonna take the guy that already has some experience. I mean, they might interview both of you if they have enough time, but they have 1,000 applicants. 50 of them have already worked with Node.js, and maybe they have like a 3.8 GPA. Like, okay, let's go with that guy.
Yeah, I understand.
So
The thing is,
go ahead.
Oh, sorry. What were you saying?
Yeah, like basically with the quant stuff, like if I'm hiring for a quant and the dude submits something and it's just a bunch of full stack projects, like, and then another guy submits it and he's doing like actual quant related projects, talks about like some competitive program he's joined, talks about some math competitions. I'm not just gonna go with the full stack guy because I don't know if he's gonna be able to ramp up to my quant role versus the person already doing comp sci, like has some super hard technical projects, done competitions. That person seems a bit more employable for my position that I'm. So yeah, and like vice versa. Pretend the quant guy sends that to a full stack role. Like, yeah, you're smart at quant. You're smart at doing math competitions, but that doesn't really translate into being a good full stack engineer. And like that for sure. Like I already know that because I've seen that before of people really crack that math, but it's the different skill set.
Uh-huh.
So yeah, that's why it's important to tailor, but you don't need to tailor it so hard for everybody you're applying to. Just have 3 different variants of the companies you want to apply for, and just kind of shoot there.
Okay. Oh, I forgot what I was gonna say. But okay, wait, never mind. Yeah, so I guess I know, or I have knowledge about data structures and algorithms and how to implement them, and I was considering starting leak code. Is there like a ordering, like in which problems I should tackle? Because I know there's also, ways to solve it. Like there's different there's like the sliding window algorithm, like, or not like an algorithm, but like a way to like generally solve problems. And there's like things like that, but they're not necessarily algorithms, right? So I'm just confused. Like, should I try and learn all these things first and then go into leak code, or should I try to like solve some of the problems, and if I fail, then try and learn it?
I would do okay. I have a series on this. I'm gonna
Oh, you do?
plug this in. Yeah, definitely. What social developer is saying is learn as you go. Very important. But let me see. I have a playlist here. Let me just get you the playlist.
Okay.
Hey everyone, welcome. So I have this playlist right here. I'm gonna send you this playlist, but I talk about how to get good at lead code, and I talk about pretend you have the summer to learn, right?
I do, yeah.
So how long is your summer? About 3 months?
Yeah, about 3 months.
So what I would do is I would spend probably the first month learning data structures. What does that
Like,
mean? Oh yeah, go ahead.
well, yeah, because I've already taken like data structures and algorithms course, so like I already know like what a stack is and like what a heap is and like what a BST is, as well as like other algorithms like Dijkstra's and like prims and
Oh, you
stuff like
already know
that. I already
those?
know like yeah, because I took them this year in high school.
Okay. Let's see. What I would do is are you okay, go on zero track here. You see, are you on my stream?
Yeah, I'm watching right now.
If you already know, if you're already good, like do sort by rating here. Rating is
Okay.
essentially your elo. So try doing
Uh-huh.
questions at the smallest elo, and then just keep going upwards, right?
Okay.
But that's and see what your elo is. That's one way.
Oh, I see.
Or yeah, yo, we could even do code. We can even do a coding interview, and then we'll see where you are.
Like right
Um,
now or probably later, right?
yeah, we can do a different one because we only have 15 more minutes here.
Yeah, that's
But
fine.
what we can do is okay, because my thing was learn data structures first. Can you implement a linked list from scratch?
Yeah.
You can implement linked list from scratch.
Yeah, pretty much.
Okay. Okay. Actually, just do neat code 150. Have you heard of this neat code 150 list?
I've heard of it, but I haven't tried it.
Yeah. Okay. Try to go through the neat code 150 list. It's a really good
Like
list.
in order.
Um, I would shuffle it. Choose random
Okay.
problem, and then like click into choose random problems and start with the easy one.
Mm-hmm.
Like go like this. Okay, wait. Let
Getting a
me
little
think that list.
unlucky
Yeah,
with your
this will get you
choices.
right. Oh wait, can you hear me?
Yeah, yeah, I can hear you.
Because what I would do is that I would just actually because you know the basics, I would start learning the algorithms like did you see my series on like coding patterns like two pointers, sliding window, stat depth first search, backtracking.
Yeah, I think I watched a little bit. It's like there are like patterns that show up in like all the leak code problems, and if you learn them like well enough, you can pretty much solve any of them, right?
Exactly, exactly. So what I would do is have you another resource is called Grokking the Coding Interview. That's a really good one. It shows you all the different patterns and it shows you
Mhm.
it's called Grokking. It shows you all the different coding patterns and it shows you like 5 or 6 lead code questions for those coding patterns. So what you could do is try to work through those. But I would say since you already know, try to get 100 questions done by the end of the summer around there. I think once you get to around 300, you can pass any fan company 300 or 400 questions done.
Oh, really?
Yeah, it's pretty
So just like
deterministic.
yeah, I mean, I feel like I've seen like a lot of coding interviews where people can solve like problems in like 20 minutes or so, like even if they're explaining out their algorithm to like, the interviewer. But like, is it common like if problems take me like over an hour to solve it? And like, I feel like at what point like should I like just give up and try and like find
Yeah.
that or just like get the answer?
Okay, when you're first, this is your first lead code grind. This is the summer. Like, don't
Yep.
even focus on. Yeah, probably spend an hour max on it, but like time yourself for like an hour. But if you can't solve it, maybe think about it a bit more. I'm trying to think because like there's trade offs here, right? You could because I know when I first started, I just didn't even look at the solution until I figured it out, even if I figured it out a couple of days after. But I didn't
Oh,
have
really?
any interviews coming up. So it's different if you have an interview coming up. Because I think what people, well, there's an extreme here when you just look at the solutions too early, and then
Yep.
there's people who don't look at the solutions enough, and you want to kind of balance it, right? You don't want to look at it too early because then you'll never learn, but then you don't want to spend a week on one question, and it's a small trick that you'll never be able to find because you want to practice breadth over depth.
Mm-hmm.
So I would say I think an hour is good for easy questions. When you first start
Okay.
doing mediums, 2 hours, and like if you can't solve it for the first 45 minutes, take a break, then look at it again, and try to figure out
Alright.
different solutions. And if you can't figure it out, right? If you can't
Mhm.
figure out no matter what, just try to think about, just write down your approach, and then when you read the solution, you should have like a aha moment. You're like, oh, that's why I didn't even think about it in that way. I didn't even
Right.
go that direction. So keep track of all the directions that you tried, kind of thing.
Okay. And when you're finding the solutions, like there's like the solutions tab in Leak Code, right? So should I just look at that, or is there like a
Now, straight buy premium, bro. It's like definitely worth it if you have the money.
really? Wait, how much is it?
Probably like 30 a month. It's
Oh,
kind of
that's
expensive.
fine.
But like it's definitely
That's
worth
fine.
it. But I think just message me too if you get stuck on anything. I have videos on a bunch of different topics in our Discord. Like if you don't want to buy it, also yeah,
Hmm.
you like everyone on Discord is pretty helpful, like sending in solutions. Or you could just look at the solutions tab and look at the community generated. But I feel
Uh-huh.
like the premium generated ones are really good.
Okay. All right. I had
Yeah. What's your
another
other question?
question. Oh, sorry, what?
Yeah. What's your other question?
Um, my CS teacher, he went to UPenn and then he worked at Microsoft and he talked about how like he wrote like a lot of or like he learned a lot of coding languages and like put them on his resume. Like, do you think that's necessary, like depending on like which company you're applying to?
Learning a bunch of different coding language. I don't
Or
know.
like,
I feel like it's not the best strat. I
uh-huh,
feel like you should learn one coding language all the way deep
right.
and understand. For example, Python. Python could get so deep. First, the
Hmm.
first level is simple variables, loops, and stuff like
Right.
that. Then you could start thinking about, um, okay, Python object oriented, and learn how to do Python in object oriented fashion. Go
Yeah.
deep on that. Okay, then look up Python in functional patterns, right? How to
Hmm.
write Python functionally. Now you kind of know object oriented and functional ways of doing
Right.
Python. Then look into the other stuff like the meta programming of Python, right? Like reflection and all that.
Yeah.
The like these are the other abstractions on top of Python to help you write code. Like reflection and stuff is different. You just learn focus on concepts versus programming language. If you learn functional programming in Python, you'll easily be able to move into another functional programming because they have similar concepts. But the other programming language might enforce some of the concepts a bit more, but the concepts are still there. If you learn reflection, reflection is in Java and in Python. So I would
I see.
say just go hard on one language and learn everything about it end to end. Like even Python is it's interpreted, right? So
Uh-huh.
understanding how that works too, like
Yeah.
just go deep into Python and just understand everything about it, because once you know a language really deep, you could start contrasting it to other languages. You could be like, okay, C++
Yeah.
doesn't really have reflection. Like, why is that the case? And like, what are the differences? But it helps you like know what the options are. Like, I think it's good because like pretend I learned Java, then I learned Python, then I learned Ruby, and I just learned it the basics of just variables. That I'm not gonna learn too much about it, right? Like
Right.
I'll just know surface level, but then I jump into a code base and it's completely functional. Then I
Yeah.
won't know anything how to navigate it. But yeah, that's kind of my
Uh-huh.
advice there. Does that make sense?
Yeah, no, I understand. As for like learning Python, like are there like books I should read or like just like watch like a YouTube video? Because I know there's like videos that are like 10 hours long and it like gives you like the whole rundown of like an entire coding language. I
Yeah,
just don't know if I should watch the whole thing.
you're into textbooks, right? You're not. You're more into
Yeah, yeah,
textbooks than
very
reading.
textbooks.
Yeah, honestly, I prefer reading the textbooks as well, and
Uh-huh.
so that's good because I think it'll walk you through it really nicely. So I would let's see. Yo, what I've never had to do I learned Python straight by just doing, not actually a textbook.
Hmm.
So I can find resources, but just take a Python textbook and read it from end to end. I'm pretty
Okay.
sure at first it's gonna start with the advanced or sorry the beginner concepts like loops and like syntax, Then it's gonna get into the more advanced stuff like object-oriented, functional, and then it's gonna
Right.
go into like the meta programming stuff. But I think, yeah, that's what I'd do. Just take a textbook, read it front to back. You have a. It's gonna be a good summer, man. Like if you lock in this summer, school's gonna be really easy for you.
Oh yeah, no, I'm so ready. I'm like really motivated.
Yeah. No, you're already
Yeah,
like way ahead of most.
yeah, no, definitely. I'm just I just like want to get more ahead. Like I just want to like make sure like as for like if I do choose to go into quant, like I feel like since I'm not going to like a target university, I feel like I'm at a little disadvantage. So I
Hmm.
just want to make sure I'm like, able to keep up like as far as like learning and stuff like that, like I want to be able to answer the questions they ask.
Yeah. Yeah, and like what the social developer said, the fundamentals translate across most languages, right? So if you just learn for loops, if you learn what a loop is and why it's needed, that translates to every single language. Versus just like if you just think about it in just terms of like syntax.
Hmm.
So same with everything. Like object oriented principles, they're different in Java and Python, but only slightly. And it's fundamentals that you need to understand. You need to understand inheritance. Some languages might have multiple inheritance. Some might have single inheritance. But if you don't understand inheritance pattern at all, the fundamentals of that, you don't understand
I mean,
encapsulation. Even encapsulation works a lot different than Python and Java that you need to watch out for. But yeah, does that make sense?
yeah, I understand.
You got any more questions? We got like 5 more minutes.
Um, I'm trying to think. Do you think it's good like if I try and learn C++ at the same time? Because I feel like a lot of quant companies look for like people who can like code in C++. I just don't know if I should like, because like I don't know if it's like too much to try and find like some sort of interview that's like something related to quant over the like my first year at college, like in the next year. I guess like I don't know, would I have enough time to learn both Python and C++ very well, like, before I start applying to jobs or internships, I mean?
Let's see. Does he want to do QD or QT? What's Q? Like quant dev or quantitative analysis?
Yeah, I was thinking of doing quant research or quant dev,
Paul, what do you mean by QD or QT? Can you explain that quick?
quant trader, quant
Okay.
developer.
Which one are you thinking of doing?
I was thinking of doing either quant developer or quant researcher, which is quant researcher is like a lot of math and stuff.
Yeah.
It's the one that requires like a lot of knowledge of proper like or probability and like
Yeah. That's
statistics.
gonna require advanced, probably, what Paul said.
You can't do it without a PhD. Okay.
I don't know. I think you might be able to. Uh, Most of the people I know who are in quant, even though they're like cracked at LeetCode and then competitive, they're
Hmm.
actually quantitative. They're like basically engineers in quant. Some do like the analysis and stuff, like are
Right.
actually quant. But I don't know the difference between the terms, honestly. I don't know if I
Right.
can help you too much with the quant stuff. But
Okay.
like go follow Coding Jesus. He does a lot of that.
Yeah, no, I see him. Like I saw in some of his like interviews, like he always asks questions like about like C++ itself. So that's sort of what I was asking.
Yeah, yeah. I think you could
Yeah,
learn. I wouldn't if you want to get into that, just learn C plus plus this summer. Don't learn Python and just code all your like practice leak code in C plus plus. Don't do
okay.
Python. You don't want to spread yourself too thin. But the stuff you're gonna learn is gonna be very translatable to Python.
Okay. So I'll stick with C++ this summer though, and then I'll get really good and like after that maybe I'll see if I want to do Python or not.
Yeah, probably in your first year course they're gonna teach you Python and stuff.
Yeah, probably.
Okay, cool.
All right, yeah, that's all I had for today.
Sounds
Thanks
good,
so
man.
much
That was
for
really good convo. Good luck with all your
yeah,
stuff, and keep like messaging in the. I'm pretty sure
yeah, I'll
the
let you know.
Discord has been pretty helpful, right? With answering all your stuff. Just keep
Yeah,
asking there.
definitely. All right, yeah, thank you so
All
much.
right,
Have a nice
sounds good.
day.
You too. All right,
I'll
see ya.
probably stay in the stream for a
Sounds
bit.
good. All right, see ya.
All right, bye.
Yo, what's good?
What's up, bro? How's it going?
Wait, I'm gonna let me get you. Oh, hop on the stream too, so you can see.
Oh, okay,
Yeah,
okay.
yeah.
Bet, bet.
Yo, chat, I got my YC friend hopping in. This is gonna be sick. Everyone can hear him?
Oh shit, dude! Wait, I think you got another like 15K subs since we last
Bro.
since we hung out, bro.
Yeah, it's going
Oh my
crazy.
god, bro! You're actually a beast.
Audio screen capture. Yeah, it's going crazy. Yo, this one's gonna be fun.
Bet. Wait, how do I like not have both? Like, you want me to be listening, or you want me to just look at the chat, basically?
No, it doesn't matter.
Cool.
Yo, chat. No, I was just saying, like, if you want to see, like.
Oh, okay.
Yo, chat. This is my YC friend. Let me blur out your background. All right. Yo, who got questions for him? Let me prepare some. Yo, ask him questions quick. I need to go hit the washroom quick. I was streaming for like the last 3 hours.
Oh shit, dude.
That's why I was saying hop on the chat or I was telling you to hop on so they can ask you stuff.
Yeah. True.
Yo, chat. So this guy, yo, okay. Let's just start this off quick. Or give me a sec. Let me hit the restroom. I'll be right back.
Alright, cool.
Nah, this Farzan. Wait, what school did you go to again? Oh yeah, can you?
Me? Okay. I'll.
Yeah,
I'll
give the full intro, but I'll start the recording real quick.
Alright. Wait, yeah. Tell me when you start the recording, then.
Okay, so we can get into. All right, 3, 2, 1. Hey everybody. So today I have my friend Camille, he was in YC before and we've worked together. So yeah, I met him we worked in the same company. So yeah, I've seen this guy, met this guy, hung out with him. We're good friends, and yeah, he has a pretty interesting story. So I just wanted to get a nice call with him. We'll just talk about YC specifically because he got into YC when he was like 21. Got the 500 grand. I think it's just an interesting story because, I mean, this guy's smart. Like he was doing deep learning research in NVIDIA and stuff. I mean, Camille, just intro yourself for yourself.
Yeah, sure. Okay, so hey everyone, I'm Camille. I work at Rippling with oh wait, shit. I don't know. Whatever, yeah. We work James and I work together basically at the same company right now.
Yeah.
When I guess I'll give a more like longer overview of myself. So I started college when I was like 17, went to UC Santa Cruz for computer science.
Nice.
When I was there, I did deep learning research primarily. Like that's what I did at a few different labs on campus, like doing computer vision stuff. So like image classification and then some NLP stuff, like sentiment analysis kind of stuff. And this is before like transformers really got big. So like all the research I did was just with like shallower neural networks.
Mm-hmm.
And then my junior year, technically my sophomore year, I got an internship offer at NVIDIA to do like deep learning engineering. But then it got rescinded and then like I finessed it back basically. And then I also interned at Amazon, basically doing software engineering. And then I interned at NVIDIA doing deep learning engineering. And then, that was computer vision stuff basically. And then once I finished with both of those, I wanted to start a company or I wanted to do something entrepreneurial. I originally wanted to buy like a software business, but then I decided against it. It was kind of like, it just felt kind of weird, like buying something super small and it would be kind of like not my own code and like potentially some other language and like not that big of an opportunity, but you still have to work a lot.
Yeah.
I figured let's try and do something more interesting. I went to a hackathon. At the time I was doing crypto because I was really into that. And then I won this hackathon. And then there were some VCs there that kind of pushed me to like start a company, convinced my friend to join me. We both like turned down our return offers and like what other offers we have.
Yeah.
At like big like FANG companies and stuff.
Mm.
And then applied to YC. We applied with one idea, interviewed with a different idea, got in. did the company for another like 9 months or something. We shut it down, and then like a couple months later, basically, I joined Rippling, and I've been there with you, I guess.
Nice.
Since then. Yeah.
So got into YC. Okay, let's talk about all this stuff before getting into YC, doing YC. Like, what can you not talk about specifically for YC?
Well, I mean, like, it just kind of depends, man. There's like obviously I can't talk about other companies. Like, I can't really talk about other companies.
Yeah, for sure.
Like shit like that.
I mean,
I think I can talk about like my experience and stuff.
Yeah, let's talk about. Let's work a bit backwards because I feel like I want to join YC one day. Like, how do you even get into YC? And
Yeah.
like, what's the benefits of getting to YC? Like, you got a 500K investment from them, right? For like probably 25% of your company. Or there's a flat rate that they do.
So, I mean, the deal information is available online. Basically, it's like the way they do it now is like it's 500K total. That gets wired like straight into your company's bank account as soon as you incorporate it and set up a bank account. The equity deal, the way it's structured, it's on safes. So if you're not familiar with the safe, it stands for like simple agreement for future equity.
Mm-hmm.
Basically, YC invented it as a way to like avoid having like convertible debt, but also avoid having the complexity of like straight equity. And so what a safe is basically an agreement that like once your company actually has like a value to it, like some sort of like price round by like a later stage investor, the price at which they paid for their shares gets converted into actual shares. So fundamentally, a safe is just like a way for an investor to quickly give you money without the overhead of having like to issue shares in your company and without the overhead of them having shares in your company, basically to have like voting rights and control. So the point is that it's very founder friendly because like you don't have like no one actually owns, like you can technically run away with the money and they can't do anything legally about it. That's the benefit of a safe from a founder perspective.
I see.
Yeah, but basically the way it's structured, it ends up being about 10% because it's like 125K at 7%. So that values the company at like $2 million roughly. And then 375K at like uncapped most favored nation, which basically just means that whatever round or whatever valuation you raise the next round at is whatever the value like converts to.
I see.
For example, if you raised at like a seed round at like $30 million, then the 375 would convert at the 30 million cap. And so that would be another like 10% or something. Wait, is that how that would work? Yeah, something like that. Yeah. Wait, actually, it might be more. Am I stupid? Wait. No. Wait. Wait. Dude, I think I'm doing the math wrong.
Let's just.
Right?
This is important stuff though. Like, I think you get equity. They give you 500K. They use a safe in order to actually, like, give you this money and evaluate your company. I mean, because every company is pretty much worth $0 when it first starts.
Yeah.
Like, a lot of the companies there, some of them are ideas. Like, I mean, some might have it, but pretend. Yeah, you just get 500. Is there limits of what you can do with this 500K? Dude, and what is the YC program? Pretend, or like, what's the process to actually get in? And then like, don't you have to do something on site with a bunch of different founders and stuff?
Okay, so you asked me like a couple different questions.
Let's just start. Yeah, like what the process is, and then actually what the program entails.
Okay. So basically, like, in order to get in, the way that it works is you basically just submit an application online. So imagine like when you're applying to college, you have to do like a Common App or something like that. You literally just write out, you answer a couple of questions, and then you submit your application. In like a couple of weeks, they like submit a request if they want to interview you or something, or they reject you, and then you interview, and then you either get in or you don't. It used to be that it was just like a 10-minute interview and you get in. Nowadays, they have like more, like it's more common, I feel like, to have multiple interviews. Like we have multiple interviews.
Yeah.
And I think nowadays also they're flying people in to like do it in person. When we did it, it was still like COVID time, so it was like remote for us. They always change their process. Like honestly, like I feel like they're constantly experimenting with what to do, especially as like things change.
So what's in the application?
So it's basically like you write about your idea. Like the application is available for anyone. Like you can go to Y-Combinator.com/apply. But basically like you talk about your company, like what you guys want to build, what progress you've made, like how the company's organization structure is set up.
Yeah.
your co-founders, like what you guys did in the past, and then like what kinds of other ideas you'd want to work on, basically, if the current idea is like shitty in their
Yeah,
opinion.
I like that. Write about your
Yeah.
ideas. So you write about your idea, write about yourself a bit.
Yeah, and the progress you've made, I guess.
And then like other ideas you would like to explore. Did you get a referral when you applied there?
We did not have a referral. We didn't get any referrals. It was just my co-founder and I.
Does it help to get a referral?
Um, I mean, I think it depends. I think it depends on who's giving it.
Yeah.
Yeah. And like how strong the referral is. That's my opinion. I don't know all the details about how they kind of like process it, but I mean, clearly you don't need a referral. Like anyone can apply and get in, basically.
Okay. So now you submitted this. How long did it take for them to reply? And you're just getting emailed about it? Like,
I think for us, it was like, well, we applied late. That was the thing. You can also apply late and get in. Like that's another thing. We applied like a day late, and I think we got the interview request like a month and a half or 2 months later, something like that. And then we did the interview like a week later, and then we got a second interview like a couple days later, and then they told us we were in, pretty much.
okay, what are they asking in this interview? Are you allowed to talk about that? Like, what are they?
Yeah, I mean, I
what
can
are
talk
they
about it.
focusing on?
Yeah, like they basically, it really depends. It really depends on the interview. It depends on like it depends on like who you are and the state of your company. That's what matters the most. So it's kind of like I do mock interviews with my friends all the time. It's really not that hard to figure out the kind of shit that they'll want to know, because it's like you think about like what's the biggest risk to this company, and like have they thought about like a solution, or like do they have a better explanation? It's kind of like sales almost. Like they have some sort of objections or concerns, they bring it up to you in the form of questions, and then you address it somehow. But other than that, it's like what kind of progress you've made. Like basically, what are you working on? Like the classic question they always ask is like, what are you working on? And then um, like what progress have you made? Like how did the founder, like if there's like a founder kind of relationship they want to know more about, they'll ask about that. If they have concerns about like the competitive landscape, they'll ask about that. If they have concerns about like the technical ability to execute on this, they'll ask about that.
I see.
It really depends, right? It really depends on the idea and what you're working on, and like how long you've been working on it, and like how well the founders know each other. Because like, yeah, again, like I said, like they kind of want to, they're ultimately still investing, and so any sort of investor is going to want to be like, okay, what's the reason that this company would fail, and do they have like an explanation for like to dissuade our like opinions about that. That's my personal
I see.
take on what happens. Yeah.
So what do you, like? Why do you think you got accepted? What do you think are like the strong parts of your application?
So I think for me and my co-founder, I think like something that like if you look at the directory, well, I guess they don't have the directory anymore. If you look at like companies, like all the companies, and you look at the co-founders and like you look at their backgrounds and stuff, usually it's like you should be friends or like know the person that you're starting the company with. We knew each other really well. We'd work together. Ideally, you work together as well. We both had like prestigious internships. Like obviously my background was like relatively prestigious. And then my co-founder, he had worked at Peloton doing computer vision as well.
Nice.
Back then AI was not like as hot. Like it was still cool, but it wasn't like everything in the world was about AI like it is right now.
Yeah.
And so like I think that was part of the interesting factor, right? Like, oh, these two young technical people that know each other really well.
Yeah.
And actually, sorry, I'm kind of getting ahead of myself. If I had to break it down, it was like hustle and grit, because we had already like left our jobs. Like we were not working on our jobs at that point.
Yeah.
It was technical ability, because clearly like we had, at least to them, we had like the background at like strong companies.
Yeah.
And then they're not like they're not giving you like a coding challenge or something
Yeah.
like during
Yeah.
yeah. We had worked together before and like knew each other really well. And Oh, and I think we like had interesting ideas and were like relatively eloquent about it, I think. And I think what my partner told us when I asked that question, like during the batch, he was like, "You're smart and you want to win." Like that's what he said. So I think it was just like
Okay.
you could get the vibe of like, oh, like these guys are capable, but also like they're like really fucking grindy and like really like trying to hustle.
Yeah.
So I think that's what it was. Because we also like during the interview we had we basically like cold outreach to uh like 10 different engineers at crypto companies to get like the idea for like what we pitched basically during the interview. And I think and he was like, "Oh, how'd you get them?" It was just like cold, right? So he was like, "Oh shit, if these guys can do this, like this is probably what he was thinking. It's like, oh, if these guys can do this without having YC, then imagine what they could do if they were in the program and had the brand, right?
Yeah.
Because we literally were doing it with like no rapport with these people."
I see.
So,
No,
yeah.
that makes a lot of sense. I think they're probably looking at you like, yeah, they're really young, they're smart, they have a good background, they're friends, like
Mhm.
because ideas. So it seems like they would even take somebody who they think is really smart over someone with just a good idea.
I think the way it works, and again, like this is not even like I don't have the proof for this.
Yeah.
My opinion is just that like um I think that they would rather have like smart people that don't know what they're doing yet. And they've actually talked about this in their videos, like Dalton and Michael
Mhm.
in their videos. Like they'd rather have people that like don't they have like a super shitty idea that they're easily willing to like throw away, but they're really smart and they can figure something else out instead of like people that are like really hard stuck to like an average or like not great idea pretty much, right?
Yeah.
Because it's like if a company, if like if the co-founders don't want to pivot, then they have to be really strict about like what they're working on, right?
Yeah.
They have no choice. They have to look at it like, okay, like what is this all about? Like, can this work? Basically, can this become really big? Can these people build this, right? And so you make it harder for yourself if you're committed to just doing one thing to get into the program. Because most of the time when people apply, they're applying with shit ideas.
Yeah.
Sometimes it works, but like a lot of the times, like people like end up changing their idea, and then that eventually works, right?
Yeah. I think I've seen that in their videos. They always say people come
Yeah.
in and a lot of times they're gonna have to pivot. Every company in the program pivots. They say like,
Not everyone, I would say, but like not everyone, but definitely a lot, and and some of them become the biggest companies. So like that's why they still let those people in, right?
yeah.
Because if they don't, then they're throwing away like the majority of their alpha.
No, that makes a lot of sense. Like, just have a bunch of smart people. I mean, because execution is everything, right? Like, everyone there kind of. Like, do you think they prioritize people they know can execute versus people who can just come up with good ideas? You kind of
Well,
goes
you
into.
need both, but yeah, I mean, you need both. You need both. I think that's kind of what they were screening for with us a little bit too. Like, um, you can't, yeah, you can't do like a no. Yeah, I feel like,
You need both, right? For sure.
yeah, I think
Like,
you need both.
you can't have no ideas at all, and someone has to keep telling you what to do because then you have no
Yeah,
product sense. You have no
yeah,
pulse on the economy. You have no pulse. You have no pulse on anything.
yeah.
So like, okay, Paul's asking what was your business idea, your company idea?
So we applied as a crypto social network. So we changed ideas a lot. Like I was saying, like a lot of companies pivot. We were one of them.
Yeah.
We applied as a crypto social network. We realized that was a really shitty idea, and then right when we got the interview invite, that's when we like did some interviews with like data engineers at crypto companies,
Hmm.
and then we like pitched the idea to do like a B2B crypto data API pretty much, which was honestly a pretty common idea, and it's not a great idea because like I don't think any of them became really big. But the way that we talked about it, and I guess like the way that we thought about it was
Yeah.
good.
Explain the
So
idea and like what like and yeah, explain the idea and let me pick into it and kind of see what they would
sure.
ask. Yeah, like
I mean, I don't even remember all the details, honestly. That's because as soon as we got in, we literally stopped working on it. We were like, this is not a great idea. Like, let's not work on this idea.
And then what'd you pivot to?
Dude, we kept pivoting.
And they didn't care?
Never. Not really. I mean, eventually they were like, bro, like, what are you guys doing? Because it was like, yeah, because we've been pivoting for like a year, right? So it was like, okay, well, at that point, like a year after you get into YC, if you're still pivoting, like, all right, come on, guys, like, what's going on here?
Yeah.
But
it's all in the crypto space?
no, it was like crypto at first, and then within a few weeks, we switched to like AI infrastructure, and then we switched to like AI application layer stuff, and then we shut down. We shut down because like we got, like my co-founder and I just started like beefing, and like not really seeing eye to eye about what we wanted to do, and so it was just like too hard to like keep working together. That was like the main reason why we like stopped.
Yeah.
And we were both like super burnt out from all the pivoting.
So
frankly.
So you got in for which batch? Like summer?
It was winter 23.
Winter 2023.
Yeah.
And then what is the program like? So when 23 is there a start date? And then like how does the program run?
2023 is there a start date?
Like January, everyone meets up in some location. Then they start doing like week 1 of like. Do they do curriculum or no?
They don't really do a curriculum. I think things have changed since I did mine. When I did my batch, we had like a retreat, basically, in like the North Bay, like wine country, basically. It was very nice. But then after that was like a couple days, and then after that it was just like weekly meetings with the group partners, weekly meetings with like like a small group within the batch, like of other companies that had been funded by the same partner. And then we had like weekly dinners with the whole batch, and then eventually weekly dinners with just like our section, like with just our partners companies and with just our group. And then there was demo day, and then there was like this like post batch party, basically. And that's basically all it was.
So weekly meetings with partners, that has to be in person in the YC office?
I think now it's all in person. But when we did it, it was like all remote.
Even dinners?
Well, no, like the meetings with like our partner and our section were all remote, but the dinners with the batch were in person.
Nice.
So we were the first in-person batch after the COVID like wave. And so because of that, it was like honestly pretty nice because like we got to like socialize with everyone.
Did they get paid for those dinners?
Did we get paid?
Or did they pay? Like, did you have to pay for the dinner yourself? Or?
No, dude, we didn't have to pay.
Dude, that's crazy. So
it was sick, dude.
Every week, and like, how do they pick the restaurant you go to for dinner?
It was like the same place most of the time, and then for like specific events, there was like a smaller venue. But it was like, dude, it was really nice. It was like free drinks, like free food. Yeah, it was really sick, dude. It was like really nice.
And it's with the whole batch, the weekly dinner?
Most of them, it was the whole batch. I think, again, this is like all changed. I think some of it has changed a lot. Like, I think now what I've heard is like it's the groups and the groups are more together and like they're not as like interactive with the rest of the groups. But that could be wrong. Like I don't remember. I just remember hearing something like that. I think it's changed though. Like they're always changing it pretty much.
Okay. So what are they asking you in these weekly meetings? Like I get these what's the goal of these weekly meetings? There's, of course, like socializing and getting to know people. Maybe like cross pollinating.
Like the dinners.
Okay, let's start off with the meeting with partners. What's happening there? What are they checking up on your product? Asking.
It's honestly just like it's not like the way that you would do it. Like at a job. Like these people aren't your boss.
Yeah. Right?
They're not your boss. They have no control like over your company. They only own like 7% or 10%, whatever.
Yeah.
And like I said earlier, it's not actually shares. It's literally just a promise for future equity. So because of that, like they have no say in what you actually do, even with the money, like legally. So it's not like a check-in or a stand-up kind of thing where like your boss is checking like, yo, bro, are you doing your work?
Yeah.
It's more like, hey, like this meeting is for you to ask us any questions that you have. about like what you're doing and like whatever. Like the meetings were pretty short. It was like only like 20 minutes or something.
Okay.
So yeah, just like what my co-founder and I would do, and I think what other people would do is like prepare like what you want to talk about because you don't have much time, and then bang it out, and then like debrief, and then use that to like move forward pretty much. That's kind of like what those were, I would say specifically. They were really helpful, honestly.
Like what are they doing though? Like they're like, okay, you're pivoting your idea, or like maybe you're on one idea. Are they asking very specific things?
I mean, that's kind of a broad question. Like, what do you mean?
So I don't know. Pretend I'm a partner, right?
Mhm.
Like, are they asking you high level things of like, okay, what's the market you're attacking? How are you thinking about the market? Or like, okay, how's that API you're building working now? Like, where are you with that?
Like I said, it's not a check-in, bro. Like
Okay.
they're not checking in with you. It's you asking them
What would you
questions.
ask them then? Like, how would a typical session go then, right here?
I guess like one example would be like, hey, we have these ideas that we're thinking about, or like, hey, like we're trying to talk to these people and we're not really getting that much information out of them. Like, how do we get more information out of them? And then he would give us like his opinion basically, or he'd be like, hey, like, um, yeah, he basically gave us his opinion about like whatever the question was, and then we move on to the next question, maybe ask some more follow-ups, and then move on.
Were
Um,
your questions more on execution related stuff? Like, oh, how do we get this done? Or more like,
it depended on the day. I think like the nice thing about about like the way that they do it now is like they have partners that are like have been partners at YC for a long time, and they have partners that have been in YC for like less time.
yeah,
Like basically like visiting partners, that's what they call them.
yeah,
And like because they haven't been out of their execution space for like a while, like for that long, they still have a lot of like really relevant juicy details on like how to actually like execute.
yeah,
And so I feel like that was like more helpful from them. The partners are like the partners that have been there for a while and haven't worked on their companies in a while. They have a bit less like insight, like I would expect, basically on like, hey, like specifically, how do I like run like a LinkedIn campaign to
yeah.
like what exact words do I say? Like they're not going to be able to tell you that as well as like someone that maybe just like exited their company or something. Um, but they're really they can connect with anyone like basically within the community. Like they will like propose people that maybe you wouldn't have thought of
Yeah.
to talk to. Um,
Because
yeah, like it's really
what
nice.
I was
Like they
thinking too, though, is like, okay, their experience. So they might be watching you, and they'll be like, okay, when are you gonna release your first prototype? Get that out there as soon as possible, so you can get people on it. Like they're not even pushing you towards that.
I think it depends again on like your company and your partner. I think some people who like have a more solid idea already, they'll get pushed like that. I think for us, and maybe you could argue this is like their fault, like or their like that was like not good. But for us, it was like we were so lost in like what we wanted to work on and like in working with each other
Mm-hmm.
that it was like we didn't even really get to the point where like he was being super pushy, like, yo, you guys have to ship something, you have to
Yeah.
like he was telling us like, yo, you guys should really like pick something and like you guys should really do something.
Yeah.
But he was never like, yo, like when are you guys gonna like
Uh-huh.
release this thing or something?
But did he ever give advice on it? Be like, okay, if you can't figure it out, maybe you should try this exercise. Think about like some advice in that direction of.
Yeah, he would do that like all the time. Yeah, he would do that kind of thing, like basically like the times that we would like come to him and ask about it, or like we were like still struggling. And that was also helpful. But again, like for us, it wasn't about like generating ideas, it was just committing. So like
Yeah.
that was our personal issue.
Okay, explain that. Like how. Why did you decide to switch? Like how did you get the urge to switch, kind of thing?
I think it was like uh
So for like I'm working on this idea, and all of a sudden one day like, okay, I don't really like this anymore. Let's try.
honestly, I just never, for me personally, I just never cared about like any of the shit we were
I
working
see.
on, and I never cared about like the people we were building it for.
I see.
Like I felt like personally, I had way. It's like I felt like I had a lot of other personal problems that I would have rather worked on that would actually have helped me instead of like trying to like constantly grind to like get these people's time and attention for them to not even really like give a shit or like help me. And I felt like I'm pulling teeth to try and get them to. It's like it felt to me what it felt like honestly was like I'm putting so much effort into helping people that don't even want to be helped by me. And I was like, why the fuck am I doing this
Yeah.
when like I don't care about this problem, I don't care about these people, and I don't even like if I work on this, it's not gonna like whether or not I work on something to help them, it's not gonna materially change my life like day to day. And so I think because of that, that's why I was like, dude, like why the fuck am I like working on these ideas? But I think I could never accept it.
Yeah. So
I
what
think
would be your advice there?
what would be my advice?
Yeah. Like if you're giving advice to yourself at that point in time, what would you have done differently?
I would have probably said, well, there are a variety of issues. I think with that, with respect to that particular like error and mistake, I probably just been like, dude, like, just like, um, think about what you actually. Um, I probably would have been like, think about what you actually, what you actually have problems, like what your actual problems
Yeah.
are, and then don't think too hard about like the competitive risk or the market risk. Just focus on like seeing if you can solve something for yourself
I see.
and if there's a world in which it can make money. Like for me, I think the criteria I have now for what makes a good idea, just to at least start working
Yeah.
on. And then like for like a good idea for a business versus a good idea for a startup. So I'll tell you the good idea for a business.
Okay.
To me, a good idea for a business is like I clearly know what to build. I clearly am able to sell it and I know who to sell it to.
Yeah.
Um, and I can do both of those relatively quickly. Um, ideally, and again, ideally, I guess for me, it's something that it's helping me personally
Yeah.
because that makes product taste way better.
Yeah.
Right? Like you don't need to do all these user interviews and shit. That makes the iteration cycle so much slower.
Yeah.
Versus if you know what to build because you're the one that's using it. And if I can use the product, then I can make it go so much faster.
Yeah.
And I care more. So I think that it would be like, yeah, like, and there's like it's like clear, like there's a clear path to monetization pretty much. That's like the base of like a good business idea because you're not worried about market size yet. And then once it's like, there's like, if you're thinking about what's a good startup idea, a good startup idea is one where like the market is either already large or it's like growing really fast, basically. That's the difference. Yeah.
I see.
Yeah. But yeah, the thing is like YC like they have videos on like how to come up with good ideas and stuff. Like a common thing people talk about for how they come up with their idea is like you do a bunch of user interviews and then you find like the problem that people want and then you like solve that. That sometimes works. That's why they talk about it. But it's a lot rarer from what I've seen because it's so like one, you have to like be really technically competent because you have to be able to build basically anything at that point because you don't know what idea you're going to land on. And two, you need to get kind of lucky with who you're talking to and really be able to like parse out the noise, like parse out the signal from the noise. And in my opinion, you also need to like either really give a shit about like the people you're trying to help, or you need to like be willing to not give a shit in order to just like focus on making a big company. And personally, I found emotionally, I could not do that.
Yeah.
No matter how hard I tried, I think that was just not the kind of person I was.
Yeah.
Personally.
So you just didn't care about the idea, so it's hard to like you're grindy, but you're not gonna grind something that you don't like. You just couldn't get yourself up to even work on those ideas. Like you could, but it wasn't a good thing to do long term.
I just like I think at some point it was just easier for me to be like, oh, I can just work on something else since this is like not easy and like it's not easy. It's not obvious how this works. This is like probably bad and like the risk I'm taking is so great. I'd rather just see if I could find something else to work on, pretty much.
Oh,
Like
that's
the
when you
switching cost
pivoted.
is so low
Pardon?
to change.
Yeah, yeah. And then, but would you switch? How fast would you switch? Like, how much in the idea did you get? Did you write
It
something?
was like every couple of days or like every week or something. Like it was really fast.
Yeah.
It was really fast.
Because you're still
Yeah.
young too. You're still young. I kind of know what you're feeling too because I tried to start stuff when I was early too, and sometimes you feel like you don't want to lock into one specific idea because what if it goes for 10 to 15 years and you don't like and you wasted your whole
Yeah. Yeah, and it's like you can feel that you don't like it really quickly. Now I see like you can kind of, if the business is making progress, just focus on like making the business work and then keep the business going. But still, that's not like, if you want to build a really big company, I feel like that's still not ideal. For a lot of people, at least. Some people can do it, man. Some people can just really not give a shit and just be like, I want to make a big company. For me personally, I don't think I could do that though.
Yeah.
Like, I don't think I could build a big company that way.
What are the stuff you're interested in?
Dude, it's pretty weird. It's pretty weird stuff, bro. Like, I'm interested in like looks maxing and shit like that, bro. And like health maxing and shit, bro.
Yeah.
Like that's the shit that I'm interested in. Like you know the kind of shit I'm
Yeah,
interested
yeah.
in. Bro.
Do you think you'll ever try to get into YC again at some point?
I think like maybe. I think like I don't know if I'd want to do a venture backed company just because it's like so much of a hassle to like deal with that. Like I would want to do it for the freedom and not necessarily for like a flashy like exit. Because when you work on a startup, when you raise money, you're basically working on one thing really, really hard for a really long time.
Yeah.
And then there's like you're basically taking on like the likelihood of nothing working. Like you get nothing out of it after like years of working on it.
Yeah.
That's not really the ideal place to be, in my opinion, if you're gonna like take that much risk. Like bootstrapping, if you can, is much better.
You really? You think bootstrapping is better than venture-backed business?
If you're prioritizing freedom, yeah. If you're prioritizing like other shit, then maybe not. But yeah, like if you're prioritizing like getting rich and like freedom, then bootstrapping is probably better because you can sell it for a lower amount and get a lot of money, right? Like if you're a venture-backed company, the first round you raise from YC is effectively valuing it at like 5 million, right? And you're 500K in the hole already.
Yeah.
Like YC would probably be cool with it. Like you'd still like be able to, figure that one out. But like as soon as you raise like, dude, these companies, they're raising like millions of dollars in fucking like seed funding.
Yeah.
Like they're fucked. They're fucked unless like they can't, even with $1 million in ARR, you can't fucking sell that company for like more than the amount you raised. So you're not making any money off of that, right? And it's even worse when you raise like a Series A or something, or if you raise like 10 million or something. Like you're basically like when you raise money, you're kind of like putting yourself back. Most of the time, you're putting yourself back in the position of like, oh, I'm all or nothing again. Like I need to either like go big or go home, like that kind of thing. That's how it works, in my opinion.
That's great. I guess that does make sense because when you raise money, it raises the price on paper of your business. And most of the time it's valuated at a multiple of your profit. So you have to grow into what they believe your company's gonna be.
Kind of. I mean, the way that venture capital works is more about like ownership percentages and less about like valuation multiples, at least early stage for sure. Like the average Series A round is like 20% or something, 20-25%. But that's what they want. They're just literally going off of like, how do you get to that ownership percentage if you're the lead investor in a Series A? And it's similar with like seed stage stuff too. Like they don't give a shit about the valuation of the multiples. They're literally just focused on ownership percentages.
I see.
Yeah.
Damn, that was okay. So how long did how long does the program last before demo day?
It's like 12 weeks. But if you get in earlier, then you get access to all the stuff and the partners, and you meet your partners like every week and stuff. Yeah. But yeah, it's really, the actual program is like 12 weeks. But yeah, like if you get in earlier, you have access to stuff earlier.
Any tips for like actually getting the most out of that program for the 12 weeks?
I think like launching early is the best. I think launch early and like make friends with as many people as you can, in my opinion. Because some of them, like, dude, I'm friends with people that like are running like Series A companies, and and I know people like in my batch who already raised like Series Bs basically. I don't know everyone. I know some people that are like pretty good. I think it would have been nice if I knew even more people than I did. I think I did a pretty good job of it. Like I did an okay job of it. Yeah, like I know some people that were like that like have been at our company for a while, and they were like, hey, yeah, like I know this guy from like literally this guy of like the founder of like a $10 billion company.
Yeah.
Like I used to like get coffee with them and like shit like that.
Yeah.
Like that is crazy to me. Like that is the opportunity you really have. Like you get to meet people that are so exceptional and they can become your friends. Like I'm friends with a lot of people from my batch still.
Yeah.
Um,
It's like basically
Yeah.
going to Stanford Business School. Like you meet
it's
so
better
much.
than Stanford Business School. It's like it's like you take all the most cracked, ambitious people from like all of the top schools, and then you put them and companies and you put them in one place to try and build like the biggest companies possible.
That sounds
That you just
amazing.
get like it's like cracked upon cracked, bro. It's insane.
Like people are really tweaking out in the program, huh? Like pushing thousands of lines every week.
People are grinding, yeah, dude. People are really grinding. People are really fucking grinding.
What's
I
a
mean,
grinder based on you see? Like they were literally working 9 a.m. to 9 p.m. sleep.
I think the best companies from my batch, I think some of them didn't even go to like some of the like uh group like meetings. They would just go to like they would just go to like the dinners and like their office hours. And I think and they would like basically take no days off, work all the time. They were just focused on like selling and building. Um and yeah. But like and the ones that were pivoting, they like were basically meeting with like 60 people a week or something crazy, like something super crazy. It was like selling, yeah, like basically like focused on only the right shit and then grinding out in such a way that like actually was productive.
So,
They were just
so,
very focused, like very, very focused.
so out of your batch, right? There's smart people. There's grinders. Like, what do you think makes someone successful in that? Is it, I mean, a mix of both, or can somebody
Dude, I
just
think what
grinding?
helps, I'd say like because it's still only been 2 years since my batch,
Mhm.
like all the, I don't know all the details, but from what I can see, the, um, the biggest, well, honestly, like among like the companies that I'm friends with that are doing well, most of them, actually, let me think. It's about a 50-50 split actually of like companies that like came in with their idea and then like worked on it like throughout the batch and like are still working on that idea,
Mhm.
or they like pivoted into their idea like relatively quickly. Like most of the companies that I know that are doing well, they like found their idea early in the batch or already came in with their idea figured out, and then they just relentlessly grinded it out pretty much and just focused on that.
I see.
And the other companies that did not, that took a little longer, I think they just like were very persistent. Like they did not give up and they continually focused on like one thing at a time and then like progressed through the idea space there.
Yeah.
And then they eventually committed to doing something, but kept their emotional energy up. It's pretty hard to do that, honestly. But yeah, some people are able to do it.
What? Keep the emotional energy up.
Yeah. Like despite having like no idea that you're working on for like months. Like there are a couple companies I know like that, or even years, dude. I know people that are still pivoting from my batch, bro, that are still working on their company.
And they're still using the 500K
Well, so they raised more money. They raised more money at like Demo Day
to
or like some
pivot.
other.
Like they raised even with that with the same idea.
Yeah, they raised and then they pivoted again. Yeah, that happens a lot too. Because it's still just a seed round. Like the seed round is still really early.
Bro, this that okay. So for 12 weeks, grind like crazy essentially. Meet as many people as you can. How do you even have a girlfriend in that during that? Can you even do that?
Some people did, bro. Yeah. Some people did. I know some people had to like break up with their girlfriend.
No way.
Well, I think it was more like it was. I have this one friend. He like dated this girl. He was dating this girl, and then like after the batch, like they broke up because like she didn't want to like move to SF with him, and he didn't want to move like back to be where she was permanently, basically.
Mhm.
So that was like the case of they broke up. My co-founder had a girlfriend. Like I introduced him to his girlfriend, and then like I know other people that like they were engaged or they had wives or something.
And they
I think
still
it's just
pulled it
like
off.
because it's only 3 months, it was like not that bad. But if it was longer, I think it gets more cooked.
I see.
But
I mean,
yeah,
after, if your startup does well, you're gonna be grinding like no tomorrow too.
yeah. I think that's just like a constant struggle, bro.
Yeah.
Yeah.
So people when they're in the batch, they pretty much had no social life. They're not going to no weddings. They're not going to any trips. They're kind of just grinding on their idea.
I think the companies that did the best, yeah. I think the companies that did the best were not like doing that much craziness outside of their
But
company.
did some
And the
literally
people that
just
were
do nothing?
what's up?
Some people literally just did nothing too, like not even show up or like ghosting or like didn't get any code written,
Uh,
vacations.
you mean some people basically just like
Like
took the money?
did that happen? Or like did some people like what's on the bad end? Like the extreme end, like the very good end, these people grinded the whole program. They got a lot out of it. What's like sort of on like the other end? And then where do companies fall after it? I'm just trying to get a sense of like how companies grow in YC.
I mean, honestly, I would say we were kind of on the lower end of the spectrum, but like you can make the argument that the companies that really have get the most fucked. In my opinion, I think the people that get the most fucked are the people that work on companies that don't really go anywhere, but they get far enough along that like you don't really want to leave. But like or like you keep working on it for like years and years, basically like 5+ years or something, but you don't get like a substantial exit out of it. It doesn't get that big. And so now you've worked on like a company for 5 years, grinding it out. You didn't really get anything out of it.
Mm-hmm.
That is the worst case scenario, in my opinion, for like the individual. I think for YC, the worst case scenario is like they work on like a shitty idea that YC already tells them is going to be like trash. And then like they just keep working on that anyways, and then it eventually fails.
Okay.
I think that's what they think is the worst, other than people that obviously just like scam YC.
Yeah.
But yeah.
Okay. So what's demo day like?
Um,
That's like the finale, the climax of the whole program.
the climax, bro.
Yeah.
Yeah, dude. Uh, Demo day again. I think it's different now because people present in person.
Yeah.
Like when I did it, it was all online. So it was way more chill. Like if I wanted to, I could have had my script up pretty much and just like read off of it.
Yeah.
I might have even done that, dude. I don't remember honestly.
I would too.
Yeah. But yeah, dude. Demo day was cool.
Like how long is the demo?
It's like 1 minute. You don't even
Oh, wow.
demo your product. It's literally just like a slide, and then like
Oh damn.
you like talk about the progress.
People
of
raise
something.
millions off that 1 minute thing.
Well, they do that 1 minute thing, and then you have a meeting after, and then some people have decks, some people don't have
I
decks,
see.
and then they raise the money there.
I see.
It's like a trailer, basically. It's like a movie trailer for the company,
I see.
and then they do a meeting to like check it out, or they'll just email you about it or something.
I
But
see.
yeah,
No,
yeah,
that's a lot of insight. I mean, at some point, I definitely want to try YC and
you
like
should, bro. It'd be cool.
the application. Now I know that I just need to grind.
Yeah, bro. I mean, you're at 40K subs, bro. You're the big beast. You're a big beast, bro.
Yeah, let's see. What else? Need to find an idea. That's the hardest part for me, honestly. Like I can't find an idea that I want to work on.
Like, what do you mean you can't, like, you don't want to work on it? Like, it's just like you think it's shitty, or you just literally can't think of ideas at all?
I don't have any ideas off my head that I would work on. But I actually, it's because I don't really think about it. A lot of
Yeah, like, have you actually thought about it? I think that's the problem.
not lately because I'm just thinking about what content to drop that the people need to see. That's literally
Exactly.
what I've been dropping. It's like, oh, there's no videos on this, then I drop one. Like,
Yeah, like, I'm pretty sure if you actually thought about it, you could, it would not take you that hard, like, long to think of some good shit.
Yeah.
Yeah.
So what's up with you now for the rest of? You're gonna. I mean, you're working on some stuff, right? Do you want to share that at some point?
I can, yeah, sure.
Yeah, send a link. Send a link. Because
Sure,
it
sure.
works well with what people who follow my channel do, and I'm sure like I'm gonna try it out at one point.
Sure, bro.
You gotta get me the free link though. I don't mind paying for it though. Just
I mean, if you make an account, I can set you up with some credits, but I need your account to do that.
I don't mind. I'll pay for it. Send the link.
You don't need to fucking, you don't need to pay for it. It's cool. Um, yeah, I got you. One sec. I'll send it in the chat, in like our chat.
Nice.
Google Meet.
Yeah, pitch your thing real quick. Like, what is this thing? Like,
Oh,
what are you
okay.
building it?
Sure, bro. Yeah, so yeah, I shared this thing with James. So basically, this is like a mock interviewer AI. So you like sign up. Imagine that like you're doing lead code, but like when you do lead code, you aren't really like practicing the interview.
Mm-hmm.
So this would be like instead of having your friend or like a professional like that works at Fang do a mock interview for you, or like someone like James, I guess, if
Yeah.
James is like time constrained, then you would just like go to this site, pay like $10 basically, and then you get like an hour of interview time. And like it's literally just like you can see from the UI, there's like the
Hi everyone, my
IDE,
name is
the problem, the examples. You can run your code, see what the model is saying. The model will speak to you,
Nice.
and then yeah, you get feedback at the end of the interview, and you can go from there.
Okay, what are the inputs? Is pretty much where you like your code, the audio, your thought process.
Yeah. It's like the code, the transcript, and then yeah, just goes through a model for the feedback pretty much.
Is it giving you hints and stuff on the way if you get stuck?
It does, but like that's obviously counted against you. So
Wow.
yeah, like it's pretty interactive. Like it gives you hints without giving away the answer. Like that took a lot of work actually
Yeah.
to get the system to be at the point where like you can't like cheese it into giving you the answer. It's like pretty like solid about like not really like giving away the stuff.
No, this is cool. I think I'm gonna play around with it. Definitely.
Yeah.
Maybe
Just
this
let me know,
stream.
bro.
This stream I'll play around with it. If I
Alright.
have time, because I'm like in like 5 minutes I'm interviewing some guy from NYU.
Oh, okay.
But like, no, this is cool. What else? Have you seen that guy who built the AI to cheat interviews? This is kind of opposite of it, huh?
Yeah, interview coder.
Yeah. What do you think about that?
Dude, my co-founder like has a lot of opinions on that. He really like wants to like mess with that guy and like build something to not like to like prevent that shit from happening.
Yeah. I mean, what it's worth, everyone in my chat and stuff really like or don't like that guy or like don't like that idea either because it kind of cheats the system in a way. I don't know how I feel about it yet, but what are your thoughts on like cheating for coding interviews? Is coding interviews actually useless?
I mean, I honestly used to think it was kind of useless, and then I got an actual job instead of like my internships and stuff, and I realized, oh, this is actually pretty similar to what you do day to day. At least at like my particular job at our company, I feel like it's pretty useful to gauge that. I will say though that like um, I think because AI exists now, this was kind of inevitability, right?
Mhm.
Because it's basically at the point where like a lot of the code is going to get written by AI more and more. Like coding is not really what people should be assessed on, or at least it's like someone is bound to make a mockery of it. And so, like in my opinion, the system just needs to evolve, because like people were always cheating. Like I don't know if you know, I mean, like people were always cheating on. Like I have friends that work at like that literally only got into Citadel and stuff because they like had like all four of their roommates in college working on the problem together.
Yeah.
Like literally, like they literally had like a whiteboard behind their laptop and they would just write it out and stuff like that. It was crazy. So like people are always cheating on this shit anyways. It's just like if anything, it's better because it's gonna make it fairer if companies or like someone figures out a way to like make it so that it is actually fair.
Bro, that's hilarious. Nah,
Right.
like there's so much things that Yeah, that's just crazy. That makes a lot of sense. That I mean, people are cheating for sure, but I think this is people are using this to even just like crack Amazon and Google and stuff. But
Yeah.
nah. All right, Camille. It was nice talking to you. Well, we'll do another one soon. I'll see if I covered any. If there's other things I hadn't covered, definitely want to do it again. But
Yeah, bro.
thanks for joining in.
Sure, man. Yeah. Thanks for having me, man. All right.
All
I'll
right,
see you later, James.
see ya. Yo, chat. What do you think about that guy? I wonder how hard it was for him to send back 300K. I'm gonna be right back. Taking a quick break. Let me put on a timer for 5 minutes. Taking a quick break. Yo, chat. Up next, we have a coding interview with some guy from NYU. So that's the plan. We'll get back on this stuff soon. Alex, happy Sunday. Alex, you wanna come on for a coding interview? Yo, what's up? What's up? Yeah, he got the job. I gotta catch up with him. But yeah, one of the people in our community landed a job at a Fang, or not, so at a quant, at a top tier quant too. How's studying, Alex? Need to get more. One second. Need to grab water. All right. We're hopping into the next session, a mock coding interview. Join Google Meets. Okay. I'm in here. I don't see him. Oh, nice.
Yo.
Yo, what's up?
Oh, what's up? Bro, I was on the Discord. I thought we were gonna do this over Discord.
It's good. It's here. How's life, man?
It's been pretty good. Just been chilling. But I've been not gonna lie, I've been kind of slacking.
Mm.
So, like missing quizzes and whatnot.
Yeah.
On the verge of failing, but I just lost all my motivation.
For school?
Yeah, for school.
Why? What happened?
I don't know.
You're not
I think
liking it
it's
anymore?
like- yeah, I just realized that like I was only doing it so that I could get a job, and now that I have a job, it's like, or I have an internship. It's like,
Yeah. You have 2 internships lined up, right?
yeah, I have a summer internship at Meta.
Nice.
Hopefully, I'm not gonna lie. After these Trump tariffs, I'm kind of scared.
Why? What happened? It's gonna affect the Trump tariffs. Could affect your job.
Yeah, what if they get rescinded?
They're saying that.
I mean, I don't. I mean, it'll probably be like, it's just like, it's just dooming. But I doubt it'll happen. But who knows?
Yeah.
It depends on how bad it is.
So you have like a meta. You have meta summer and then winter is like LeetCode or sorry Google. Something?
Yeah, it's in the fall.
Nice.
Yeah, it's like, yeah.
Dude, those are sick ones. And like what? I mean, yeah, we could start. I just want to get some background before I start because I'm gonna record the video as well for doing the challenge. Like, how many LeetCode questions have you done?
I think before my like coding interviews, I had like 200, and then now I've kind of like fallen off, but I'm still like, this like January I started I picked it back up doing like the daily. I kind of
Nice.
it's kind of like, treating it like a Wordle,
Okay, I'm gonna send you a link. I sent you a link in our chat here. Let's see. Were you already watching the stream or not really?
I watched like just the hour before with that with the YC guy.
Nice.
I was watching.
Okay, so you didn't, because I did a question before that. I was working through LeetCode. Did you see that? Because I might ask you the similar one. See how you...
No, I don't think I saw. I don't think I saw that one.
All right. Cool. Yeah. When I start the video, we'll just like talk for a bit, like introductions, try to understand of like, I mean, where you're at, what courses you've taken, maybe your goals, like where, yeah, like just where you are in your LeetCode journey, or just software. Maybe we could talk a bit about like where you want to go,
Right.
and then yeah. All right, I'm gonna start this up. Am I allowed to say your school or no?
Yeah, you can say my school.
What school do you go to again? NYU or?
Yeah, I got NYU.
Cool. Yeah, because I'll just introduce you as a friend from NYU. So, all right, I'm gonna start this up. Hey everyone. So today I have my friend from NYU. What year are you in again?
I'm a junior.
Nice. So he's a junior and he has internships at Meta and Google coming up. But actually, do you just want to give a quick background on yourself, quick?
Yeah, sure. Um, I'm a junior at NYU. I'm studying computer science. I have taken like basic CS classes, just like the prereqs, mostly, and I have about. I've been picking up background the back. I've been picking back up the grind for leak code. I have about 350 questions done.
Wow.
Kind of semi daily. Yeah.
350, 350 questions solved.
Yeah.
NYU junior. Working at what other internships have you had?
I had a small startup. It was a New York City like A16Z funded startup, a
Mhm.
Series A, and then sophomore year I worked at Niantic.
Nice.
I worked on Pokemon Go.
Yeah, I know Niantic. That's in Bay Area.
I was in the Bellevue office.
Nice. Okay, Seattle ish.
Yeah.
Cool. And like, what's your goals? Like, you landed these really good companies. Is you want to work in Fang? You want to work in startups? You want to start your own startup?
Hmm. Right now, I don't necessarily know exactly what I want to do. I really liked the startup experience that I did, like my internship freshman year.
Mm.
So I'm leaning towards that, but depends on how I find like working at Meta and Google, how cool that is. I'm also considering maybe trying to go into quant,
Yeah.
which I'm learning like C++.
I see.
But that's like a big maybe. I'm
Yeah.
not too sure if I'm willing to pick up the grind for that.
Yeah. Any advice for people trying to get into Fang internships?
So I landed Meta, Google. I also landed Amazon,
Mhm.
but I ended up reneging. I would say like my best advice is, other than like obviously get lucky,
Yeah.
get lucky. Try to intern at like other places. Try to like find any sort of relevant job experience. For example, like before my first startup, I literally had Chipotle on my resume. So
Yeah.
find relevant experience, whether it be like through research, TA for some reason is kind of good. Any other internships at like smaller companies first. Second is once you have experience, is reach out to recruiters, reach out to people, alumni, etc. I think that definitely helps. I didn't really do that. I kind of got lucky by like getting past the like cold applying,
Yeah.
but I seen a lot of friends who were sort of like reaching out to friends and whatnot, and that definitely helps. Maybe last one is um, send out a lot of applications. That's really it, I think.
Just spam.
Yeah, because like you shouldn't rely on like anytime you send out an application, you kind of just assume you got rejected. Honestly,
Yeah.
it's just very low percentages, very tough job market. So you kind of have to. So the
Yeah.
volume is kind of a prerequisite. Yeah.
Yeah. I mean, you got your job in the middle of, like, I mean, yeah, the job market is tough. How about leak code?
Leak code.
How
Okay.
important was that for you?
I think leak code is definitely very useful and necessary. I have a controversial opinion though,
Mm.
and I think that the technical side of technical interviews, I don't think matters. Like of course it matters. It's like more than like I'd say like 60% of it, but a lot of I think a lot of what matters is how well you are able to like talk to the interviewer in a very like explain topics, technical topics in a very like approachable manner. Essentially, like basically, it's a lot of behavioral. I feel a lot of people like worry about like I feel like I've seen comments and whatnot of people worrying about like, oh my gosh, what if I made this syntax error, or oh my variable names were bad.
Yeah.
And I think that's, those are obviously kind of matter. They'll ding against you, but or like for example, oh, I didn't get the like optimal solution. But I think as long as like you are kind of charismatic and you're able to like talk and as long as the interviewer understands what you're doing, I think that goes a lot further. And I
Okay.
think it's a little bit more applicable than just like doing all the lead code questions. For example, like at Meta and Google, I didn't fully solve my questions, but neither of the two questions I got, or I got like four, two each. But I didn't fully solve any of them.
I
But
see.
I got pretty close, and I was able to like talk, and the interviewers like followed along. I like integrated their feedback and whatnot.
I see.
I think that's what will help.
Okay. So, how many questions have you done? I just need to. I'm coming up with some questions right now. So I just need to figure out how many, or not how many questions, but like, how hard of difficulty can you do? How many hard questions have you solved?
Let me search this up. I think I've maybe done like,
Are you pretty cracked at parting 20? 20?
yeah, around 20 hard. I'm pretty sure like at least half of them I like probably had to search for the solution.
Yeah. Like, how would you say?
I don't think
You think you're pretty cracked at leak code? Like, I need to get you a good sense.
I think I'm okay. I think I'm like maybe better than average, but not insane at lead code.
Okay.
Like I don't do like competitive programming or whatnot.
Okay. Let's see. All right. Let me post in. Okay, I'm gonna start with the first question. Right. And we're gonna do two questions. One's gonna be slightly harder, but yeah. So this is the first question, and then just do it the same way you would do an interview.
Okay, I see. So given the rule of binary search tree, return the minimum absolute difference of any two different nodes in true.
And I'll do I'll write an example here. Inside you could see, so we're given a binary search tree. Do you remember what a binary search tree is?
Yeah.
What's
Like left child is less than, right child is greater than the
Yeah.
parent node. Right?
Okay. So we're given, this is you can see the drawing mode, right?
Oh,
On the right
yeah.
tab.
Oh, yeah,
Nice.
I see it.
So we're gonna be given a binary search tree. Why is this a binary search tree? Could you explain?
Because yeah, so like any like left child is smaller than the parent, and any right child is greater than
Okay.
parent.
Is this a binary search tree?
No, because this is like it's like any, I guess it would be like any value on the left subtree has to be smaller, right? So this one wouldn't work because you have the root is 4, and that's smaller than 7.
Okay.
That wouldn't work.
So what we're getting asked is, what is the minimum absolute difference between any values, any two nodes? So here, the result would be 1. This would be the result. The minimum difference between any two nodes. Do you see why it would be 1?
Between minimum. Oh, the minimum absolute difference between.
Yeah.
Yeah.
Like what? Like where?
So it's like the difference between like 1 and 2 is 1, 2 and
Okay.
3 is 1. And
Okay.
Yeah, those two.
Okay, yeah, that's exactly it. So, yeah. Well, yeah. What's your thought process then for solving this?
Interesting. Not gonna lie, when I first read it, I thought it said maximum. So if it was like maximum, for example, I can do just traverse all the way down left, all the way to the right, and then just find the difference. So
Yeah.
that would be pretty easy. In terms of like the minimum absolute difference, one thing, I guess, can we assume that all values will be positive, or can they be negative as well?
It could be any value, but we could assume that it's a valid binary search tree.
Okay, right. And it's like an integer.
Yeah, it's a valid binary search tree of integer values.
Yeah.
I mean,
And
it wouldn't matter though. Right?
yeah. That's true. And then maybe I just one more question just
Sure.
before we go into it. Just making sure. Are we just like guaranteed at least like 2 nodes in the tree?
Yeah, we're guaranteed at least 2 nodes.
Mm. I think the way I would solve something like this is, since what would give you sort of like the smallest difference. For me, looking at, for example, this example is, I think it's like what, for example, let's say you're at node 2. What are sort of like, where could you get sort of the smallest value?
Sure.
I think here, for example, it would be either 1 or 3, right? And I think the reason for that is if you were to, let me see if I can like write text.
Yeah, you can write text.
So for example, if you were to print these out in order,
Yeah.
you can sort of see that since the binary search tree, all in order traversal will give you sorted array.
Nice.
Any 2 adjacent elements here would sort of be the closest, right?
Sure.
Or would sort of give you the closest difference
Okay.
between two nodes. So I think the way I would do something like this is I would just do an in order traversal, and at every in order traversal, just like compare in order traversal, just like compare difference between like the left and right child.
Yeah.
Let's see if that is, maybe have like a global minimum of sorts.
Okay, that makes sense. Yeah, go ahead and code that up. Yeah, good thought process. So you're familiar with in order traversal for visiting them in sorted order, kind of.
Yeah, I'm gonna. Do you mind if I change it to C++?
Yeah, change it to whatever.
Okay. I'm gonna copy this as well. And you want me to run this code? Okay. So
Yeah.
let's see. So int, let's find minimum absolute difference. Let's say a tree node pointer to root, right?
Yep.
Just imagine this, with just like left, right, and value. I think the one thing is like, this is sort of like the one thing I was confused at was like, how would you, if you go back to the drawing, right? Let's say with like 4, right? How would you find the closest, the quote unquote in order traversal from 4? That would essentially be like the predecessor and successor, right? So you can't just look at the left child direct, like the direct left child, because that could be its own subtree, and that could be there could be like a closer value than that.
Yeah.
So I think the way we would have to do this is we might. The way I'm thinking is like you need O event space where like you build this array and then compare. I think.
Okay.
Less.
You're thinking of building this array, and then at the end you loop through the array and just figure it out.
Right. Yeah. Hope that's okay. Maybe there might be like an O of one space solution if you were to sort of traverse at each node, look at the predecessor, find the predecessor, find the successor. But I think that would be you're like it's like trade-offs. You're trading off space for time. I mean space for time.
Okay. Once we have this, right, what are we comparing?
Oh yeah. When we have the array, we just compare like adjacent numbers.
So we compare 1 to 2, 2 to 3, or we can compare 2 to the 1, 3 to the 2, 4 to the 3, right? So I mean, like, do we need the whole array? I mean, pretend we we okay. Do we need the whole array then if we're only comparing like single?
I guess you don't need the whole array. You could just keep track of the last value. That could work as well, I think.
Okay, keep track of the last value and then what? Could you explain it?
So let's say you're at 4. You do an in-order traversal and you get to 1. It's like you see the 1 and then you have 1 and then you store it somewhere. After you compare with like 2 and 1, for example. Let's say you could do 2 and 1, compare which one is like the difference between the 2. And then store either you store 1, then you could store 2, and then store 3. So basically like the last element that you traversed at.
You want to store that?
Yeah.
Okay. What's the space complexity after that?
For that, I think because I think if you were to just have that with no like vector, it would be O of log n, where n is like the number of nodes in the binary tree if it's like balanced. Worst case, it could be like O of n if it's like unbalanced and you go recursive, like your recursive stack goes all the way down one path.
Yeah.
That's like a linked list.
Okay. So you're saying no matter what we do here, we're not optimizing space, or space isn't changing?
Yeah. I think, I suppose like very worst case, it would be O of n if it's like a unbalanced binary tree.
Yeah.
Binary search tree.
But in your last solution, it would always be O of n, right? Because you have to build this whole array.
Yeah.
Okay.
Yeah.
And then what's your final runtime? I mean, we'll ask you at the end. Just go ahead and implement that.
Okay.
Yeah. But like, yeah, it's good. I see you understand how the different edge cases and what it's gonna. That's kind of what I was testing. But yeah, go ahead and implement that. Then we can move on to the next question.
Okay. So, I'm just gonna, I guess, for easy, do you want me to just do the vector one for easy sake, or do you want me to do the whole?
What's the vector one?
The one where you just like store the whole array. And then
No. I want you to do the optimal solution, the optimized solution.
Yeah.
Otherwise, it'd be too
So
easy. Just do it in order and append to some array, and then afterwards.
Okay. You can do the same thing for diff. Diff. I think this is right. I'll have to include limits. I forgot. And then just do in order on the root. And then here, for this in order traversal, you just do in order tree node. If node term, and you say so in order just means like you traverse left, then traverse right. Something like this. Okay.
Okay.
Yes. How do I do this? So when do I, for example, like set the last value? Okay.
Yeah, what are you thinking here?
I guess I'm thinking I'll probably do the processing here. So maybe, do I need this? Okay, maybe last val shouldn't be max. It should be min. I'm just like for some reason I'm like thinking about like when to set the last val. But like for example, last val goes to node.val. So okay, so right after line 11, we just did an in-order traversal on the left subtree.
Yeah.
And we can do min diff equals to min of last val minus node val. I guess these could be like global variables. So let me put class solution. Sorry, class solution. It's like this.
Sure.
Say last val. Okay. So we set min diff equals to the minimum of last val
Yeah.
minus node dot val, or min diff and absolute value of this. And then we set last val equals to node val, I think. I don't know
Sure.
why it's complaining. Well, that's fine. Oh, it's because of the class. Well, that's okay. So then the idea is you traverse through the left subtree, and then you just compare the last value with the current val, and set the min diff as that. Then we set the last value to something, and then we say node, and then we traverse to the right.
Yep. Okay. That makes sense. Let's dry run it quickly on.
Sure.
Let's dry run it quickly on this. Or you go ahead. Or, yeah. Oh, shoot. Contact. Yeah. You write that on. Let's dry run it on like a very small example.
Sure. So let's say 1, 3. Something like this. The one issue I noticed is like last val being min, which might be an issue if, for example, like the first element is very close to min, and
Yeah.
that's the minimum, which shouldn't work. I think it would be something like, I think better would be if it was like an optional int or something, and it's like if we haven't set the last val, then set it. Otherwise, and don't calculate the min diff. Otherwise, do calculate the min difference. But you're at this tree, for example. Maybe make this slightly bigger. Or actually, let's just do something like this. So let's say you're doing an in order on 2, right? Which is the root. What does in order 2 do? It calls in order on 1, right? And in order 1, its left doesn't have anything, so then it sets min difference equal to. So we can say min diff equals to min, like int min minus 1, which is like a very big value, and then we say last val is equal to 1, and then we go to the right, and nothing happens there because there's nothing onto this right, and then we go back up to 2. It's left in order just finished, and we check, okay, min diff is equal to the minimum of min diff and the absolute value of the last val, which is 1, minus our current val, which is 2. And then we get changed min diff to 1, right? Because 2 minus 1 is 1. And then our last value gets set to 2. And then we go to the right subtree.
Nice.
And we call in order on 3. And then when we do in order on 3, we check. Again, it's left and right don't do anything. So we check the difference between 2 and 3, which doesn't change min diff. And then last value set to 3.
I see. Okay, cool. Sounds good. Good job. Let me get you the next question. Pause it here. Wait, have you done 368 on LeetCode? Let's look that up. Let's see.
I don't know my numbers.
Yeah. check out. Chat, how do you think you did? Like, look it up and see if you did 368.
Largest divisible subset. Is it the daily?
It was a daily, dude. How was that question for you?
Yeah.
Was it easy?
I did not. I thought it was like washed or something, but that was hard.
Okay.
I thought that was very hard. I had to look up the solution.
Okay.
I tried the backtracking and then TLE'd.
Oh, I see. I see. Okay. Let me go. I have a good one. Like,
I just looked. I forgot to return it.
all right. Let's start the recording. Cool. Good job on that one. We're gonna move on to the next question.
Mhm.
Let's do this. We're given a integer array, right? 1, 2, 3.
Yeah.
It's gonna be an increasing array, right? This,
Mhm.
and we're gonna be given a target. I want you to return me the indices of where it starts and where it ends.
I see.
Where target starts and ends. -1 if it's not in there.
Okay. So on this example, let's say like, let's do the indices 0 to 9.
Yeah.
We would. Do you want me to output something like 2 and 6?
Yeah.
Okay. I see.
Mhm.
Nice. Okay, so this is sort of what I'm thinking about right now.
Sure.
Thinking, well, I think right now I'm thinking the algorithm is likely to, it will just be like a left binaries, left, left binary search. I actually don't know like which is exactly like left or right, but essentially you want to do like a binary search on like sort of the smallest target and then or the smallest value that is still the target, which is like our target is 3. So we
Mhm.
set the smallest index where our target is 3, and then the largest index where our target is 3.
Sure.
And then we sort of just return those two numbers. It'll just be like a double binary search. Thinking if there are any like edge cases here, and the only reason I thought of that is because like because we're taking advantage of the fact that our input is sorted.
Sure.
So obviously you could do this like linear search, but I think that's like pretty easy. So I would imagine it would be something like this. So I'm returning the two indices, and then let's say find target bounds
Sure.
given a vector of integers nums and a target into target. Let me fix these. I think I'm missing some imports. No member called a vector. I include vectors. Okay. So maybe I'll leave a comment. So first, find the left bound, then we find the right bound, and just return make pair. Something like this. I'm gonna leave these blank actually. So let's just do a binary search. So you start with int l equals 0, r is equal to side. Next one. Next is y. L is less than y. Well, that's less than r. We just say, so there are a couple of ways you could do this. I think the way I like to do it is essentially like always, let me actually set it. M equals to L plus 1 minus L divided by 2. I think like this. The way I like to do it is essentially like always increment left or or always set L equals to M plus 1 or R is equal to M minus 1 or the other way around. And then just like you say, if, for example, if nums M is less than or equals to the target. So if nums M is, let's say the middle number is this, like 3, and it's less than or equal to the target, then this means that we should probably traverse to the left side. So this would be R is equal to M minus 1. Otherwise, you do L equals to M plus 1.
Okay.
Yeah. So the reason is, let's imagine, for example, you're at, let's say, index 2. Or let's say we like split it into so that L is here and R is here, or something like this, and then you say M is right here. Or
Yeah, which middle is it gonna pick?
yeah.
Because if there's two middles, I mean, if it's even, right? There's two middles. Which middle is it choosing?
I think this one picks the like left side.
Okay.
If it's like even, right? Yeah.
Yep.
So 4 minus 0 is 4. So it's divided by 2 is 2. Here, we essentially set right equals to here,
Sure.
M minus 1. And I think the idea behind something like this is you essentially like hold an invariant here. You're essentially saying right will always be 1 less than this condition, right? So it'll be 1 less than where nums M was equal to, when was less than or equal to target. So what you can say then here is if R is less than 0 or nums R plus 1. I think it's if R plus 1 is less than 0. Right, so R will always be 1 less than the sort of bound if we find it. So we say if it's out of bounds or if num R plus 1 doesn't equal to target, then we just return. What should we return if like
just like negative, like a pair of negative ones?
Yeah, let's do something like this, right? So essentially saying if R plus 1, meaning where our value should be, is out of bounds or doesn't equal target, this means we haven't found the target at all, right?
Sure.
Otherwise, then we know that our left bound, so let's say int left is equal to R plus 1. Or I guess it would have been better if I did something like this. Let me do that, actually, to be a little more clear. And then we can say, we can do something like this, very similar.
So if the left is less than 0, that means out of bounds.
Mhm.
Or it's not equal to target, then we couldn't find it. So what we're expecting is after this finishes, the left is positioned 1 below the target.
No, right. It would be right at the left bound, because it would be int left is equal to R plus 1.
Okay.
Right. Yeah.
Okay. Sounds good. Okay, what would we do for the right side?
For the right side, we can just take advantage of the fact that we already know where the left bound is, so we don't have to start from the very beginning. I don't think it adds anything to the complexity, but it's like, yeah, why not?
Cool.
And then we just, instead of less than or equal to, I think you do is, I think it's greater than or equal to, and then you say L is equal to M plus 1, and then R is equal to M minus 1. And the idea is left, again, with the same idea here, is that left would be 1 to the right of where your target is. Right? And then you would just say int right is equal to L minus 1. And then you can also, I mean, you could add the check. I don't think you need the check, but I guess you could say if right is less than or equal to, if right is greater than or equal to nums dot size, even though I don't think it should be fine. This shouldn't really happen because I believe it should, at the very least, like find the same values of this. Probably not needed. And then just return the pair, right? And so the time for this would be, since we just run 2 binary searches, it's just O of log n, and then the space is O of 1, because we only allocate for like constants.
I see. Okay. Let's run down some test cases. See if this works as expected.
Yeah. I'm always like very skeptical about about my binary searches.
I mean, let's change it up this time. Instead of dry running it, write your test case code, the test that it works.
Oh yeah. Let's print it. I think. So let's say.
Oh, they do console log for C++? No.
Oh no, it's not console log. I don't know why. I don't know why I thought it was console log. Let's say.
I was like, that's interesting. I never knew that.
Although I think they do have a new print statement like 15 years later.
Nice. Yeah, the CL is pretty weird, but
Stud C out, find target bound of bounds and target. Let's say a reference. Am I missing something? Why? Oh, this I forgot. Like this. And so how do I run this?
you just click run right here.
Yeah.
There's
This is not standard. Am I dumb? Let's see out. Oh, I think it's because I can't print. Okay, never mind. I get it. Equals to this, and then we see P dot first, P dot second. Something like this. Find target bounds. Something like this. Okay.
now I'm testing your debugging skills now to see.
Well, okay. Std C out does not have a type. Wait, C++ C out. No, that's right. Std C out is right.
Oh, shoot. That part's right.
App global scope. What does that even mean? Include IO stream, yes. No type named C out in namespace. Am I dumb? I actually don't know what I'm missing. Std C out. Is it? Wait, like this? What if I just do use namespace? Yeah, I don't know.
Okay, there's a GPT, there's an AI assist button. Like what?
Oh.
What would you ask here?
I would. Okay, this is what I would do. I'll type in no type called, because I'm assuming it's like, I'm pretty sure it is correct.
Okay, yeah, your code is correct, but it's just there's like a slight syntax error, right? Why it's not running?
Yeah. So I would just like copy the error, and then I would copy the whole thing and just be like, any syntax errors.
Oh, okay. I won't let you pass in the code, but ask.
Okay.
You can ask. Do you see the AI assist?
Yeah.
You can copy the stack trace in there.
Stack trace.
You see the stack trace is broken, right? It shows stack trace. Copy and paste that in there and ask what's wrong.
What's wrong? This error message, the necessary header file for input output is not included. Make sure you have IO stream included, which I think we do. check for conflicts. Could there be conflicts? Additional notes. Okay.
Yep.
So this said, how to resolve these issues. Include the IO stream header. That's not it because we have it. Namespace declaration. So try to do something like using namespace stood, and
Yeah.
then just do that. Let's see if that works. Doesn't work, then cout does not have type. Did I define cout anywhere?
Oh no, I think it ran. Let's see. Cout does not name a type. Okay, keep asking GPT. I'm trying to see how you debug this in production.
Okay.
Like if I gave you the job, I need to see how you're gonna run this.
Sure. The way I'm thinking right now is that someone is defining cout somewhere else. But okay. How come?
You could copy and paste the code. It's all good. Just copy and paste because that's what I would do too. Copy and throw it in there until it fixes it.
How come cout doesn't work?
I was just trying to see if you could understand what GPT is saying, because this one will just straight fix your code.
That's true.
Because sometimes you can't pass in the context. You have to read what GPT says.
I forgot. Oh, I forgot to put main. It's main.
Okay.
Oh my gosh. Sorry. This is the first time using C++ for interviews. Like,
You're just practicing for quant right now?
yeah. Well, I'm also like I'm using C++ for my internships. So
I see. I see.
get good at it.
Okay, stuff is broken.
Yeah. So outputs -1. Something's wrong. So what I'm gonna do is I'm gonna print out r+1 as well. Right? Because I'm assuming this is where the -1 is running into it. So let's run this. Okay, so cout is so left should be greater than or equal to z. Wait, no, that's right. If left is 0, left is of less than 0 is not. Oh, why is it 0? It shouldn't be 0. It should be 0, 1, 2. I would expect it to be 2. So something is wrong here. R is equal to m-1. Okay. So let me print out what m is at all stages. Oh. Let's run this. So m starts at 4, which is right. Then it goes 1, 0, 1, which is right. And then at 1, it goes to 0, but it should go to... Shouldn't do that.
I mean, 2... Okay, look, it's looking at 2, right? 2 is less than the target. Oh, wait.
Yeah. 2 is less than the target. 2 is less than the target. So we... Oh, oops. So what if... Okay, so if nums m is less than or equal to target, is it... Here should I put... greater than or equal to the target? So, okay. Then... Let's see. What is... It's greater than that. Oh, okay. Oh, so that was it. So it should be greater than. I guess this one should be less than. It seemed to work. So I'm so lost.
2 and 6.
2 and 6. 1, 2. What was 0, 1, 2, 3, 4, 5, 6. That's right.
0, 1, 2, 3, 4, 5, 6. Okay.
2 and 6.
Okay,
Yeah.
let's add let's do 4. So 2 and 6 again? Oh, sorry. Target should be 4 here.
Oh.
Tweaking. 7 and 8.
I think 0, 1, 2, 3, 4, 5, 6, 7, and 8. Yeah. Okay.
Okay. What about
And-
a single digit?
1. Yeah. And maybe if it's not found, should return -1, -1. So 7, 7. That's right. And then -1, -1.
Nice.
Okay.
Okay.
I
Why
wish
why
I-
did your fix change it? Like how did that work now?
Actually, so okay, so if nums m is greater than or equal to the target, yeah, so I guess like you this is essentially saying like oh, okay, this makes sense. So it's like as long as like you're on this right side here, you want to like move to the left, right? That's sort of the idea. Like where can you see what I'm highlighting?
Yeah, yeah.
For 3, this for target 3, right? So if we go back to the 3 example, right? We're essentially like sectioning off this section, this side, and we're saying, oh, go to the left here. If you're ever in this spot, go to the left, and that means r is equal to m minus 1.
Mhm.
And then when we do the other way around, we are sectioning off this area, and we're saying, oh, if you're ever on this area, which is if nums m is less than or equal to target, then move to the right,
Yeah.
because our target is sort of 5,
I see.
like the right bound.
I see. Cool. Yeah. Good job. You were able to solve the question. How do you think you did?
I think I did okay. I feel like for this one, obviously, I forgot this. I forgot the direction. Maybe I wasn't as clear as like explaining why I would do a binary search.
Yeah.
So yeah, but other than that, I think it went okay. I would say it went pretty good.
Yeah, yeah. Yeah, I agree. Yeah, I think you did pretty good. First question, let me look at my notes. First question, good clarifications on the binary search tree, the minimum amount of nodes, the values, pretty much clarifying all those. Able to understand that if you do an in-order traversal, you visit all the nodes in the right order, and then we kind of just have to compare adjacent nodes. So good intuition on that. So I understand that you know the different variations of depth first search. Probably know the pre-order, in-order, and post-order are.
Yep.
Good understanding of the call stack and execution flow. Understanding that, yeah, it's going to keep calling the left, and it'll only process, like, after the left returns, then we go to our right. Then after the left returns, so that's how, yeah, you're able to keep track of the previous value because you understood the execution flow. And then, yeah, wrote good, clean code that wasn't buggy. So good job on question 1. Second question, pretty good as well. You're able to get to the solution. Yeah, good use of like understanding how to do a modified binary search here. What else? Yep, right minus left to avoid integer overflows, edge case handling. Was able to write tests. No, I think overall good job. Like definitely would pass you on the interview. Like no real comments there. We should do one another a certain time. I'll ramp it up even harder to see because now I know that you're good. I can ask some better ones.
Oh my gosh, I'm scared.
But yeah, all right. Good job, man. Let's keep in touch. Message me on LinkedIn or Discord or something so we can schedule the next one at some point. Because I know you're ramping up, but we're gonna take it even harder. Because now I know that you're good.
Thank you
But
so much.
yeah, no problem. Thanks for hopping on.
I appreciate it.
Yeah.
Thank you.
All right. Cool. Nice to see you. I'm gonna hop up. All right. See you. Yo, chat. How do you think he did? Yeah. I'm just debating between like obviously a hire, but was that a strong hire? Yeah, I think he did really, really good. No, pretty good, pretty good. Yeah, pretty good, pretty good. Up there for sure. Yeah, I don't know. I think definitely a strong hire for intern position. Nah, that's a strong hire for doing that in C++ too. Making no mistakes. Really? He's still a student. Don't get scared though. Yeah, he's still like a junior. What is a junior? Like second year, third year? Yo, I'm gonna make some food real quick. Give me a sec. Yeah, he's just a junior. I'm gonna make some food and then we have my friend Richard from Waterloo hopping in. What's a junior? Okay, it's over. Third year? 3 out of 4? Yeah, okay. Bro's cracked. That's pretty good. Really, really good. Really, really good. One sec, just advanced TP. Yeah, I like those questions. I need to make sure people actually understand the difference. Alright, we got my friend Richard hopping on next. Let me just get some. Yo, let's see if I have slots. We got a Waterloo student coming off next. Yeah, Graphs and DFS is sick. Okay, let me make a little bit of food. Like, what's the time? It's already. I'm making a little bit of dinner. It should take like 5 minutes, and then from there, we're gonna hop on to some coding questions. But I can answer questions and stuff in the chat. Let's go. Yo, who wants to do a lead rooms? Yo, Richard, what's up? Let's do a lead rooms. Go to elite rooms while I'm eating quick. I'm gonna eat real quick, so to keep everyone stimulated. How do I do this? Rafi, I got you. Hop into this room code. people, join up, join up. Let's run this real quick. Yo, Richard, we'll have you on in a second. Let me just make my food. No one wants to. No one wants to join Soldier. Everyone, and then like
multiple of the one before.
yeah, exactly. I think that would work. Let's
Okay,
see.
so if we go with this approach.
How long was that? 24 minutes.
Yeah, no, I do think that's like a pretty solid medium. If I had to rank it, I don't think it's that difficult. I honestly this one's harder, and this one's a medium as well. So in my opinion, anyway, we'll see how it goes.
Okay. So we're given a set of distinct thoughts on algo map. What's algo map? I'm reviewing my footage and seeing where I could have done or where I could improve. All right. We're given a set of distinct positive integers nums. Return the largest subset answer such that every pair ij of elements in this subset satisfies this. Answer I. So for every I and j, if you mod them, you get 0. The values. Like either one, like this one divides j perfectly or j divides I perfectly. If
And
there
there was also a daily problem like a few days ago, so if you've done it, we can do something.
No, I don't do the daily problem.
Okay.
I should probably start, but I'm lazy to do those.
I mean, it's not necessary. Like unless you're like making videos on them, you can do whatever you
Yeah.
want. It's not like it's better than something else.
Okay, so we're given there are multiple solutions, return any of them. So 1 and 2, give us. Okay. This is interesting. So the largest subset is 1 and 2 because 1 and 2 1 mod 2 is equal to 0.
2 mod 1 is equal to 0.
2
So
mod
it can
1.
be one or the other.
1 and 3, like return the largest subset answer such that like here what I'm trying to figure out is why is it not like why is 1 and 3 not there? Isn't if you do 1 mod 3 that equals to 0, isn't
Yeah,
it?
so they tell you 1 and 3 is also valid.
But why not 1? Oh, okay. What? So the output can't be 1, 2, and 3 because 2 can't mod 3.
Yeah, exactly.
2 can't mod 3. So what I'm thinking is that is a good question. Let me think. Like at a high level, this is what I'm thinking off the like it's a bit skipping ahead, but what we're gonna like what I'm thinking is we want to be built. Well, first off, what's the brute force?
Mm-hmm.
I mean, it would be brute force would be generate the subsets. all the possible subsets, that's already pretty inefficient. O of 2n.
Oh, I see. Literally make every single one. Yeah, you have to make every single one, and then you also have to double check them for validity.
Yeah, and then like...
So it'd be like O of 2 to the n times n or something.
Yeah, exactly. Validate each one.
Mm-hmm.
But
Yeah,
what
definitely not an acceptable answer. Yep.
Like what I'm thinking is maybe there's a solution like this, like where we like hypothetically try to extend some subsets. So we have like some subsets where we know the length of those subsets, and we have like some hypothetical subsets. And then we know like some hypothetical subsets that are like that are marked by something. Either like it might be some value that encapsulates like who can extend this subset, right? Subset and size of the subset. So pretend we have one. We have no subset, so maybe we can start a subset with just one. As a count of one. Then we see 2. I mean 2. Which subsets could it extend? It could extend probably this subset. And it could start its own subset too. Something like this. And we still have 1. So 3 comes in. 3 could pretty much extend this subset. It'll create its own subset with 3. But it'll be a size 2. Then it's kind of like the max of what we see there. Like what we can do is we can try extend. Like we can add it into subsets. Let's see. Yeah, something like that. But then pretend there's a 6 that comes in. Like we'd want to, the answer would actually be 1, 3, and 6. Or like pretend there was 9 instead. The answer would actually be 1, 3, and 9. So what I'm thinking is that's sort of my intuition for the problem.
And so let me ask you, like, so when you're saying like 6, like how do you know where you can add the 6? Like how did you know you can add a 6 here? Like what are things you consider, I guess?
Probably what I would consider, one thing is maybe the largest value in there. If you could divide that.
I see. So you have like an increasing subset, and if your new number can divide the largest value, then you can add it in. And why is that? Why like if I had an increasing subset and my subset can just divide the largest value, how do I know the rest of them would work as well? Can we have a counterexample, or does that just work?
There might be a counterexample, because if the largest value is 9, pretend the largest value is 3. No, that might just work. No, it might work if the largest value can divide my largest value, or something like that. Or like pretend I'm looking at 9. Like if something could divide 3, it could also divide 9, I'm pretty sure. Because then you could just multiply it up by 3. It's like some math there that might make it work. Like if something is divisible by it can divide the multiple. Then it could also divide, like if 9 is divisible by 3, maybe from transitivity, I don't know, if 9 is divisible by 3 and something divides 3, I mean, you could just divide 3 times. Like it could break this up, like if it can break this up into like what into terms, like, you know what I mean?
I see what you're saying. So if you had a 9 here, if 9 can divide the 3, the 9 can divide the other numbers because each number is a multiple of the one before, I guess.
Or yeah, like if the largest element here can divide the new number we're bringing in, all of the numbers under it can also divide it. Yeah. Because it'll just divide 3, and then like it'll do that X more times.
So if we tried to add another number here, like what would we check for?
First we'll sort these elements. Right? We'll sort these elements, these nums, but the number that we're gonna try to extend is like 3.
Like, what's a possible number we can add? Like, let's say we have this array. What's another number we can add after this that would work? Like how do we know exactly?
18.
Yeah. Okay.
Yeah.
Yeah. So because it divides 9, it divides the other numbers because each number is like a multiple of the one before.
Yeah, exactly. I think that would work. Let's
Okay,
see.
so if we go with this approach, like let's say we're just keeping track of subsets. First of all, do we need to know like what is this, the count or the length of what does this number represent? The length, I guess.
The length, yeah, the length. These are the lengths, so this would be 3.
Okay. And so your approach is like once I'm on some number, I'll just try to extend every subset I have by checking the last number. So like let's say we have like a big array and we're close to the end. How many subsets can we have already? Like if we do that approach where we just take our number and we just check like does it extend every subset we have? Like what would be the time complexity for that?
Well, we can just check our multiples. Like, wait, let's see.
Right. But for every subset, we still have to check the number, right? So if there's like 1,000 different subsets here, and we're on some number, yeah. Like let's say we have 1,000 numbers, and we're on number 1,000. How many subsets can we have already? Like, can we have 1,000? Can we have way more?
Yeah, we can probably have like 1,000 if we just choose really like a bunch of prime numbers, something like that.
I mean, like worst case. Sorry, worst case. Yeah.
Wait, can you repeat the question? I'm a bit confused of what you're asking.
Yeah. So if we just have like a bunch of numbers here, right? Like 1,000 numbers, and we're on one of the last ones, and our strategies for every number, let's just compare it to all the subsets we already have. Once we're on this last number, like how many subsets can we have already?
Well, we're not gonna like what we're gonna store is like if we can extend one. Multiple one. We can have as many subsets. Like
I guess let's just walk through like the dry run for this case, for this 1, 2, 3, 9. Like how would this work?
Like
and how many would we?
What I'm saying is it could either be exponential the amount of subsets if we're gonna store every single one of the subsets, or it could just be if we find a smart way to remove subsets once we extend it. It could just be like O of n size to look.
Yeah. So is there a way we can make it like with this example? Let's try to figure out a way to not store every subset, because here like we can have 1, we can have 1, 2, we can have 1, 2, we can have 1, 2, 3, we can have 1, 3, and so by the time we get to this 9, we can have more than 3 subsets, right? We can have like some exponential amount if we store all of them. Like 1's a subset, 2's a subset, 3's a subset. 1, 3, 1, 2. You see what I'm saying?
Yeah.
It's not like linear. So how would we optimize that?
Wait, sorry, could you repeat that part?
Yeah. So for example, like if we just store all subsets, like 1 could be a subset,
Yeah.
2 could be a subset, 3, and so on, right? 1, 2, 1, 3.
Yeah, that's exponential for sure.
So by the time we get to the 9, there won't be 3. There might be, like a lot. So if we take that approach where if we just, even if we're only comparing to the last number, if we compare our 9 to every single subset we've made to see if we can extend it, that's still going to be exponential, where essentially for every number we have to compare it to some exponential. So that might be like n cubed or some whatever. So can we optimize that where we don't have to compare it to every subset?
What I'm thinking is like if we could extend one, we can delete the other one too. So pretend, let's start with 1, 2, 3. Let's say maybe we have a hash map. And then first we have 1, and that gives us that doesn't work because it needs to be returned large. Like, does 1 just work, or if 1 would return 1, the subset of size 1? I mean, it needs more than 2 elements, right? At least.
It can be 1, I guess, technically.
Okay, so we have 1.
Like if we have an array of 1 number, we'll get 1. So yeah.
Okay, so let's like loop through this right here. And this is one where I can't think of a top down right off the bat. So if we do 1, pretend we have 2. For 2, we could extend. If we have 2, we could extend. We could extend 1. But how do we know that? Well, we could loop through all the answers here. And then we can go to 2. We can get it to 2 elements, right?
Okay.
Oh no, but we
yeah.
need to output. Do we need to output? Oh, we just need to output the size. Okay.
No, we need to output the whole subset. But let's say we only needed to output the size. How would we do that? Like, let's change the question a little. Like, if we just needed the size, maybe we can do the subset as a follow-up.
So if we need to output the size, we do 2 and 2 right here. When we have 3, we can loop through the values here and see which ones we could extend, and then we can add 3 and then 1 here.
3, 1.
Or sorry, 3, 2, because we could extend 1, but we'll try to extend like the largest one that we're divisible by.
Okay.
Then when we get to 9, but yeah, it will be like a O of n squared algorithm. And we do it for 9, right? Who can we extend? Well, we can 3 can divide us. So if we add 3 there, or we can get to like 3 here. Right? And then we just return the maximum of this. But we'd still have to loop through all these values.
Right, so what would be the time complexity of that?
O of n squared, pretty much.
Yeah. I think that's good. And then, so I'll give you a small hint because we've only done top down. So for rare problems, bottom up is actually better. So whatever you prefer, I guess.
Oh, for array
Most
questions,
of
you're
the
saying?
times-
For array
What was
questions?
that?
Array questions, top down
Not
is easy?
necessarily array, but kind of like with this approach, for every number, you're checking your output you built before. So if top down makes sense, you can do top down. But in some cases, bottom up like just intuitively makes more sense, which I would argue this is one of them. So, but if top down's easier, we can do that as well.
Yeah.
So yeah, I guess
Does this-
bottom up is literally just like you build an output like you were saying, like basically what you described. So
Do you think this solution is going to work? Or we're going the right direction here for O of n squared? We can have
I think this is literally the solution. Yeah, so I think it would work.
But this will just return the size, right? Not the actual output.
Right, so I'm saying let's code the size and let's do like a follow-up,
Okay.
the actual thing.
Okay,
Yeah.
sounds good. Yeah, this is a good question. Is this medium?
Yeah, it's medium, but I'd say this one's harder than the one before for sure.
Okay. To get subset size. We're given nums. Oh, we're given a distinct positive nums. Return the largest subset answer. Okay. So what we're gonna do is we're gonna be given like we're gonna have a path map. This is the same or subset map, and we're just gonna return the largest value. We're gonna store the longest or the largest value of each one, and like the size. Maybe we can use a default dictionary. Sure. No, let's just do this for now. But what we're gonna do is like for num in nums. Like I said, we're gonna sort nums first. That's important part. So we're not. That just helps us like we know. Like pretty much, it helps us allow us to just compare. Like when we're looking at a value, we know all the subsets that we're trying to extend are less than it, so we could just do one equation there.
Yeah.
So for num and nums, what we're gonna do is like if we're gonna also loop through all the elements in this subset map. So all subsets equals dot keys, I think.
Okay.
So this is gonna return the elements in the subset, like 1, 2, 3, 4. Sorry, let me just list this out. So now we're gonna loop for num in nums. What we're gonna do is like, is it actually for subset key in is divisible. We're gonna take the subset key, which should be an integer. Hopefully, let's see.
Yeah, I think it just stores as a key in Python or as an integer already in Python, even if it's a key. So I think you're good.
So we're gonna say is divided by the current num equal to 0. And we're gonna have our best result here. We're gonna try to maximize it, right? So 0. If it's actually divisible, what we're going to do is we're gonna do best result equals the max of the best result here, and what we're gonna do is we're gonna grab all subsets, that subset key plus 1, because that's like I'm extending it.
Mm-hmm.
And then we'll say subset map equals the best result. Subset map of none. Something like that. So we sort the nums. We're looping through all the keys. So let me just walk through the example and then I'll try to catch anything breaking in my code here. But what we're going to do is we start at nums equals 1, 2, 3, and 9 here. Let's start empty here.
Mm-hmm.
So we start at 1. Now it's sorted for num and ones. If the for all subsets, there's no subsets. So it doesn't even loop through here. So 1. The best result should actually just equal to 1 here. Right. So we're trying to maximize.
Yeah.
So
yeah.
1 equals 1. Okay. Then when we get to 2, for 2, the best result here, we're gonna loop through all the keys. So it's gonna loop through 1 here. So is 1 divided? Can 1 divide 2? Yeah, that's divisible. So we could extend here. So if we print the map, we should add like 2. Should be 2. So let me print the subset map. Let's just see if it it creates the right subset map. Yo, chat back. I'm gonna get my friend Richard on. Hop in this. Who's still here? Back. Exit. Matthew, what's up? Yo, Richard.
Yo, what's good?
What's up, man? How you been?
I've been good, bro. It's been a busy couple of weeks, but it's been pretty good. How about you, bro?
Like midterms and stuff?
Nah, I'm on a work term, so like
Ooh, yeah.
yeah. So I just been doing stuff on the side, but yeah, after this I'm probably gonna watch the Rockets.
Oh, the Rockets versus who are they playing?
The Warriors.
Oh, nice.
Big game.
What's your team? You like Houston?
Nah, it's just one of my homies. My homies rock with Houston.
Yeah.
I don't know. I don't really have a team. Like I would say the Raptors, but like we kind of stink right now. Can't lie.
Where are you from? Like Toronto? So
Yeah,
okay,
Toronto,
you don't like
the
Warriors.
GTA area.
Nice. But you
Yeah,
still
how you
not
been, bro?
like you still don't like that team?
Which team?
Or you don't like Toronto too much?
Nah. I like Toronto. I like the Raptors, but like
Yeah.
we're too bad right now.
Yeah.
I don't think we're making the playoffs.
I don't watch Warriors right now. Or no, I don't watch I was watching a bit of March Madness, but I usually watch Phoenix, but Phoenix hasn't been doing
Yeah.
good, so I haven't really been watching basketball
Yeah,
too much.
aren't the Warriors like in the Bay Area?
Yeah, they're literally in SF.
Down. Yeah, the Warriors are looking pretty good. I can't lie.
Yeah. What team or what company are you working for right now?
It's some cybersecurity company. It's called Trend Micro.
Oh, nice.
I'm gonna be honest, I haven't heard of them before. Like I started working, but
Nice.
apparently they're like pretty big in Asia.
Oh, nice.
But yeah, it's been pretty
Sick.
show.
Let's see. I'm gonna bring this thing up. Okay, what we're gonna do today is like let's talk about Waterloo quick,
Yeah, sure.
and then yeah, like your job hunt. We'll check in on all that stuff. Are you looking? What's your background again? Like what? Are you the one with Verkada coming up too? Or no?
Oh no,
Okay.
I'm doing Shopify in the summer.
Oh yeah, Shopify in the summer, and then you're a junior, or you're second year student, right?
Second year.
Okay,
Like
second year
sophomore, right?
student,
Is that
yeah.
what you guys call it?
No, I'm not even from the U.S., but second year
Yeah.
student. So, and then you're targeting maybe FANG companies in your third year, and when you graduate, I think you mentioned that. I forget.
Yeah, I'm kind of keeping my options open. I think like recently I've been more like I've been moving towards like startups a little more just because like a lot of my friends who are working at SF, they're working for startups and like their work seems pretty interesting. I think like ideally maybe like towards fourth year, probably either FANG or like a late stage startup like
I see.
Ramp, Rippling, Stripe.
Nice. Cool. Okay, let me bring up- I'm gonna load up some of the questions I had, but we could just like
Yeah, for
freestyle
sure.
it.
Yeah. How you been though?
I've been good, man. Just working, shooting content. Mostly focused a lot on work. Though. I haven't been streaming that much because grinding out a bunch of projects. I have a ton of projects, dude.
Yeah. Almost 40K, no? I see you're at
Yeah,
39.9K.
it's going crazy.
It's
I've been
huge,
getting like
bro.
1,000 subs every single day.
That's
It's
crazy.
going up.
Yo, 100K soon, bro.
Yeah, I
100K
hope so.
soon.
Let's see. Dude, okay. I'm gonna start up the first part of our video, which is gonna be
Alright, yeah,
I'll
for
just
sure.
freestyle it. And then we'll get into coding questions, right? Let's see.
Coding? Alright, let's see. I
You haven't done it
any
in a while,
coding
right?
in a
What's your last one?
Yeah.
Yeah, I'll bring it up in the thing. Okay, I'm gonna start this up. 3, 2. Yo, chat. How does he sound, by the way? Everything good in the chat? Let's see. Crystal clear. Let's get it. Okay, 3, 2. Hey everyone, so I got my friend Richard back, and this is the same Waterloo student who aced this coding interview. I gave him a strong hire for the first question, valid word abbreviation, and then gave him a hard question he was able to solve. So I posted that about 3 weeks ago. Has 25K views. It's popped off. 412 people liked that video.
Damn.
Have you seen these yet? The stats on this yet? It's going crazy.
Nah, like I see him every once in a while because like one of my friends, they're like, "Yo, is this you? Is this you?"
Yeah.
It's reaching
Dude.
a wide audience.
You caught like your friends are just randomly getting they recommended and they notice it's you right away.
Yeah. They like watch for a little bit and then they're like, wait, this guy sounds kind of familiar, and they check their name tag because like I had a CoderPad account before, so I couldn't go anonymous. So they're like, yo, no way.
Yeah, it's so funny. Yeah,
Yeah.
this thing's popping off. 25K views. It's like my 5th or 6th most watched video. 412 likes. That means, people are really rocking with it. They're like, this guy's actually good. So those guys like
Yeah,
he
it's
survived
huge, bro. It's good to
Waterloo.
hear.
It's like I didn't even know
Yeah.
what that meant. But then
Yo, that
yeah, what does
Yeah,
he
what you
mean by
saying?
that?
it's like a meme that's going on. It's like if you look on TikTok or like Instagram Reels, there's like a before and after photo, like this one Waterloo Eng student,
Yeah,
and it just looks like he went through the most. Can't lie.
yeah.
Yeah, so then like everybody else has been posting their before and after eng transformations, and then everybody's just saying like they've been through Waterloo. Is that one guy?
Like they're literally coming out and they're balding and stuff too. I remember I
Yeah,
seen
yeah,
this.
yeah. They're balding. They like lose the light in their eyes. They got like eye bags and everything. Hopefully
Oh
that's
my
not me, bro.
god. You're only in your third year, right? Serving Waterloo.
Going into my third. I think my third year officially starts like next year winter because I'm taking a double co-op, so I'm a little delayed in terms of courses.
I see. So what was it like going to Waterloo? For background for anybody who doesn't know Waterloo, I mean Waterloo kids literally are invading San Francisco Bay Area. I mean all these companies are straight hiring Waterloo kids and they're not doing it on purpose. Right? I got to the bottom of this. I was figuring out why are so much Waterloo kids in the Bay Area, and it's actually not even on purpose. Like, y'all are just the ones
Yeah.
who are passing these interviews. What are they
Yeah.
teaching you? What is the curriculum like, and how come everyone's so cracked coming out of that school?
Yo, I'm gonna be honest, like, well, when you look at like the CS programs in Canada, I
Mhm.
think a lot of the times the course content is like exactly the same.
Mhm.
Like I've seen U of T, and like sometimes like even U of T's content is harder. But I think like what makes these companies really really like Waterloo is because of like the builder culture that we have. I think the reason why we have one in the first place is because like the co-op program has a really good reputation.
Mhm.
So like naturally all the students who like want to get co-ops, they like go to Waterloo, and then like that creates like a little like hub of like startup people, whatever. And I feel like that kind of like snowballs a little bit, and then eventually like Waterloo gets this like reputation, and then that reputation is like the reason why people come. I feel like initially when I was about to come, I was like, oh yeah, um, like the co-op is good. But then I came here and I just realized that like a lot of the people are like really self-driven
Yeah.
and like really passionate, and I think like that's it's like people kind of like it's like sometimes it's a toxic environment, but I feel like people kind of uplift each other, right? You could be like in a really good position, but then there's always going to be someone who's like that much better, which like kind of makes you want to work no matter what.
Damn. So like the Waterloo kids, everyone's there is like a lot of them are grinders, huh?
Yeah, like I remember for high school, I wasn't really like grinding that much. I feel like coming to Waterloo, I had like my welcome to the NBA moment. It was like
Yeah.
the first guy I met, he already had like 2 internships at this crazy AI company. And I was like, yo, I literally used this app before. How does this guy already have 2 internships in high school?
Dude, in high school? Oh, he got in there in high school after?
Nah, he was like doing internships in high school and was like flying to SF and everything.
Wow.
So then like going
That's
into
crazy.
uni, he already had like work experience.
And then like what class did you meet him at?
I met him just like chilling with some of my friends. Like I met a couple people during O week, and then he was just there in the group. But like generally like a lot of the people that you meet at Waterloo are like super they're like super they work super hard. So then like you feel like if you don't work hard, it's like it it's hard to describe. It's like it's kind of like
Yeah.
if you're surrounded by people who are always so cracked, you're gonna feel like a bum if you like don't really do anything.
And you're saying, I mean, there's people who are cracked, but then, on average, I mean, because there's people who are cracked and there's people who just grind. So
Mm.
are people there cracked and grinding, or some are just straight grinders, or some are just straight cracked?
I think it's both. Like I've asked myself this question before. Like, is it the chicken or the egg? You know, it's like,
Yeah.
do the cracked people go to Waterloo? Is it that Waterloo makes you cracked? I feel like cracked people do go to Waterloo, but I feel like the culture at Waterloo is like what kind of like. Because some people are like super smart, but if they don't get their name out there and then like not applying themselves, like you won't really know that they're cracked. But I feel like Waterloo, like whether you're cracked or not, kind of forces you to apply yourself. So then eventually you get labeled as cracked.
I see. Okay, so how do you even get into Waterloo?
I think there's a lot of different options. Like you can either go the engineering route. So in terms of tech, I think the main like engineering faculties you want to target would be software engineering, which is like I believe it's the most like famous and like notoriously difficult to get into. And then you have computer engineering, electrical engineering, and system design engineering. I know system design like they're very notorious for like having a high co-op rate. So like a lot of students end up getting employed during the co-op cycles. Or you can go like the math route, which is to either apply for like CS, which is a program that I'm in, or math, or some called CFM, it's like computing and financial management. I think like you can transfer in between. I know a lot of people they try to be like either ECE, SC, or CS. And I know like for engineering, they look at a more holistic application. Like they care a little less about grades and more about like your ECs, what you've done in high school, like where your engineering passion comes from.
Yeah.
Meanwhile, CS is like pure grade grind. I remember like I think the cutoff is like a 95 high school average,
Wow.
but like to be competitive, you have to be like in the 98, 99s.
So you need 98. Okay, so CPSC. So you're in this computer science program, right?
Let me take a look at your stream.
Well, like, what's your degree right now? Bachelor's of Science in math or Bachelor?
I think it's Bachelor's of Computer Science, so BCS.
Okay. Well, no, it's probably a Bachelor's of Science major in computer science, right?
I remember I checked my transcript.
Okay.
I thought it was Bachelor of Science too, but I think the official one that they wanted to put on our resume was Bachelor's of Computer Science.
Okay. So you have a Bachelor's in computer science. So you're just taking the traditional computer science route, right? Because yeah, there's like electrical eng, there's computer eng, but yours is like strictly CPSC. What's the difference between SWE and CPSC in Waterloo?
I think the main difference is that their course load is like harder.
Yeah.
I'm gonna be honest. I think like it's harder to get in, but like their course load is like engineering on top of like computer science / math. That's why their like faculty kind of sits in between both math and engineering. Like I think they get a math degree and they also get like the engineering iron ring.
I see. Okay.
They also have a smaller cohort, so like all their classes are like predetermined and they'll always have their classes with like their 100 or so people. I think like speaking from experience, like SE probably has the highest density of like cracked people. From what I've seen, like a lot of the SE people are actually like crazy. I can't lie.
All right, that's crazy. So, for high school, you got over a 98 average.
Yes.
That's
so I
wild.
went to like a private school, so I think like that's part of the reason because like I think they're kind of notorious for inflating their grades. Like when I look back at some of the work I was doing, I was like, this really isn't worth like the grade I got. But I think like that's just how it is.
I see.
But yeah,
Okay.
it's like a lot of grindy people. I'm pretty sure that's why like a lot of grindy people end up at Waterloo.
A lot of private school students, or not really? Or is everything?
A lot of IB.
IB. Yeah.
Yeah, a lot of people I meet are like IB.
Did you take IB?
No, I went down the AP route.
Okay. Nice. So what was your first year courses? What did you take? I'm just trying to understand, like how this all went.
So my first year courses, I had two math courses, I believe. So one was called Math 135. This one I think was just your standard like discrete math course where you learn about like
proofs and stuff.
Proofs, logical statements,
Induction.
all that.
Yeah.
Yeah, and then we had like Calc 1, which was Math 137. I know U of T has one as well. So this one you learn like standard like Riemann. Actually, I don't even think you learned Riemann sums yet. But I think it's like delta epsilon proofs.
So this is not basic. Just because limits and stuff are just pre-calculus, right? Or no, that's calc. You didn't learn limits.
Yeah,
and derivatives.
We did learn limits. It's just that I think U of T and Waterloo goes a little more in depth into like epsilon proofs for calculus. And then I took a CS course called CS 135. Yo, they made us do this in like a random functional programming language called like Dr. Racket. It was Yeah, yo, I don't know. I didn't really like it too much, but I guess like if I ever do functional programming in the future, I guess it helps there. Um,
They're not teaching you basic. What is a array? What is a? How do you do a loop? Like, what if no one ever did
yeah,
comp sci yet? There.
yeah. I don't know. They started us off with functional programming, but then like in our second semester, well, I'll get into that
Yeah.
later. But like in our later semesters, we start with like low level programming in like C and C plus plus.
Okay.
Um,
So what else are you
yeah,
taking?
and then something interesting about Waterloo is that we do like something called like your communications courses. So you're required to take two. I think it's because a lot of Waterloo people end up being like very antisocial
Yeah.
and like don't really communicate their ideas too well. So I think like these classes were meant to kind of, I don't know, like I didn't really find it that useful towards communicating better,
Yeah.
but I think like that was the purpose. You have to take two, one in your first semester, one in your second semester. So I took public speaking in my first semester, and then you have like an elective. So I just chose econ.
I see.
Um,
So
I
one
think
CS
it
course
was
only, first semester.
yeah, one CS for first semester.
Econ, macroeconomics for all the learners. Like
Yeah,
supply and
I
demand,
think
or they're going.
yeah, it was like before you kind of split off in a macro and micro. I forgot which one
Okay, I
it
see.
goes deep into though.
Okay,
Like I
so
didn't
they
really
they
pay
go
attention
they
to
gloss
that
over
course.
high level macro and micro, but don't dive deep into a specific one.
Yeah, it was like they probably did end up diving deep, but I just like after that class, I just kind of released all the info from my brain,
I see.
so I can't even remember. Yeah, I think it was micro though. Yeah,
Okay.
I think it was micro. And then my second semester is when I took CS 136. So this is like a low level programming course in C, and here we also had a lab that taught you about like bash scripting, um, like uh like command line, like the simple command lines commands, and then also like testing suites, like how to create your own testing suites.
I see.
And then we also had like yeah, so low level programming, it was just like a little bit of data structures. It wasn't focused on data structures, but we did end up covering like some very basic stuff like what you'd see on LeetCode. um and then we had two math courses again.
Damn.
One was linear algebra,
Okay.
one was Calc 2. Calc 2 I think was low-key easier than Calc 1 because Calc 1 went into like some like things that we haven't learned before, but I think Calc 2 covers like the standard, like what you'll learn in like high school calc. My
Like,
second
find the area of this curve. Kind of thing.
yeah, like simple integration. And then I think like I guess the difference between like that course and like high school is we learned like some like formulas to like or some like
Like
for like
infinite
Riemann
equations.
sums.
What do you say?
Yeah, it's kind of hard to describe because I'm trying to like pull it out of my
Like
my
summations and
memory.
stuff, or like you're looking at
Yeah.
sequences, and coming up with equations.
Oh
of
yeah, we also had a
sequences.
lot about sequences. Yeah.
Yeah. Okay. Yeah.
Um.
That makes sense.
But yeah,
What
standard
else?
like Calc 2.
Yeah. Calc 2.
Had my second communications course. That one I
Oh,
did
nice.
something called digital lives. Still couldn't tell you what that course is teaching. Like, and then my last course
Wait,
was
they're asking if you learned Taylor series. I think you learned Taylor series in
yeah,
Calc 2. Yeah.
We learned Taylor series, I believe. Um, and then my last course was psychology. I did this one online, and like low key, it was my worst course because I kept on missing assignments. But um,
So one CS course again. So two CS courses for pretty much the whole first year. Is that standard usually for?
yeah, that's like standard. But then like year 2 and year 3, it gets crazy. I think like I'm not projected, but in my next semester, I'll be taking like 3 CS courses and a CO course.
Are you
But-
are you about to get into your third year, or you're about to get into your fourth year? Oh no, you said you're in second year. only?
Yeah, so I completed the first semester my second year.
Okay.
I was supposed to take my second one in the summer, but because I'm doing Shopify, I pushed that one back to winter or
I see.
fall.
I see. Wait, so you
Yeah,
only did 3
so
semesters so far?
yeah, only 3 semesters.
When did you start?
Fall 2023.
Okay. Well, 2023. Oh, you
Yeah,
just
it's
had a bunch of
2025 maybe.
internships? Oh, yeah, your
Yeah, this
internships
is
were kind of
my
taking up your thing because you've only done 3 semesters.
yeah, like the way Waterloo does co-op is that you do 6 co-ops that are 4 months each.
Yeah,
So usually like you do 2 school and then alternate co-op or like there's different like we call it sequences.
I see.
So like there's different like patterns that people take.
I see.
But like one of the reasons why I chose CS over SE is because there's like a little more flexibility. Like I think in SE you'd probably have to skip a year. Like you'd be a class of like 29 if you wanted to like change your co-op sequencing.
Yeah,
But I think CS made it a little easier for me.
I see.
So um yeah, I think like what Waterloo wants to do is like in 5 years you'll have a 4 year degree and like 2 years of work experience, but you like compromise your summers.
Yeah, I see.
Yeah. And
So,
I don't really mind. I don't think I'm doing much in the summer
yeah.
anyway.
Okay, so for how was it taking these courses? I mean, the math you probably shared those with a bunch of other degrees. Maybe discrete math you had to
Mhm.
take with just comp sci kids and other ones, right? But Calc 1 is
Surprisingly,
general.
yeah, surprisingly, first year, like everybody in the math faculty takes the exact same courses.
I see.
So like CS, CFM, like normal math with honors, we all took the exact same course load. But then later on, like year two, year three is like when you kind of like split a little bit. I think math goes more into like deeper math, but CS
I
starts
see.
to yeah. So my second year, like first semester, I took 2 CS courses. One was like logic and computation. This one, oh my days, I think it was like I hated this course. I think everybody hated this course. I didn't do bad on it, but like I think just learning it like it kind of like I lost a little bit of my soul trying to learn it.
What's
It was
this
like
course called?
logic and computation. Oh yeah, and if you want, like you can go on this website called UW Flow and um search up like the course names I'm telling you, and then I'm pretty
Okay.
sure you can get like yeah. So if you search up
I have to log in
CS
real
two
quick.
45,
Is this the one? Are you on my stream?
yeah, I see it. Yeah, that's
This
the
one?
one.
Okay, let me log in.
I think you can just explore without logging in.
Oh, really?
Yeah.
Oh, should I already logged in? Okay,
S-
what's this one called?
CS 245.
Logic and computation.
Yeah, bro, this one was terrible, man. Like, yeah, like you could see the reviews, bro. Like people thought it was like fine in terms of difficulty, but it was just like so
This is like.
in my opinion, it was so useless.
Does it talk about like
But like,
DFAs and NFAs and stuff like that? Or what's it talking
nah, it was like we started off with like an extension of discrete math, but then we started like doing like really long logic statements and then
I
like
see.
Turing machines and like
Okay.
correctness, validity, all that stuff. It was definitely a course.
Does it show the
but,
notes? Professor reviews. Bad. Like
yeah,
this guy got bad ratings.
7%. I don't think I had that. Okay.
Okay, so this is more like they're just trying to improve your logic skills essentially.
Yeah. And then we had like yeah, Turing machines. We
Yeah.
had like the halting problem.
I see. Yeah.
That one. Yeah, I still think to this day I don't understand the halting problem. Like I think I just memorized how those answers are supposed to be
Yeah.
done, and then I just like wrote that on the exam, and
I see.
I prayed. But
Yeah, they
um
taught that in my school too for second year.
yeah,
What else
I
did
don't
you
think
take?
anybody liked it there too, right?
Yeah, no, that course. Lots of people failed that course. Sorry.
Yeah. And then the next CS course was It's called CS246. This one was actually very useful. It's like C++ object oriented
Finally,
software.
they're giving you.
Yeah, finally
It's like,
some real
what's
coding.
going
You know,
on?
no more C, no more racket.
Bro,
I mean, I guess like C is real coding.
that's crazy.
But yeah, this one just like taught like object oriented design, like inheritance, pointers, all that kind of
Nice.
stuff, like pretty deep. And then we had like a final project where we just like work on like a game.
Yeah.
I think it's pretty standard. I've seen like most schools do some variation of it, but this one was pretty useful. I think a lot of the concepts I learned here I still like use if I'm doing like system design or like even if I'm coding my own projects.
Yeah.
And then I did.
Wait, Paul's asking what's automata? Did you have to do that? Work on the automatas at all?
I don't think so.
Like state machines, I think you're talking about, Paul.
Yeah, state
Yeah,
machines.
like state machines. Like you go from. Then there's like the yeah. We had to do that in my school. That's so funny. Everyone's kind of doing kind of similar stuff in their classes.
Oh, I don't think we call it NFA or DFA. This looks kind of familiar.
Yeah.
I don't know. Like I think all the course contents have been flushed out of my brain already.
Okay, finally, second year is something that you're gonna use in your job. I mean, the other stuff is still useful. Obviously, you need to like build a base for.
But it felt more like
knowledge.
a side quest than anything.
What else did you take?
I took linear algebra 2. This one's called Math 235.
Yeah.
Um,
How's that?
Honestly, I think it was pretty interesting. I took it by accident though, because I thought it was a prereq to like the machine learning courses.
Oh.
Turns out, I think CO like computation optimization. I think that one is the actual prereqs. But this one's pretty interesting. Like you learn deeper into lineage.
You do some proofs on it or no? Proofs on it?
Yeah, there's still a lot of proofs. Like I think the thing that Waterloo does different is that they teach you like for exams you have to solve proofs instead of like just application questions.
I see.
It's like a little bit of both.
I see.
So we learned like singular value decomposition, like deeper into like eigenvalues and stuff.
Yeah.
I low-key forgot a bunch there too, like off the top of my head. This
How
course
are
is,
you
like,
doing in those courses? Are you like acing them or doing medium or like tanking them?
I don't really know what like acing means. Like I'm not getting like hundreds or like high 90s.
Mm-hmm.
I'm getting like mid 80s.
Nice.
I think that's where my average sits right now. And then I'm trying to think like what other
Do they
courses.
curve it?
If it's really bad, they like if everybody's doing like terrible, they curve it by a little bit. Like I know our CS245 midterm got curved by a little. It's like a slight curve by like 7% because the midterm I know like it was pretty rough.
Okay, so someone's asking how does GPA work in Canada or just in your school? How does GPA work? You get a letter grade and it gets converted to a GPA? Or like, can you
I have
explain
no
that?
clue.
You don't know how the GPA works?
Yeah, I just like take my average and then there's like a little chart that we map it to and I just have my friend do it. And then
really?
I'm like, okay. But then I stopped like really caring about GPA after my first couple internships. So I just didn't really bother calculating.
Yeah. I think in my school how it worked is you get like a 85 to 90, that's an A minus. You get a 90 to 95, that's an A. 95 to 100, that's an A plus. Right?
Damn.
So A and A pluses is 4. A minus is like a 3.7. B plus is a 3.3. And then those get converted, that's your GPA grade. And they just like divide those and stuff, like add them all up and divide it. That's kind of how our GPA works.
Yeah, I think like we have a chart. So like
chart. Interesting.
I'll send the Reddit link. Oh yeah, the thing I sent earlier was like the Waterloo meme. I don't know why it says has a weird hyperlink.
Yeah, I see this.
But this Reddit one is I think what people usually use. Okay, wait. Yeah, I don't know if it's actually this inflated because my GPA like sits in a range, and I know my GPA definitely is not that high. Maybe I should just like put my GPA higher then.
Yo, chat, this is the Waterloo guy. That's actually so funny. He's so happy, and then
Yeah.
he's just now he's a bit more blind, staring at the computer all day. Got glasses.
Yo, what's actually funny is that the photo is reversed. Like the one where apparently like the dude who like released the photo, he said like the one where he's looking rough is like when he started
Oh, I
Waterloo, and the
see.
one where he's looking better is when he finished.
Bro, that's
It's
funny.
still hilarious.
So okay, let's get back into. So you took. So how was the CS course there? Is like a bunch of the kids cracked? Do you go into the course and kids are not even pulling their weight on the assignments? How does it work? Like, let's talk about
Um,
object oriented class specifically.
I'm not gonna lie, like I think when it comes to, like the cracked atmosphere of Waterloo, I think like the top 10% are like really cracked, and then and I think like so like I was kind of surprised because when I came to Waterloo, I saw a lot of people like actually weren't putting in too much like work into like courses or like their side projects and stuff.
Yeah.
Um, but it's pretty funny. Like I don't think anybody like really puts their focus on like courses in general, and this includes like the cracked people. From what I see, like uh a lot of like my friends and like everybody in the class is like kind of like actually wait,
Focus
no,
on
never mind.
internships.
Nah, I was about to say something, but like in case like the dean or someone is watching, I can't say
Yeah.
anything more. But yeah, well, we're like doing our work pretty diligently, you
Yeah.
know. Yeah. Um, but yeah, I think a lot of people like study together. Um, it's like no one's really like too pro. Yeah, I think it's like your standard school experience. It's like, you know, everybody's a crammer, everybody procrastinates.
I
It's
see.
just like some people at the top are like just really crazy, and like they do a lot of stuff outside of school and just have like crazy CVs.
So a lot of the people are pretty entrepreneurial. You think?
Yeah, I mean, it's like some people are entrepreneurial, but from my experience, most people are just like really, I don't know how to describe it. It's like they're not the kind to really start a startup, but they're like the kind to be like really proactive and like learn on their own time and like really apply themselves, like get themselves out there, and like they end up getting like crazy cool internships in
Yeah.
like SF where they work for like some of the most like innovative startups.
Yeah. That. So what's like the lead code culture? I mean, y'all are good at lead code. That's why you're getting in there in the first place. It's like everyone already spamming lead code by the time they're in their first year, second year, or sorry, first semester, second semester.
Um, from my experience, like no, not. I think like people don't end up doing leak code a lot until like second and third year. Like I didn't really leak code that much until like this year December, um, or like last year December. I think like later on, some people go like the startup route, so they do like some leak code, but then they end up spending most of the time like building projects, attending hackathons, like flying to SF to work with like labs. But the other half, like they're going down like the big tech route where they need to do leak code, so they end up like grinding a decent amount.
Is it like half half? Like what's people's goals mostly? Do everyone trying to get into Fang, or every like people are also don't care for Fang at all? And someone
Um,
asking how many leak codes have you done?
Let me check. I haven't checked in a minute. I think recently I've been working more on side projects in leak code. I'm 597.
Holy crap, dude! And how long did you take to do those? You have almost as much as me.
Let's just say like January, February, March was a rough triplet of months.
God damn.
I think I think that was when I did the bulk, but I think before that I had around like 110, 120
What's your
solved.
breakdown? How many hards and mediums do you get?
I'm 172 easy, 376 medium, and 49 hard.
Holy
So I try
crap.
to focus more on mediums.
Yeah, you have like the same breakdown as me. Damn. And I've been doing lead code for a long time. You almost have as much questions.
But now I'm probably gonna slow down. I think like I've already
Maximize
I
it.
don't. Nah, I feel like lead code's kind of lost its like. I remember in like January and February it's so fun, and then like now it's like a chore to even do like one a day, like the daily.
How many questions were you doing in a day?
Uh, let's see. I think like some days I'll just get back from work and then just like literally do nothing but lead code. So I think in those days I'll like, well, not really days. There are maybe like 2 days where I like get 20 down, but then like I think on average it would be like 3 to 5 a day, and then I slow down. Now I just do the daily.
You still do the daily?
Yeah, I try to do the daily. Sometimes like I get like sometimes I couldn't really be bothered, so I just do it to like keep my streak alive,
I see.
which I lost recently. That was the most tragic day.
How long was your streak?
Um, is so in terms of submission streak, it was 57 days, but my daily streak was 75. I ran out of like the time travel tickets.
Oh, okay. I see. I see.
Yeah,
No, that's actually insane. There's even kids
like
at Waterloo who are Grandmaster Code Forces. One of my friends was sending me some guy who was Grandmaster Code Force.
yeah, dude, like some people are like crazy. Like they like don't do elite code because it's too easy for them. Like the hardest elite code is probably like a chill question for them. Like
That's
these guys are the people who are like international coding Olympiads, like CCC. Like 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 these are the guys you're competing with if you're trying to get into quant. Like I know one guy's in quant right now in Chicago, and he's like insane, bro.
yo, that's
But
crazy. How'd you solve so much questions though? Were you already good? What was your steps to getting good at lead code?
uh, so I followed the neat code roadmap, but I think like my main like strategy was just to do it. Like I realized that like I could be like sad that I wasn't cracked at lead code, but I realized that like most people they didn't really start like quote unquote cracked, right? Like, I think
Yeah.
a lot of times like they had to start somewhere. So I realized like the only difference between like me and like a version of me where I'm good at lead code is just like the fact that I have to like just do it, like, and like stay consistent.
Hmm.
um I I, I recently wrote a blog about this.
Oh, you blog it out too?
Lokeka.
You
Nah, I just started like
nice.
I seen some people blogging at my school, and I actually like really enjoy their blogs. So I was like, okay, I'm just practice
Yeah,
reading one of
drop it,
them. So I
drop it.
could,
It's good.
yeah, I'm gonna do a shameless
It's
plug.
real good stuff. No, you gotta do stuff to get yourself out there. Honestly.
Yeah, that's what I realized. I think like working working like kind of like corporate and maybe big tech. I'll I'll see how big tech is, but I think like I'm still missing like kind of like an itch to code. I think that's why I'm working on side projects. So maybe like next time I'll explore like startups, which is why like I started like revamping personal website
I
and
see.
like
So what's this one about? Lead code
writing
and
blogs.
discipline?
Yeah, I plug your video at the bottom.
Hey,
Yeah,
I'm gonna plug
but
this one too. Holy crap.
appreciate
Yeah,
it.
what's like the TLDR here? I'll read it. I'll
Uh,
do a video reading this actually, but just explain it real quick.
the TLDR is like some things will be. I think I have to talk a little quieter now. I think like the people in my house are asleep, but um, the TLDR is like leak code is kind of like one of those things that you have to do if you want to, achieve your goals.
Yeah,
So like what I realized, like kind of in the time that you spend like not really doing much, like you might as well like challenge yourself because like that's kind of what causes growth,
hmm,
and it's kind of just about like staying disciplined, being consistent, and then just finding ways to like make it easy to stay consistent. Like leak code makes it really easy. They give you like company lists, they give you like dailies, they give you contests. So like to really like just show up and do one question a day is like my like non-negotiable. And I
yeah,
think like by kind of just being able to brainlessly pick a question is what really helped me stay consistent. And then once I started one, like I wanted to explore more.
I see. Oh man, you're
But
on
I
the
remember
right
like
path. Like second year, already have a few intercepts. 40K subs, let's get it.
40K,
Yeah, just passed
huge,
it.
bro, huge. Yeah,
Nice. Yeah.
I
'Cause
mean, yeah, I think like, what was I gonna say?
seeing the chat.
Yeah, I think like, yeah,
So how do
40K
you
is
how do you
huge,
actually
bro.
survive water? Okay, so this is all you've took so far, because you're gonna be only going to your second year sem 2, right?
Yeah, I took stats as
Oh,
well. It was like a
stats,
basic stat course.
stats basics, like yeah.
Uh, yeah, like it starts off with probability and then goes into like the distributions and
I
stuff.
see.
Um, yeah, and then like after the summer, when I go back, I'm gonna be taking my second sem of second year. Like those classes will be like compilers,
I see.
uh, like yeah, compilers, data structures. Our school does something weird. It's like we split data structures and algorithms. I think second year you learn data structures, and then third year you learn like algorithms.
I see. I like that actually.
Yeah. So I think like yeah, we have CS compilers, CS data structures, we have CS computer organization. I think like it's called CS 250. So I think like that's when you start.
Damn.
Oh no, that's not OS
So
yet.
where's all the practical stuff? That's what I'm thinking. I mean, this is similar to how my school did it too. I mean, data structure algorithms
Yeah.
are practical and stuff, but where's like the software engineering large? Where's the like large scale data, distributed systems?
That comes in like third and fourth year, and that's
I
like
see.
what when people start taking like things as optional. So there's like networking,
Yeah, exactly
there's
that
concurrent
stuff.
programming. Yeah, there's distributed systems, there's OS. They're all stuff that I'm looking forward to.
Yeah,
I think like yeah, I think like this is pretty standard for like all CS. I think the thing that kind of makes Waterloo stand out is just the co-op.
yeah. I mean, like, what? How'd this guy turn like this though? What they do to him? Like, which course?
That's engineering.
Oh, it's
Yo,
engineering.
I can't tell you what happens to engineering, bro. Like I seen their course load, like they be taking like 8 courses, bro.
That's crazy. So what's next for you? I mean, this is solid stuff that you're learning. What courses are you interested in that they're offering in your third and fourth year that you're gonna definitely take? Like, what are you
Probably
planning
like
on taking?
networking,
Yeah,
concurrent programming, distributed systems. Like yeah, I recently like wanted to learn more into that because I think like engineering those systems are like pretty cool. Um, and I think like going back on leak code, like I think the first 100 or so was like extremely like tedious, extremely hard. I didn't really feel like I was like learning much. I feel like most of the problems I was like cheating, not cheating, but like looking at solutions
yeah,
on leak code. I think like eventually like as you go topic by topic, like you see the patterns, and I think like that's why I grinded a lot is because I found it kind of fun.
yeah. No, I found
Yeah,
it kind of fun too. And bro, you're
yeah,
way
yeah,
ahead of
exactly.
everyone, because you
Uh,
grinded it in your first year. I was grinding leak code right before I was about to graduate, and
yeah,
I already had. Bro, I was grinding leak code when I already had interviews lined up where I knew they were gonna ask me leak code. I opened it up for the first time. And I was just grinding. But the thing is, I already
yeah. I think
took the data structures and algos class, so I kind of was able to ramp up faster, because I didn't have to really relearn a lot of this stuff. But
mhm.
but a lot of the when I took data structures were really literally like writing the algorithms on paper, or like proving the algorithms on paper, not
Yeah,
actually writing the code. So even that still tripped me up.
bro. I'm gonna be real. Like the only reason why I have this many souls is kind of it's like low key like pure degeneracy, bro. Because like I remember one of my homies in like first year, he like set a goal for himself
Yeah.
to like do lead code every day, and he ended up doing 1,000 in the year
Whoa.
as a first year. So I was like, yo, what the hell? So then
Yeah.
so like he like inspired me. So I was like, okay, this year I'm gonna like lock in. Like before I wasn't really doing that much lead code. And then I was like I wasn't really confident in like interviewing.
Yeah.
So I just kind of figured like, if I like if I'm confident that eventually I will get the interviews, like I should probably just prepare now. So,
Yeah.
later on, it's not that big of a struggle. But I think like now it's kind of different because I think the companies that I want to like interview for like don't really ask like leak code. Um, I'm thinking like maybe for my next co-op, I like go towards like the SF startup route.
Yeah. So they're gonna ask you a lot more practical stuff.
Yeah, like I know like one. Well, I don't want to jinx it, but like I have one coming up that it's just gonna be like an hour, and then we just like build, and that's it. Just like an hour, and they watch me build like a mini project.
How are you with that? Like how good are you with that? Because I know you're good at leak code. What about other stuff?
Um,
Like
I'd say like I have like it's like I have like the belief that like I can figure something out. I'm just like scared like in an hour. Like there's like a lot of small stuff when it comes to setting up a project. Like what if I forget how to like create a Next.js app or like set
I
up
see.
my API. It's like just like really
Yeah.
small stuff. But like I think in terms of like general like working on repos, I think like I can eventually like figure it out.
What kind of side projects are you working on? Like what kind of stuff are you learning? Are you learning full stack, CSS, React?
I think right now I'm working on like full stack applications. Like a couple of first years, bro. Like, yo, it's crazy. Like, there's a couple of first years like having like some crazy side projects,
Yeah.
and then I was like, oh, this probably just vibe coded.
Yeah.
And then I looked into the like repo. I looked into like their write ups. I'm like, bro, this is really good stuff. It's
Yeah.
very clear that like it's like they were the ones like using the AI. It wasn't like the AI just doing whatever it wants.
I see.
So I think like um yeah, so that's kind of inspired me to like make a couple like tools that are full stack and eventually like deploy them.
Yeah.
Um,
Bro, so how do
but
you break out your day? When you were
I,
grinding
I'm
leak
like
code with school and stuff, like how are you breaking up your day and how are you breaking up now? Like how are you managing your time? Because you're getting a lot done.
um surprisingly I actually like don't do that much during my day. I think so like when I started like my first like spurt of lead code grind was searching for my second co-op. So the way our school does it is like um we have a job portal and then we split our co-op search into cycles.
Yeah.
So each cycle like new jobs will be posted. So like my priority was like, okay, I remember like first year, yo, do not take me back to second semester. First year trying to look for a job, it was actually like fighting for scraps, bro. Like I swear, like me and my homies were like we're all unemployed and we're like dreaming about this like unpaid in like the middle of nowhere. And, like, yo, please take me.
God damn.
Like, but like, bro, first year had me so down bad. Like, um,
Bro,
it's like
the crazy thing is too, that's in your first year. Y'all are really ahead of the times because you're in your first year really worried about an internship versus if you compare to other schools, they're not worried about that in their first year. Nobody
yeah,
grinded leak code in their first year.
but like the way I like to think of it is that it's like less of the person, but more of like the environment.
Yeah.
Like if Waterloo didn't have a co-op, I think not, I wouldn't have done like that much lead code. I wouldn't have been job searching. I think like because it kind of forces you into like the situation like obviously it's gonna suck, but I think like eventually like it does pay dividends, which is what I'm grateful for. um
No, it's
I
gonna
think
pay a lot of dividends. You put in the work early, and it's just gonna grow exponentially. All the work you
yeah,
put in early is gonna pay off
that's
hard.
my hope, bro. Fingers crossed, fingers crossed. But um yeah, so like second co-op search, it was like semester one of my second year, and I was like, yo, I'm not gonna let what happened last time. Like I think I was job searching during final exams at the buzzer beater and unpaid co-op. Like genuinely the worst semester of my life,
Yeah.
bro. but but yeah, so like I was really committed to like getting it done semester one. So like grinded a little bit of lead code. I think like I would have my classes, which I stopped going to after like 2 weeks. Um and then I like really spent my time like doing a little bit of lead code, working on my resume, um, working on side projects. So like most of my day I would do that, and I think like after I got a Cycle 1 job, so it's like the first month of school,
Yeah,
yeah, I stopped lead coding entirely. I think if you look at my like lead code submission history,
I see.
it's just pure white for like 2 3 months. Um,
So you think that just it's the you're pretty much a product of your environment. Like everyone's
yes,
grinding around you, so that's kind of what's pushing you. If you're in
hundred
a
thousand percent.
if you're like if they weren't doing that, you think you'd be able to get up and motivate yourself still, or no? You think
It's like 50-50. Um I think like it'll definitely like push you, but like at the end of the day, like you're the one who puts in the work. And I think like when I started lead coding, it was like the start of my huge lead coding streak started at like mid-December. So this was like after the second school term ended. And then I kind of realized like I wasn't really happy with because it's like FOMO. It's like I see a lot of my friends getting co-ops in like San Francisco, New
Yeah.
York, and they're like getting paid a lot. And then I was just kind of like, yo, well, like what am I doing? It's like I have so much time, but I'm not like using it properly.
Yeah.
So then like kind of like that winter, I don't know. Like I still remember the feeling I got. It's like really like intense, like not like I don't know, not
Like you
yo,
felt
not
like
to
you
sound
failed.
corny. No, it wasn't like a failure feeling. It's just like huge like motivations.
Yeah.
It's like I just like I was like kept on telling my parents like, bro, I want to go to US. Like, I want to go to US so bad.
Yeah.
And like as corny as it sounds, like I think that's what kind of like pushed me. And I was like, you know what, like everybody who I know who's been to the US has like gone through this before. It's like why not just like start it now when I don't have anything else to do?
Yeah, it's a grind to get into US, bro. Honestly.
Yeah, bro. Like I know you relate to this like coming from Canada, bro. Like holy, like Canada to US is like so difficult, bro.
And everyone's trying to do it, right? You have to
Yeah,
compete with, like when you apply to SF, you're competing with the Berkeley kids who live right there, Stanford kids, all the
that's what I'm
UC
saying.
schools.
Yeah, all the UCs like CMU, MIT, but like at the end of the day, it's like those schools can only like produce so many engineers, and like there'll definitely be like spots for everybody if you like try. But like I think what people like misunderstand is like I don't really spend that much a day like grinding. Like I think I still have a pretty like relaxed lifestyle. It's like
Hmm.
today I didn't like today I woke up at like 11.
Hmm.
I watched a soccer game.
Yeah.
I like kind of like literally, I kind of just chilled for a couple hours, and then I went like ran some errands. Uh, went to the gym, and I came back. Like I didn't really do much work today.
Yeah. No, it's crazy. And then where do you think you are in the pack? Like middle of the pack, top of the pack, bottom of the like what is a cracked Waterloo kid and what is some like are there people just flunking out? They can't handle the
Uh,
pressure?
Not that I know of.
I see.
Like I don't really know where I sit. I think I think like something about Waterloo is that you also see like the survivorship bias.
Yeah.
Like you'll see like the top 10%, which is like still a lot of students, but like those guys are going crazy. But then they like assume that like every person from Waterloo will like um but I'm still in second year, like I can't really say yet. I think um I think I still have like a long way to go before I become like cracked at Waterloo. Like kind of knowing the people that like they like inspire me and like you know that I like see what they're doing. I'm like, oh yeah, I wanna. They say I wanna work on this kind of stuff too. Say I wanna work towards this. Like I still have like a long way.
Yeah. What's your goals? Are you trying to get to like a staff? Are you trying to be a CEO? Are you trying to make like $1 billion in Silicon Valley?
Mm, I don't know yet. I don't think like CEO is really for me. I want to join like I think right now where my passions are. Is I want to join like a really early stage startup, like an engineering team of like 4 or 5. Just like grind as hard as I can with them, and just like it's like if it works out, like I'll be lucky, you know. Like if it doesn't really matter. It's like it's still an experience because I don't think like I think like eventually I want to end up at like late stage startup or like big tech and then maybe climb the ladder. But I'm still like kind of unsure like what specifically I want to work on. Like whether it's, you know, like SRE, cloud, cybersecurity, or like full stack.
Yeah, but you enjoy it so far, like coding and all that stuff.
Yeah, I think before I was like, you know, just whatever. But I think like recently, part of what's like kept me going is like I found out that like I really enjoy this stuff. Like I don't think I could imagine myself doing anything else.
Yeah, I feel like since you grinded it out, you started doing all these legal questions. You realize you're kind of good at it. You realize that it's fun when you could solve questions, and it just
Yeah, yeah,
reinforces that behavior.
yeah. I'm not gonna lie. Like lead coding gets like addictive once you get to like that spot where like your progress kind of skyrockets because you learn the foundations of all these different algos and you start applying them. And I think like after a bit, it's like that kind of wears down a little bit. I think like even though I've done like a lot of problems, I haven't done like the most review. So like going into an interview today, like if I were to interview for like Meta, like I would like believe in myself, but I wouldn't be like, you know, like extremely confident.
Yeah,
You know what I mean?
yeah.
It's like what if they ask me like a linked list problem, which is like my absolute least favorite topic.
I see. That makes sense. Cool. That was a
Yeah.
good topic. Let's hop into coding interview then. Since we're talking about that, we'll run it similar to last time, and let's
Mhm.
see how well you perform again. But that was
I
good
hopefully I don't
talk.
drop a stinker.
Surviving
Yeah, it's
Waterloo.
fun, bro.
I finally got my insight into Waterloo. What's happening? But we'll keep doing more
Yeah,
checkups when you get through. Maybe a few
yeah,
years
for
from now
sure.
too. If you're working down here, I'll see you. But we'll catch up on all this stuff. But that was a good chat. I have a lot of friends from Waterloo too, so I'm gonna send this over the
Yeah,
video.
yeah. It's almost like unexpected like how many Waterloo people have invaded SF, right?
Yeah, there's so much Waterloo kids I know. I'm friends with a lot of Waterloo people. But that's so funny.
Yeah,
This I'm gonna read this post. Maybe I'll do a whole video on it because I think it's interesting to understand how people actually get good at lead code as a student.
yeah. I'm still trying to work on like my writing skills, but I just kind of like dumped all my thoughts
Nice,
into like a blog.
nice. Yeah, I'm gonna
Yeah,
read this. Do you like Atomic Habits? That's a good book.
yeah. I think like that was like part of the inspiration. It's like when I thought about like how I approach lead code, I was like, you know, I like kind of subconsciously apply like the things I learned in this book.
Yeah, dude, that's crazy. All right, I'm gonna end this one video and let's get into the coding challenge.
I bet.
You ready? You want to take like a 5 minute break before you're coding?
Nah,
Ready to
we can
hop
go
in?
straight into it.
All right, let's
We
get
can
it.
go straight into it.
Let's get it. Let's see.
Yo, hopefully like some of my Waterloo friends don't watch that video and say, yo, this guy completely misrepresented Waterloo. Fingers crossed.
Nah, that sounds super accurate. And you're only in your third semester, fourth semester, so I mean, everyone's experience is always different, but I feel that yours is valid no matter what. What is this? Let's go test.
Yeah, I don't know. I think like my viewpoint might be a little skewed because like I kind of got caught up in that like imposter syndrome group who like saw what some people were doing as like, bro, what the hell? So like my perspective of like what Waterloo is and like what the average Waterloo student's doing is like a little different because like I like all I see is like the people who are doing like really crazy things.
Yeah. No, like that's crazy that there's even people doing crazy stuff there too. I mean, that's not in most universities. There's only a small percentage of people doing those crazy things, but seems like at Waterloo there's a lot already.
Yeah, I think like yeah, I guess Waterloo like to summarize, it just makes you feel FOMO if you don't like get ahead now.
Yeah. Shit, close this. Give me a sec. Just trying to get the. ran out of the coder pad. Okay, we're gonna do this on Replit.
Bet. Oh yeah, I ran a quarter pad too.
Do you have an account there too?
Yeah, that was the account I joined in last time, and then yeah, I couldn't set my name, so my name was just out there.
It's all
to
good.
be
You already
doxed.
you already have social presence like on your blog and stuff. So
Yeah, hopefully. I started like a Twitter, but like haven't really been like
yeah,
consistently posting anything interesting.
you're hop into this Replit. I think social presence is good in these days because with the rise of AI, I mean like it's hard to
Yeah.
prove people can do what they do, but if they have like a
Mhm.
Twitter account where they're posting some of their code, they have like they have like portfolio, GitHub, all that stuff, YouTube, whatever. You can kind of like see that they actually did like are doing stuff.
Yeah. Let me turn off this Copilot.
Yeah, for sure.
How do I turn off this Copilot?
Bottom
Is
left,
this one? Oh,
there's like the AI
Yeah.
right next to the Python.
yeah.
You see that?
Yeah, I see the Gemini Flash. There's almost like a Copilot like autofill, auto generate. Settings.
Like at the bottom left here. I'll show you. I'm gonna bring my screen here.
Let me watch the stream.
Like the bottom left here, there's an AI. You can click enable or disable.
Okay, I see. Wait. AI. Disable. Alright. Oh, wait. Okay, there you go.
All right, let's get this. Let me look for some good questions. I'll pull up 2 good questions and then we'll do it meta style because you said you wanted to get into meta. Or I don't know what that was.
Yeah.
But like,
Yeah, it's me.
let's see.
How's the work at you work at Rippling, right?
Yeah, it's
Yeah,
good.
how's it working at like that kind of startup?
It's
Or, like,
pretty
late stage?
crazy. It's like super fast paced and stuff. It's a good. I think it's good experience, especially we have tons of Waterloo students.
Oh yeah.
Lots of Waterloo kids like
Eh.
enjoying it.
Did you have the option to like choose between like I know they have a New York location.
It all depends what team you get into.
Mm,
So depending on the team, they'll either want you to move to a specific office. Like we've hired people from New York who live in New York, and we're like, okay, all your teammates are in SF, like come down to SF.
yeah.
So
Yeah.
all right, let's see. Trying to look for some good ones. You've been doing the dailies?
Yeah, I've done some of the dailies. Just I beg just don't ask me a bit mass question.
Have you done let's see, 368?
368. Oh yeah, that was a daily like yesterday
Oh yeah.
or like today. Yeah.
Let's see. Okay, let me actually find some good ones. Okay, let's see. Let me see. Oh. One sec. I need to find some good ones for this one. Let's do
How do you push yourself to do lead code now? Because I know like you have like a like big tech or like startup job. I feel like if I was in that position, I like have zero motivation anymore.
I don't even I do lead code literally just for this YouTube video, and I wasn't even planning on doing lead code on this channel. I was dropping videos on my side projects and stuff, and I was like, I did a couple
That's
of
good to know.
YouTube video, or I did a couple lead code videos because I've already was done lead code in the past. So I was like, okay, let me shoot some lead code content, and those ones just started popping off, and I got kind of
Damn.
thrown into this niche.
Yo.
I like to
That's-
do side
that's
projects,
shocking.
honestly, but
Yeah, like what kind of side projects do you also do? Full stack?
yeah, I like to do a lot of full stack side projects. So, like, I have one Chrome extension that has like 2,000 users right now.
Or the UFC one,
Yeah,
right?
the UFC one. That one is doing pretty good. Let's see.
Yeah, I think it's nice to have users. Like that's my goal now, is just to try to get as many users as I can. If any tips?
For getting users,
Yeah.
yo, this one kind of grew naturally. So, I built this. Me and my friend built this. Like I worked on it with my other friend who works at Microsoft. But we built it in order to. First off, I needed to learn React, and I basically the tech stack we use is the tech stack I used for my first job. They just told us. They told me what I'm going to be doing, so I learned all of it by building this project. And honestly, it just
Yeah.
grew naturally. For the first year, it took like a year to get 100 users, and then like it's kind of capped at 2,000. But like these are weekly active users, so it's like still
That's good.
it's like right here. Like we added like voting feature and stuff. Like it's fun. I kind of want to. I'm trying to sell it to them at some point, but
Yo, I heard like next week there's a pretty big fight with like Volk.
oh nice. Yeah, you could see like in this Chrome extension, we have 43 people voted like favored it and stuff. You
Damn,
can see like the different people favoriting it. You can see like
that's huge.
yeah, like people are actually using this on like some of the big fights. Like 50, like people are like disliking if they didn't like the fight and stuff. It's like it's pretty
Sure.
interesting community. Like we can do a lot more with this actually, but I think with side projects, just try to find the project that you want, that you would want. For me, I hated looking up UFC while I was like,
Yeah,
wow.
same.
So I wanted it to just show it fast. That's kind of the problem I
Yeah.
solved. So I built the Chrome extension for myself, and I still use it. And I have other features that are only kind of for me, but it will notify you when fights are about to start and stuff like that. I'm gonna like push that out further, but yeah, you learn a lot from this.
Yeah, I think like I feel like users is like a bonus too. Like having people who actually like also find value.
Yeah. All right. Okay, we're gonna start this thing. What is this? Let's see who's still in this. I have a couple questions that I want to pop up. The chat. Oh crap! Tweaked. Run 3235 on him. Okay, chat. Don't worry, I fixed chat overlay. Yeah, AlphaCode got a VS Code with 30k users. That's crazy.
Damn.
Okay, what's 3225? Bruh, this guy's. Paul, you're tripping. Oh my god. Trying to get you to do all the math questions. Are you good with the math ones or not really?
Yo, that's like I don't know. Those ones are really for me.
Alright. Okay, let's hop on this one right now. I'm gonna start a second video. 3, 2,
Damn, I shouldn't have told anybody like the number I solved. I feel like people are overestimating my abilities right now.
let me see, chat. I'm gonna ask you ones that are more actually like that you're gonna get asked at a fan company, obviously. And then
Yeah,
I'm just
I know
gonna-
like
yeah, what are you saying?
Oh yeah, I was about to say like I know Bloomberg, like if you write anything related to like competitive programming on your resume, they will give you like a harder question.
Oh, really? Damn.
Yeah, same with Meta, I think.
Oh, really?
Yeah, because my friend like who did um like Bloomberg interview after he had like international Olympiads and stuff. Like I think they asked him like a 3D DP bitmassive
God
question.
damn.
Like it's actually terrible for him.
I did Bloomberg before. Like I got it. I had an offer at Bloomberg when I first graduated. They didn't ask me
Damn,
anything
for real?
too hard. Yeah, I had a
What they
offer.
ask?
I forget. One was like a binary search on a calendar. I remember that was one of the ones. There's
Oh
like
yeah.
there's a calendar and you have to find the next best place to put it. And you have to binary search. I remember that was one of them. Nothing that hard, honestly. But that I think I only solved like I probably solved 400 questions for it.
Damn.
All right. Okay, I'm gonna start
Yeah,
this
I know
video
like
up.
oh yeah,
All right,
let's
3,
start it.
2. Hey everyone. So today I have my University of Waterloo friend Richard again, and this is the same student who aced the coding interview last time. That video has been doing really well, so I gave him an easy question and actually a hard question. 25K views, 413 likes, so people really think he's good too. I'm dropping a video on how he survived Waterloo because that's the top rated comment right now. But I mean, everyone in the chat is saying he's really good. So I mean, let's ramp it up just a little bit in this interview
Yeah.
and ask him stuff that's a bit harder. Um, yeah, let's see.
Fingers crossed.
I got a question for, or I got another one. Just quickly give a background on yourself again, like school, internships you're working at, how many leak code questions you solved, and then we'll get into the other part.
Yeah. I'm currently like a second year studying CS at the University of Waterloo. My internships, like I'm right now working at a cybersecurity company, and in the summer I'll be working at Shopify, and I think so far I've done almost 600 leak codes. But yeah,
Crazy. Someone said, shouldn't you be studying for your UW final?
nah, I'm on co-op.
Oh, okay.
Thankfully.
All right. First question.
Oh no. Okay. There is a ball in a maze with empty spaces represented as 0 and walls represented as 1. The ball can go through the empty spaces by rolling up, down, left, or right. So it looks like a matrix question already, but it won't stop rolling until hitting a wall. When the ball stops, it could choose the next direction. Given the m by n maze, so these are dimensions, the ball start, position, destination, where start is, okay, like a ij, okay. The shortest distance for the ball to stop at the destination. The ball cannot stop at a destination. Return -1. Your distance is usually the number of empty spaces traveled by the ball.
Yep.
Excluded to destination included. Okay. So I think like a couple of things to note, like right off the bat, is that we have some sort of matrix traversal question.
So I'll drop the input and output. This is easier to visualize or something. So
Yeah.
this is the,
Okay. So the ball starts at 0, 4. So it starts right here.
So if you're watching the stream, this is easier to visualize here.
Mhm.
So we're given a ball, right?
Yeah.
We can
Mhm.
we can push the ball in one direction, and when you start pushing it, it rolls all the way down. It can't stop in the middle. So you can push it
Yeah,
and roll
so, like-
down here, or you can push it and roll down here. Pretend it's here, right?
Okay.
And you push it, it'll roll all the way down. So what you're trying to do is find the shortest way that it could, the shortest number of cells that it could travel to exit. So here you can push it down here, down here, down here. It's like down here, down here, down here,
Okay.
down here. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See, that's the answer is 12.
Yeah, so like my initial approach is to kind of do like almost a greedy graph traversal. Like I guess like ignoring the greedy part, right? Let's just assume that we were to um implement this without doing anything greedy. But pretty much like whenever we're anywhere, we can keep track of like how much we've traveled so far and like try moving like up, down, left, right. And then kind of adding that to our queue of like things to process. So like when we start at 0, 4, like we can roll down here and that would mark the distance as 2. We can roll to the left, that would mark the distance as 1. And we can't really roll up or right. And then what we can do is that we can almost treat this like a Dijkstra. So like we want to keep track of like maybe like a distance array, like a 2D distance array, where um like we want to keep the minimum distance to get to that like cell. And then eventually like once we process everything in our heap or like queue, in this case we're gonna use a heap because we want to kind of have like a Dijkstra approach. But like once we get to the end of our execution, we can simply check like if this distance has been filled, like the destination distance has been filled. If it hasn't, then we can simply return -1, which means that we haven't found a way to stop at that distance. So kind of like to reiterate like the approach, it's to whenever you're at any like ij in the matrix,
Yep.
we want to try moving like up, down, left, right, and then seeing how far we travel, add that to like our current traveled compared against the distance array, which should hold the minimum distance to get to that grid,
Mhm.
like that ij, and then add it to our heap, which will just process the minimum distance because we want to be greedy. And that's kind of how we like process a Dijkstra traversal.
I see.
Yeah.
So
So
why are we using Dijkstras here?
yeah, because if you look in the question, we say that, where is it? Destination. Yeah, the shortest distance. So this is kind of like a clue to when we want to use Dijkstras. In this case, like we want to always process the IJs with the shortest distance, so we can almost be greedy, and eventually when we do arrive at the destination, that one will be overridden by the shortest distance. And yeah, because like we're also planning to use like a 2D distance array where each IJ marks the shortest or the min distance we can get to that IJ.
Yeah.
So by kind of like combining this approach, we'd need to use Dijkstras, which implies that we also need a priority queue as well.
Yeah. But it's like shortest path in some questions, right? You could solve it with BFS.
Yeah,
How
we
come
can also
you're,
solve it with the queue.
so you're thinking, so you think we could actually solve this with regular BFS or no? Like you're purposely saying Dijkstras here, right?
Yeah, so I'm just gonna double check. So like we have BFS, right? Like my initial approach is that like BFS should be an issue. So whenever we like move up, down, left, right, we like process it. The only issue is that like BFS will cause us to like reprocess like unoptimal paths over and over again. Because say like we get here in like minimum maybe like 8 steps, for example.
Yeah.
But like BFS, if we like also count the paths before where we may have like gotten to a previous, it's hard to describe. Like imagine if we like got here in like 10 steps, because we just go like down, up, down, up, down, up, left. And then eventually like we'd have to process this. But Dijkstra just kind of eliminates that because it kind of eliminates the entire like the entire case where like you go like all the way down here and then back up. Because when we check our distance array, we can see that if we like go down and up more than once,
I see.
like it wouldn't make sense because it's like the current distance that we're getting to this like IJ by the second time we go down and up.
Yeah.
Like it would be that like, because for Dijkstras we have to check if it's below the mid distance, it would be over. So then we wouldn't need to exhaust that. Like we kind of exhaust that path out early, which helps a lot for our time complexity. So by processing like the the like shortest distances first, we can like ensure that like any new distance we come across will be the min
I see.
distance.
Okay, go ahead and implement
Yeah.
that. I think what you're
Okay,
saying
yeah.
makes sense. Let's just write the code so we can move on to the next one.
Yeah, so class solution. Let's just call this like shortest maze path. Grid, and we have a start and an end. Okay, so like what I like to do for these type of problems, I like to first define my variables. So pretty much these are dimensions of our grid. Why am I getting an error here? Oh, it's the sign I never used. Okay, and then also we need to establish a distance array. So this distance array should be the exact same dimensions as our maze, but it just has infinity in every single value. So here I can do, hopefully I'm doing this correct, times n4. Okay, so this is a, just keep a little comment here, but it okay, and then now we can also like define our heap as well. So for a heap, pretty much like we want to store 3 values in a tuple. And what we'll have is that we'll have like current distance, we'll have our I and our j. So pretty much like by being greedy with our distance, we can minimize, or like we can get to the shortest distance of our destination like as fast as we can. And to start that off, we're just gonna say 0 as our current distance, and we do start, I believe start is a tuple, right? Yeah. So we have our heap, we have our distance. Okay, yeah. So let's start our dexterous implementation. So similar to BFS, we just do while heap, and then we're gonna pop our current dist ij is equal to, I don't know if in Replit I have to import these, but I'm just gonna do it just to be safe. Okay, hopefully that's all correct. Yeah, and then pretty much what we're gonna do is that we're gonna like go in all 4 directions. And you have to define it. Yeah, so pretty much the idea here is that at our current ij, move in all 4 directions until you are either out of bounds or hit a wall. And then check the distance needed plus current dist against min dist, or like our dist array. Does this kind of make sense?
Yeah.
Okay. Yeah, so what we're gonna do is I'm going for the ITJ directions. So here we have our direction. We want to continue adding this direction until we are out of bounds or hit a wall, and then keep track of the distance taken. So I'm gonna define like a, or I'll just call it a count or some shit. Yeah, so what we're gonna do is that we're gonna continually like move in that direction until we're out of bounds. So let's just say while I'm gonna have di plus I. Oh, but then like we don't want to mutate our I continuously. Just also have like Ni and nj. Ij. Yeah, so di plus ni should be, so I tracks the rows. And then this is 0 for clear and 1. Okay, n grid of so you want to make sure that it's equal to 0 or like not equal to 1. Yeah, so in this case we just want to ni is equal. So this means that we can move forward. Then we also want to increment our count. So by the end of this execution, we should either be out of bounds, which is right here, or we should also be, or we should have encountered like a 1. So that means that we have our count, we have our current distance. Now we want to check if our new coordinates are the min distance to get to that ni and j. I don't know how to describe it. It's like the classic like Dijkstra's relaxation formula. So like dist of ni. So if the dist of ni and j is greater, which means that our current count, per dist plus count. So this means that if we found a way to get to this ni and j, a more optimal way to get to this ni and j, we want to pretty much do our relaxation formula, which is to add to the heap. And then, why am I getting error here? Heap q dot heap push, and then we do heap first.
Let's see.
List to sequence, which is covariant. List tuple unknown. Oh, did I mess up something here? Per dist ni and j should be okay.
Why do we need this dist?
This is pretty much like our it almost like works as like a visited array in BFS, but pretty much it marks like the minimum distance we like need to get to ij.
Okay.
So this is just like as a part of our Dijkstra's implementation.
Okay.
Yeah. So I guess like assuming that this like heap q, like nothing's wrong there. We'd also need to relax our dist. So when you say ni and j is not equal to per dist, let's count. And I think, let's see. By the very end of this execution. Okay, so that means that by the end of this execution, what we can do, am I on the right line? Yeah, this is the right line. Yeah, so what we can do is that we can return list of ends. Is it marked by end? Yeah. So we can return like the end coordinates if list of the end coordinates is not infinity. So pretty much like if it is infinity, that means that there's no way to get to our end coordinates by the end of this execution.
Sure.
So say if it's not equal to infinity, that means that we do have like a finite way to get there in minimum number of steps. Otherwise you return -1. And I guess like looking through this, okay, so we start with a heap, and then we take our lowest distance, we move in all 4 directions. I'm concerned like maybe there's an off by 1 error here.
Mm-hmm.
So we have All right, so we start at 0. Let's say like we can move in one direction. Okay, so then we move in that direction. We can, okay, so
Actually,
there's no
walk me through your code end to end real quick.
Yeah, so let's start with this. Oh, let me just remove the things I did here. What the hell? Okay, so I'll just say D for a destination. Pretty much what's gonna happen is that we start with a heap, and we're gonna start with 0, 0, 4. So pretty much like at the very beginning of our code, we add our start destination with the current distance traveled is 0, and we also have the coordinates. And what we're gonna do is that we're gonna enter our DF or like the extras.
Sure.
And pretty much here, what we do is that we move in all 4 directions, right? So let's say we first try to move up. We instantly break out of this because we see that we instantly go out of bounds if we try to add DI, NI, DJ, NJ. So you have a count of 0. And then we see that like, wait, current distance. Okay, yeah. Yeah. I think one thing I forgot to do is I forgot to mark. Well, I don't think this would really like affect too much, but it's like good practice to mark like our beginning.
The scene, pretty much.
Yeah, like the start scene as well. So yeah, so pretty much like I'll also make a copy of our dist. But then I have to do floating. All right, it's fine. So let's just say like the minimum to get here is 0. And then what we're gonna do is explore all 4 directions. We can't go up, we can't go right. We try going left. We go left. We get here, encounter a wall, and go, okay, we can get here with a count of 1. It's lower than, because here's all infinite, right?
Yeah.
If we go 0, 3, we see it's less, so we can get here in 1 step, right? I'll probably just put like an asterisk. And then we try going down, and then okay, we can get here in 2 steps, right?
Yeah.
So, because we use a heap queue, we'll start by looking at this one, just because we want to look at the shortest paths first. So we'll okay, here we can get here in 1 step, which is 1 plus 1 of our current steps. We can get here in 2, and that's about it. So then, I'm not sure which one the heap queue would choose, probably like random. But then what it will do is it will see like, okay, we can't move left, we can't move down, can't move right. Try moving up, but that doesn't work because if we try moving up, we'll get 4 here, which is greater than like our dist. So that means like, okay, like 0 is the optimal. 4 would be greater than that, which means that it's not worth exploring this path because any like subsequent paths would not be the shortest distance. Right?
I see. Okay.
Yeah, so when we go to exploring here, we explore up, but obviously like similar to here, that wouldn't work. But then we explore right, we can see we get here in 3, and we can get here in 1, 2, 3, 5.
I see.
Right.
So you think your code here works?
Yeah.
Just run it straight on there.
I think it might work. If it TLEs, like I have an idea of where it might be TLEing.
Come run it. Runtime error. Wait. Oh, okay. Wait 1 sec. Looks solid. Wow. Grid is not defined.
Oh.
There's a slight error here. You might have to just like
Okay.
I'm
What's
gonna
your-
invite you to this one instead, so you could get the code running. One sec. You join this lead code one up.
Okay.
Yeah, get this one running. Then we move on to the next question.
Okay, bet.
Intuition is good. Yeah, I
Okay,
think you're able to solve it.
Okay, so if I run it, index out of range, NINJ, so that means that NINJ, DIDJ, NINJ, IJ, IJ, NJ plus DJ.
You get an index out of range. Line 38.
Yeah. This stuff, NINJ, line 38, okay. So if it is within bounds and it's a 0, we will add onto it. The hell? So TI and I, because I think okay, so like I guess debugging this, right? We start with our NI and our NJ, which is copied from our I and our J. So you know that I and J, like initially they start as valid, starting points, or like within the bounds of the matrix. And pretty much what we're doing here is that we're first going to check, like, okay, if we move in this direction, will we still be within bounds, and will we still equal to 0? So if we can move, like afford to move in this direction, then we will move in this direction. But if we can't, like we won't end up incrementing anything. So then I think it might be with how this is declared.
Well, I'll give a small hint. Like
Oh,
right
it is how
here,
this
you're
is
out of
declared.
bounds. Right here, right? You increment it in, and then you try to access.
I think it's because I did like initialize my dist incorrectly. So if I run it again, oh yeah, and I need to change start and end.
Okay, I see.
Okay, yeah.
Oh yeah, let's go. Okay, next question.
Submit.
That thing just ran.
Ooh, let's go.
One go. All right. Okay, next question.
Bro, I love my matrix traversals, bro.
All right, you see it? I'll let you go ahead and read that.
Oh, it's one of these games. Okay, so Alice and Bob take turns playing a game with Alice turning first. Initially, there's a number n on the chalkboard on each player's turn. That player makes a move consisting of choosing any number between the current number on the chalkboard and, okay, so any of the factors, replacing the number n with n minus x. Yeah, also, if a player cannot make a move, they lose the game. Return true if and only if Alice wins the game. So both players play optimally. Okay. So I guess like thinking about the losing scenario, right? Like when does a player lose? And I think that's when like eventually. Let me just go through the examples then. So if there's two your current factors, like you can choose between 1 and 2, but you can't choose 2 because it violates this. Has to be non-inclusive between. So you take 1 and then Bob has no more moves. Okay, so I guess like if you can get to 2, then you win. Example 2. n is equal to 3, this is false because you can choose 1 and 3. You're forced to choose 1, and then Bob gets to 2, and we know this is like a losing state, or like a winning state for whoever's turn is on. Let's run through like more examples.
Sure.
Because this is one of those like I feel like these are like one of those tricky questions that like they ask. I remember I watched like a YouTube video and they always use like Alice and Bob to ask these like brain teasers.
Are you living on res, or
At Waterloo I'm living like it's not counted as like university res, but it's like pretty it's like really close to campus. It's like a suite almost.
I see. Okay. And
Did you live on res in Calgary?
No, I didn't live on res. I lived at home.
How long was the commute?
Probably like 45 minutes, but then I got a car in just 20 minutes after that. So.
Oh yeah, I feel like life gets way better after you get a car. So like n equals 2 is winning. No, n equals 3 is losing. So we want to get to n equals 2. We want to avoid n equals 3. So it makes the most sense to choose 2, which is that if you play optimally, then you win. So this is output true. Does that make sense?
If n is equal to 4?
Yeah.
If n is equal to 4, it's true?
Yeah, because I'm thinking like we already know that this is like a losing position, this is a winning position. So between like 1 and 2, you would choose 2 because that puts you into the winning position.
Yeah.
So I guess like if we go, I guess to understand it further, I'm just gonna do like a couple more cases.
Sure.
So if you do like 5, you can choose between 1 and 5. And in this case, you would get to Bob. Like you would have to choose 1, so then Bob would be at n is equal to 4, and we know that this is a winning position for Bob. So output is false. Okay, so like I guess looking at like what we know so far, this looks to be like a dynamic programming problem where we have like base case. We know like 2 is losing, 2 is winning. 3 is losing. And then what we do is that we like kind of build up on that and see like if we can reduce any of like we can reduce like a large number to a winning or losing state. So I'm assuming like as you like kind of like recurs downwards from like any like large number, you would eventually like get to like a smaller state, which we know that we can reduce to like 4, and we know that 4 reduces to 2, and we know 2 is winning, right?
Okay. So the base case is like 2 is winning, 3 is losing?
Yeah, so if we have like a DP, like if we're doing a dynamic programming approach, I guess like we would store like a boolean in a DP. So our DP would have DP of 2 is equal to true, DP of 3 is equal to false, and then we kind of build on top of that, right?
Let's see. Okay. So, I mean, we need to pick optimally, right?
So by picking optimally, you want to like avoid, or I guess if we're doing bottom-up DP, like we can like build winning positions and losing positions based off of like our base cases. Like you see like in this example, we're able to build DP of 4 is equal to true, right?
Yeah. DP of 4 equals
And
to
like
2.
so I'm thinking like what we'll do is that we'll do bottom-up DP for each number. So how do we check? I guess like we can like subtract each of its factors and check the state of that. So like if we go to like, if we get to like I is equal to 5, and then we go like, okay, we know the factors are 1 and 5, and we can simply check this by doing like I divided by factor is equal to 0. And if we see like dp of like 5 is equal to dp of like I minus the factor, or wait,
Okay,
oh no,
go ahead.
like, oh yeah, I was gonna say like by playing optimally, you can check all the factors and see if any of those get you to a winning position. If they don't, then we can conclude that it takes you to a losing position. So like we know for this one, you can only choose one. So we know that this is just equal to the opposite of dp of 4. And like if we have like dp of 4, right? You know the factors we can choose are 1, 2, and like 4 would be out of bounds. But we would check like, does 1 work? 1 brings us to this losing position, so no. Does 2 work? Yes, so then we would say dp of 4 is equal to true. Does this make sense?
So DP. So what are you gonna do? Okay, we're given 5, right? Or pretend we're given 10. We start off with n equals 10. I'm Alice. So Alice is gonna
Yeah,
try
sure.
the different multiples, maybe 2, 5, 1.
Yeah, so
Like
what we're gonna do is that we're gonna like loop from, I guess like what is our range? Okay, so if our range is like 1 to 1000, what we would do is that we would loop from 2 to n inclusive, and what we do in this is that we check all the factors. So like I think a simple way we can do this without any like helper functions, just looping from 1 to n non-inclusive and seeing if just checking if it's divisible, right? And what I'm thinking is that like we know that 1 is like our base case, and if we see like dp of
okay, what's the runtime of your algorithm here?
so we loop from 1 to n, and then for each n times we loop n again. I think it's the O of n squared approach.
Let's see.
Could balloon, it could be like, so we loop from 1 to n, and then for each n we loop to n again. No, it wouldn't be factorial. I think it would be O of n squared.
Okay, so let's like walk through for 5. Like how would we do this for 5? So we loop through. You're saying we loop through the options, right? For each. For
Yeah, so we start with our. Oh yeah, sorry. I was gonna say like we have like this base case, and we start from 2 to 5 inclusive. And what we do is that we go like, okay, for 2, if we, for 2 we have the factors of 1, like that fit this constraint of like 0 to n non-inclusive, and then we see like, okay, you know that 1 is a losing state if it's like a factor and like not dp of n minus I, then we want to set dp of I or dp of n is equal to true. Because what we're saying is that like if we found a factor and we can get to like a previous state where that state is like a losing state, then we want to set like then we know like if we get to this number is true. So in this case, like if we get to 2,
Yeah.
we know that 1 is a losing state for Bob. And if we can get to 2, then we know that we will win because we can simply force him to this like previously found losing state. So then we process 2. So now we'd have dp of 2 is equal to true. We go 3, right?
Yeah.
Now we process m is equal to 3. We see like 1 is the one that fits the criteria. Then we see like, okay,
Yeah.
we can.
Okay, I'm gonna give you a
only-
small hint here because I think DP is the wrong direction here. We can solve this more in like a greedy fashion. So, like depending on the n. Like yeah, we don't need to go to a DP.
Oh,
I'm just gonna say it's the wrong direction.
I see. I'm thinking like if we have like so you know like 2 will always be true.
Yeah.
Like 2 is a winning state. I'm thinking like here, if we look at like greedy approach. So I'm thinking like, you know how in like, I know this is gonna sound like far-fetched, but you know how in like tic-tac-toe, you can like force your opponent into like a losing state, or like in like most like video games, you can like force an opponent into like a losing state. Like what I'm thinking here is that like, depending on the number that you get, you can like always like
Like in tic-tac-toe,
Like,
if
if
you
we
make
have,
the
like-
good first move, you could always tie them, right?
yeah. So I'm thinking like, if we know that 5 is a losing state, right? I guess like, what we can do is that we see that like 3 is a losing state and 2 is a winning state. What if we always try to force them to an odd number? Because if we have any even number, we have like 1, and we have like ... But like if we subtract 1, we force them onto an odd number. And like for odd number, we know that any factor is like any factor cannot be odd. This is like a fundamental property, which means that if we can force them to an odd number, and we know that there's no possible chance that an odd number can have an odd, like an even factor, that means that since odd minus odd is equal to even, they force us back into an even state. So by then forcing them back into an odd state, we can either force them to get to that state of dp is equal to 3, or like we can force them to number 3, or we can get forced to number 2. So we always stay even and they always stay odd. So like, let's do case like 10.
Yeah.
Like what I'm thinking is that like, we have like a bunch of like options, right? Like 1, 2, 5. But we want to force them to an odd number, so they get 9. Their options 1 and 3. Either way, like they can play us to 8, play us to 6, but we don't care. Let's say they play us to 6. We force them back onto an odd number. They're on 5. They force us back, like they have only odd options to subtract from. So in this case, they'll force us back to 4. We'll go, okay, you get 3, and then we know this is a losing state for them. But like, let's say instead of like choosing, when they're at 9, instead of choosing 3, and imagine they choose 1. We're at 8 now. We're like, okay, we'll force you to 7. They're like, okay, I can only choose 1. We're gonna get back to 6. And then we've seen before, like this is a winning state for us. Like then we just force them back on the 5. They go back to 4. We force them to 3, and then this is like a losing position.
Sure.
So I'm
So what are you
thinking,
thinking?
I'm thinking whenever you get an even number, you can always force them to an odd number, and then eventually like the number will dwindle down, and then you'll get to like the base case of 2 being a winning matchup.
Okay.
And then for them, like if they start with an even number, like they can win, but like it kind of like matters about like the parity. So like if you start with an even number, that means that you can always force them to odd number. If you start with an odd number, then they will eventually get an even number. So that means that they will win. So that like you winning completely depends on whether or not you started with the odd number or not.
Okay, so what's
Does
the
that make
final?
sense?
So, if it's odd, like, what's your final algo?
No way, bro. Is this a one-liner?
What are you thinking? I'm gonna send you the link. Let me get the-
Is this really a one-liner, bro? Is this it, bro?
Huh? Let's see. Here, did you dip
Oh,
out?
I really just yapped. I yapped for 20 minutes on a one-liner, bro.
No, this is a good question. Let's see.
I knew, bro. I knew it, man. I know there's like another one where they had like a stone question. Like Alice and Bob are playing this stupid game, and it's like another one-liner.
Wait, let's see. Got it. Great. You can only join one room at the same time. Are we in the? Okay, I have to dip this other room.
Bro, Jokic is going crazy right
Really?
now.
What was he doing?
He's dropping 40.
God damn,
Jeez. And he's gonna lose, bro.
bruh. They're cooked. Here, hop in this link and try out your solution. And the intuition makes sense.
Bro. Yo, like I was thinking like a DP approach, like bottom up DP, like building up to the end state.
Yeah,
But that's,
honestly,
like,
I tried
very
that.
interesting.
I tried that. That was like my first. That was my first solution that I did. If you're looking at the stream,
Jeez, bro.
it's a tricky one, honestly. Because when you, if I saw it was easy, I would have thought of that. But if you see it out of context, it's not an easy question. You're like, okay, great. Let me think of a.
I think one thing I should have like taken as a clue is like playing optimally, because like what does that actually mean? Like I should have like seen that there was like if there's a strategy to play optimally, I should have like maybe looked at that strategy first. Damn.
It's a good one. I don't know. So how do you think you did?
First question I thought I did good. Second question I think it depends. Second question is like the question I don't want to see in an interview, because I feel like if there's like a trick, it's like I feel like if the interviewer wanted to like see my programming skills, but maybe it's like they wanted to see how I like think through a problem. But overall, I think like my first problem was definitely stronger. I think my second one, I
Yeah,
struggled a little bit, but
I
I
mean,
think
you
it depends
solved
on how
it.
the interview went.
Honestly, like your
Yeah, I
intuition.
think it
Once I
depends on
said,
your
once I
interview.
said that it's not DP, you solved it. I don't know. It's hard. I think
Yeah.
definitely the first question is hard. You solved that easy, so obviously still a pass. But it might not be
Yeah.
the strong hire from last one.
Yeah, yeah. I'm thinking like, you know how like, because I heard like recently for interview coder, like you know the like the cheating software
Yeah,
that like came out. I heard that like now with so many people cheating, like struggling is like almost like a good signal. Like
I see.
struggling and like trying to think through the problem.
Yeah,
I think in the future if I ever see that question, I'll be ready for it though.
yeah. Nice, good job. Yeah, definitely passing you on that one. I don't know, not that much
Appreciate it.
feedback. You're good. You solved Dijkstra's, implemented it. We ran it in leak code. Good thought process. Like the math that you came up with here, just understanding. Like two odds, you need to put another odd factor, and that produces an even. Or what do you say? You need an even factor? No, you said you need an odd
Yeah.
factor. Something like that.
It's like when you're in even, you will always have like one as a factor that you can push them onto an odd, and like odd, they have no option to like
Yeah.
stay at odd. It's like they'll always have to make you an even. I think like I don't know. I've been getting kind of lucky. I can't lie. Like you've been giving me some matrix traversals, bro. That's just my bread and butter.
Yeah.
It's my favorite type of questions.
Cool. All right. Sounds good. Richard, I'll message you on LinkedIn some more. Keep in touch. Thanks
Yeah.
for hopping on these interviews and telling me about
Thanks for having
Waterloo.
me, bro.
Good luck on your stuff. Yeah, let's keep in touch.
Yeah, for sure, for sure. I appreciate the time, bro.
Yeah, bro.
But yeah,
Thanks,
like reach out whenever you want to like
Sure, man.
make a video on like Waterloo or like
Yeah.
another coding interview.
What are you up to now? You're gonna keep grinding your lead code or your projects or something for?
Probably just like continue doing, like I've been working on a side project with my homie. I think I'll probably take like a. Yeah, I've been slowing down on lead code. I've just been doing the dailies now.
I see. Cool.
Yeah.
All right, man. Keep in touch.
Congrats on 40K, bro.
Thanks, bro. Right, you got to see it live. That was nice.
That's huge, bro. During my interview too.
Word.
Actually lucky.
All right, man.
All
Catch
right.
you.
Appreciate you. See you, man.
I see you. Yo, chat. How do you think he did? Alex, Justin Cookie, W? Yeah, it's a dub. It's a dub. I. Let's see. Yeah, y'all think he was good? Okay, I got my last interview is somebody from India, I think. He's hopping on soon. Let's see what else we got. Oh, that's some good content. Lead code hard. We got I'm waiting for my brother CFA to get home. We're gonna ask him like very simple questions. I'm gonna just test his coding skills. We might ask him to loop through some data structures, maybe reverse a linked list. Let's just see where he's at. And then we have a guy from India who's done a lot of lead code questions. Let's see where he's at. And then that's pretty much it. We already covered a lot of ground this stream. Maybe I'll just message him if he's free right now. Let me see if this guy's free. Bring up. I haven't stood up all day. Damn, I haven't stood up all day. What's that? Let's see. What else we got? Anyone got any good lead code questions? Wait, let me see if this guy's free right now. Another guy. Give me a sec. Oh, he's free already. Got the next guy up. Yo, what's up?
Hello,
What's up? What's up?
I'm good. How are you?
I'm good. I'm good. One sec, just setting up. So what's up? What's it called? Where are you interviewing for again, and where are your lead code skills at?
Yeah, so a quick background. I work in a prop tech in Singapore.
Nice.
I'm basically from India, so I moved to Singapore and I'm just looking for some fan companies up there, looking for Meta and Amazon
They're
currently.
in Singapore,
Yeah, I'm in Singapore currently.
and you're gonna apply for like Singapore Fang in Singapore.
Yeah, yeah, I mean, it's a bit hard here in terms of working visa, but if you do get Meta, they should be able to sponsor you, or we can also move to Malaysia if possible.
Okay.
But I heard Amazon and AWS in Malaysia is a good choice
Sick.
since they have currently set up in that.
Nice. All right, you ready for this interview? Let's just take a quick 5 minute break. So just go on mute or something, and I'm gonna take a quick break too. Cause I was just.
Sure.
Are you?
Yeah.
Were you
Yeah.
part of this stream?
Yeah. I just got up. Yeah.
Nice. Oh, you just woke up? Okay. Take a quick 5 to 10 minutes break. I'll just put in like
Yeah.
5 minutes, and we'll hop straight into. Let me put a timer. We'll hop straight into this coding question.
Sure. Yeah.
Like we'll do meta style because you're trying to get into meta.
But let it be a medium hard or easy medium.
Okay, sounds good.
I just started it off.
Okay, I'll be right back. Go
Yeah.
on mute. All right, see ya.
Hello.
What's
Yeah,
up? How you doing? Good morning.
great. Morning, you too. Sorry,
You're back?
which time it is?
Alright, I'm gonna get you I'm gonna so yeah, I'm gonna start a video here and we're gonna get straight into this. Alright. I'm gonna start a video. 3, 2, 1. Hey everyone. So today I have a friend from India, but I think he's living in Singapore right now. And he's trying to get into Meta, trying to crack into Fang. So we're gonna help him out with some coding interviews, try to see where his skills are at, and give feedback to see where he can improve if he needs to, or if he could already crack it. Could you quickly give a background on yourself, quickly?
Sure. My name is Vignesh, and do live in Singapore here for 2 years.
Nice.
I work for a prop tech here, which is a big monotony, monopoly product-based company, which is in Singapore, Malaysia, and Thailand. And I'm do looking for some Fang opportunities and doing some lead code system design in Singapore. So I do want some guidance on that.
Nice. So how many questions have you already done?
Currently, it's at 660. Yeah,
Wow.
evenly distributed across medium, hard.
So you've done 200 easies, 200 mediums, and 200 hards?
Not really. 100 easy and around 450 medium and 50 odd.
Wow. That's crazy. So, like, where did you go to school and stuff? And what is your, yeah, what's your background? Like, how many years of experience?
I did my schooling in India
Nice.
back in 2022, 2023, and I graduated back then and moved to Singapore. I do have around 2 to 3 years of experience in software industry.
Okay, cool. Sounds good. So what we're gonna do in this coding interview is we're going to work through 2 questions. Each question, I'll give you around 20 minutes to solve each question. If you haven't solved it by the end of the 20 minutes, we'll still move on to the next question. Um, so I'll just stop you there. But yeah, what coding language do you like to code in?
I do prefer Python
Do you prefer
over
Python?
others.
Okay, sounds good.
Yeah.
Cool. Let me get a good question in here. Ah, let's see. And it's all good. Win so you win some, you lose some on those interviews. You never know what you're gonna get.
Yeah.
Let's see. So you did 660. You think you're pretty good at leak code, right? You think?
Yeah.
Did you do the dailies or no?
I'm not regular at that. I do daily sometimes, not regular.
Okay, let's see. Have you done 368?
I'm not sure. Let me check. Three, 6, 8. Not really.
Okay, I have a different one. Okay, I got a different one.
Yeah.
Okay, I'm gonna send you this link and just accept it. It's a link to the lead code.
Sure. Yeah.
Room. Okay. Let me know when you're in and then we'll work through it. Okay. Sounds good. Cool. Let me see. So, all right, I'm gonna start this. So this is the first question that I want to ask you. It's called accounts merge. So we're pretty much given a list of accounts here. Right?
Yeah.
We're given a list of accounts. Given this. So pretty much we're given a 2D array. Each element contains a person and a bunch of emails list under that person's name.
Okay.
So that's the input, and the output is if they share any of the same emails, we should join them into like one. For example, like if they're the same person, we should join all their emails into one list. So for example, since these two people share the same email, they're actually the same person. So we should join all their emails into one list and then just put John as the identifier. Does that make sense?
Yeah, makes sense.
Okay, I'll let you read it again. It's a long prompt, but feel free to read it and ask me any more questions. I just want to give a high level explanation. But yeah, what do you think?
Got it. Okay. So we are given a list of accounts, and the accounts has the name identifier corresponds to its own account holder email, and there could be some intersections or union across the list of account holders, and we do need to merge those account holders into one. Makes sense. I'll just go through the constraints once. The length is makes sense. Yeah, I'm just thinking out like whether we can do a DFS just because of the graph behavior it has. So one account corresponds to another account in terms of email. So we can keep a track of say. Let me know if my writing is visible to you
Yeah, this looks good.
or my cursor is visible to you.
Yeah, it is.
So we can have some email to name mapping, and every time say how is that possible? Like um, give me a second. I'll just do a quick look up on how the input is.
What are you thinking so far?
I'm thinking of a DFS approach
Okay.
to see whether we can form a graph first, and once we form a graph, we can do a union find. Uh, and union find would be a quick complex thing to do in 20 minutes. Rather, I'm just looking upon like a quick DFS where I can have some scene set in terms of the email to name in mapping. And if the email is already seen, I will just make it to my already seen account holder name. Does it make sense?
Sure.
Sure. I'll just do a quick pseudocode or something which I do have in mind.
Okay, you're thinking of turning this into a graph problem, right? You mentioned that?
Yeah.
Like, what are the nodes and edges in that graph?
So my nodes would be the email holder name, and the edges would be the emails. Does it make sense or?
The edges would be the emails, and the nodes would be the name.
Yeah, sorry. Nodes would be email,
Okay.
and yeah. So yes, nodes would be email,
Sure.
and it corresponds to another email across the edge with name.
So we have email. Okay. So we have different email nodes, and how do they have an edge to each other?
This is mapped across the email name, the holder name.
Okay.
So two nodes are connected if they are connected with same email, the holder name, the account holder name.
Okay. So johnsmith.com is gonna have an edge to johnnewyork.com. It's gonna have a.
Yeah,
Okay.
yeah. So I'll just do a quick sort of code. Say I'll have a email to name mapping like a dictionary, and I will also have some kind of adjacent list or a graph. And for say I'll just take a simple example here, which is this one. I'll form. Okay, so the first element is always a name
Mm-hmm.
in a given list. I'll take the first element, which is name equal to John, and for the corresponding elements after the first element is always an email for that name. So I will add it to my um, graph set. Say for example this once again. So this email corresponds to John, and this one New York is also corresponds to John.
Sure.
And once I do have that email to name mapping to have a easy lookup later if needed,
Mm-hmm.
I do have a graph set which would look like yeah, again this revolves around how the node and edges have to be. So for example, I'm just thinking out loud. Um, say my graph would look like this is one of my node, which is John, and mm, this would corresponds to the second email. This would like a bidirectional or unidirectional one,
Sure.
and this email, which is again is also corresponding to uh, the first email. So each email links to each one,
Sure.
and
I mean, this could just be like this, right? Directional.
yeah, this could be a. I mean, in terms of adjacent list, it makes sense to have two entries.
Okay.
And once I do have that, I can also have one scene set or scene map where to keep track of the emails which I've looked upon.
Mm-hmm.
And once I do have that, for every email in this graph, say I do have every email a unique email in my dictionary set, which is a graph default set, default dictionary. I can form. I'll do a DFS for say first email, which is I'm looking upon. I'll I'll see whether this email can be formed to a union component. How can I do that? Is like I'll just look up for the emails which are corresponding to or which are linked to this first email. Say John Smith, John New York is linked to it. I add it to my scene set to make sure that this is not again looked upon in my DFS. And I also do know that this John Smith correspond to my John account holder through my email to name mapping. And once I do know that, I can easily say, for example, my result would be like array of um, how should my result look like? It should look like John and list of my emails, which are John Smith, and I do also have the explanations, right? So yes, this should be in terms of sorted. It doesn't needs to be sorted. So for given email name, I do know what all emails I've seen previously through my DFS
Sure.
in graph. Does it make sense, or
Yeah.
should I go with a quick pseudo code and do a dry run on that?
Okay, sure. Yeah. I think let's get to writing code on it. I think you. So wait. Could you just quickly explain? Okay, pseudocode your algorithm, but just the different steps you're gonna take.
Sure. So first of all, I'll just form the graph and also email to my name mapping. So I'll loop through the given list. I'll take my first element as name and I'll take all the emails corresponding to that email to my email to name mapping,
Sure.
because single name would be I mean, name is not unique in this sense, because John is a account holder one, and there could be other Johns. So that I don't want my key to be name, rather I want my key to be email and email corresponding to name. And once I do have that, I would also parallelly form my graph, which is an adjacent list. And I do know what all the unique emails I've seen so far. In that set, I'll do a DFS and I'll do the link in between each email to my given email to name mapping
Sure.
name. And I'll form a result set where for given account holder name, I do only have a unique set of emails for that.
Okay.
It's kind of for a name, I'm doing a DFS and collating all the emails for that account holder and putting in my result set.
Okay. Yeah. Sounds good. And then there's one small hint here where it says a person could have any number of accounts, but all their accounts definitely have the same name.
Yeah, that for that reason, I don't want to have my name as key for my dictionary lookup. Rather, I want email to be a key and name to be a value. So it's a kind of
Yeah.
the other variables.
Okay.
So
Yeah. Go ahead and implement that. Like you'll have to implement it up here in line 3.
line 3, okay.
Yeah. And
Makes
like
sense. So I can have my email to name default dict. This can be a list, because I'm just looking upon. I don't want default dict for now. I'll take an empty dictionary. And I also want adjacent list or a graph, which can be default dict, because I want to form a list of emails for that node. This could be taken as default dictionary. And for each account in my account list, the account holder name is my first element, which is 0th element, and emails are account. I mean, skipping off the first element, the remaining ones are my emails.
Sure.
For each email in emails, I'll form the email to name mapping
Sure.
So in this case, each email would be my key and its corresponding account holder name, which is account holder. And I'd also try to form the adjacency list in this fashion itself.
Sure.
Rather, I don't want to traverse again.
Okay.
So if length of my current account is more than 2, I do know there is more than one email for that account holder. So my first email would be kind of emails, the first element of my emails list. So I'll form an adjacency list with my first email. And I do also add my emails. And I do want to form another bidirectional one, so I do want to add the other email too. I'm just thinking out loud, like, should we add that? It's not email, so this has to be first email. Yes, first email. So if this should be a set of this shouldn't be a default dictionary of list. Rather, it can be a set, because there could be a case where the same email, same account holder would be in the another list with same email. So I don't want to have a list of multiple duplicates. Rather, I can say whether if each email is not in my graph, I could form a simple set or empty set for that. This is the approach for forming the helper methods or helper attributes like adjacency list and the events to name mapping. And I should be while doing a DFS, I do want a scene set, because I don't want to have a endless cyclic approach of my DFS. And my result set should be an array of account holders. So I'll just return a result. So for each of my email in my graph so far I found, I will do whether if email is not in visited or not in seen set. If it's not seen already, I do know I can form a union component for this email. So I'll say current union is an empty array, and I'll do a DFS. I do want to have a DFS method for that.
Sure.
I'll say DFS, which takes the current email, which also takes the scene set, and also takes the current union array, which I'm trying to form for that email. For now, I'll do a empty method, and for this, I do need to send back the current email, which is I'm currently looking upon, which is not already seen in my scene set. And I do also need to send a scene set in my DFS, which I can populate whenever I come across a unique one.
Sure.
And I'm trying to send my empty array, which is current union array. Once I do have that, I can populate my result set with my email to so email name. I do want my account holder name for that email, so I can easily look up on my email name mapping. For that email, I'll be getting my account holder name.
Sure.
And once I do have that, I should also have my um, the union set which I'm trying to form. So that would be my current union, which I'll be forming in my DFS approach. So the main complexity comes here where I do want to have if my if my email is there in scene, I can just return it back. If it's not in my scene set, I will say my current union can can hold this email because for that email there is no that it's not already seen in my visited set, so I can just add it into my union set. And for each neighbors, like each neighbor of my graph, for that email nodes, I will just do a lookup again saying that DFS neighbor in email, and I'll also send back my scene set and also my current union. So what it does is like given an email, I will do a DFS lookup for that email, which is like if email is there in my scene set, if not, I'll add it to my current union array, and I would also do a lookup into my adjacent see list
Yeah.
look and meanwhile I do need to add my current email to my scene set. Else I would do a endless lookup. Um, yeah. So once I do form the current union where I do know for this email, for this current email holder name, I'm trying to find all the union or linked DFS nodes, and I'm just sending it back to my result set. So this, should I do a quick test and see whether this is right?
Okay. Walk me through the. Let's see. Yeah, walk me through the code real quick.
Yes. So I'm having an email name in mapping, and I also have in my agents list, which is kind of a graph. For simplicity, I can have it into as an empty set, and for each account in my accounts list, I'm trying to find what is the account holder name, and this could be duplicate. I mean, this could be duplicated in other accounts. Rather, I'm just taking my account holder name from my first element, and also I'm taking the emails which are corresponding to from my first element to the remaining one.
Okay.
For each email, I'm trying to add it in my email underscore name mapping, which like say I do have John Smith. John Smith correspond to John, and also if each email is not in my graph, if I haven't seen this email in my graph dictionary, I do want to have an empty set for that. I do want to initialize one empty set for that
Sure.
email in
Okay.
my graph node.
That makes sense. What
And
what's here?
yeah,
What's graph here?
this is not a graph. I'm just confusing
Okay.
with
Okay.
graph. This has to be adjacent list. And if there are more than if there are more than this could be say for example if for this given a list of say So this is the account, and if I'm just looking whether I do have more than 2 emails,
Yeah.
one way I can do here is like
Sorry, I lost you. Still in there.
I do want to form an adjacent graph for that. I will take my first email, which is John Smith, as my placeholder, and I will form a graph for this first email linked to my each email, and also each email is linked to my first email.
Okay.
And once I do have that, my graph would look like I'll just do a quick graph display. My graph would look like yeah, John Smith linked to John New York, and John New York is linked to John Smith. Um, and once I do have this graph, I can just look them on my graph. Again, this is the variable name is different. It has to be for each email in my adjacency list. I'll see whether I've encountered this email already in my
Okay. I have a question about here.
scene.
Could you
Yeah,
quickly explain
yeah,
line 15 to 18 here? So we're taking the first email and we're adding
yeah,
a link to each email.
yeah.
That
And
makes
also,
sense.
I'm
But what is this
the
doing? Each
link
email?
again. So this is a bidirectional graph.
I see.
I don't have any direction for from
I
which
see.
node to which node it is. So how I'll be resolving this cyclic approach that I'll be taking care in my scene or
I see.
visitor set.
I see.
If the graph, say for example, I'm doing a lookup for this John Smith, I'm doing a DFS for all the adjacent nodes.
Okay.
John New York will be coming to my DFS. I'll add it to my scene set,
Yeah.
and I will also see what all nodes adjacent to this John New York.
Makes
I'll
sense.
see John Smith is coming, and John Smith is already in my scene set. I do a quick return.
Okay.
I don't want to do a computation again. So I do link all my John Smith. I mean the corresponding link emails for that account holder, and I do have my current union set. Or it's not union. It's not like union graph approach, but it's kind of a quick hacky way
Yeah. I
where
see.
I'm finding all the emails for that account holder.
Okay. I mean, let's see. Let's run it. I think it looks decent. It might work, but let's see.
Okay, there is some each name which is yeah. I should have used a good one like email. Each email is uh, for each email, not I'll do a quick run again.
Let's run this.
Okay.
Graph. It's saying line 30 says graph.
Yeah. I'm fighting with my variable names. I'm exhausted. Yeah.
It's too early.
Yeah. Okay.
The accounts should
Okay. Yeah.
put the emails in sorted order.
Yeah. I haven't seen that.
It's small thing. Nice. Okay, let's move on to the next question. This
Okay.
one's gonna have to be a bit faster. Let me send you this invite to the next question. Yeah, good job though.
Thanks for that. I was just thinking of union graph algorithm, but it was too harsh for me to come up.
Damn, you're pretty good.
Okay.
Did you join it? I sent you a link in the
Where?
in the
Okay,
Zoom.
I'll
Or
just.
sorry, in the Google Meets.
Okay.
Cool. All right. So this is the second
So,
question.
yeah.
Yeah, I'll let you just go ahead and read it and parse it out for me. Let me know what you think.
Yeah. So, given a string of parentheses on lower cases, your task is to remember the minimum number of parentheses in any position so that resulting parenthesis string is valid and return an invalid string. Formally, a parenthesis string is valid if and only if it is the empty string contains only lowercase characters. Okay. It can be written in form of. Um, I'll just do a quick check in my given input string. The description is kind of bombarding with different ideas. So, given a lead code input, I do want to see whether this is a valid string. And this is I do think this is an extension to valid parenthesis problem where it is in this case I'm also having the lowercase characters, and if at all I do want to have to make it easier, I don't want to have this lead LIIE or so on and so forth. So I'll do a quick skip on this lowercase characters,
Sure.
and I'll see whether this forms a valid parenthesis.
Mm-hmm.
Um, so I do have an opening bracket. I do also have an opening bracket. Once I see a closing bracket, I'll just look up whether I've seen a previous opening bracket. I do have, so I'll club it up and I'll just pop from my lookups thing.
Yeah.
Once I just traverse again. I do have my closing bracket. I've also seen a opening bracket previously, so I'll just pop it up. And I do have one closing bracket now,
Yeah.
which I don't have a pair of opening bracket previously. So this makes sense that the string is not valid. And to make it valid, I mean, the question is not to see whether this is valid or not. Rather, I want to form a valid string from this. So I can easily remove this or pop this out and make the remaining seen strings to a valid say. I'll take a quick try run on my second input string, which is kind of valid thing. Uh, I do traverse for each element. I see whether A is parenthesis or not. If it's not a parenthesis, so I'll skip the index. I come across a closing bracket, and I haven't seen an opening bracket previously. So what I can do is I can just remove this element from my string. I go to B. It's not a parenthesis. I go to open bracket. This is kind of valid. This can be possible to be a valid thing. So I'll add it to my stack, which is open bracket. I go to C, it's not a parenthesis. I go to closing parenthesis, it's a closing parenthesis, and also my stack previous element is an open bracket. So I'll just pop this out
Okay.
and I'll just look up D. And this is not a parenthesis. I go to last index and see till now I've formed a valid one.
Okay. So how are we gonna like generate this last string? I mean, it's not clear yet of your strategy there for like returning.
I can take a result string which is like empty first at initial phase.
Sure.
I'll take the same input where I'll just look up my current index is A.
Sure.
This is not a parenthesis. I'll add it to A. Result set. I will see my closing bracket and the stack is empty. So this can't make it to my results string. This can't be added to make my result string to be a valid one. So I skip the this character or this element. I go to B. This is not parenthesis. This is just an alphabet. I will just add it to my result set. This is uh, this sorry. This is an open bracket. I this can be possible, but I'm not sure. So I will add it to my stack. And to make sure that I add it, I also want to add the index, corresponding index. So this is fourth index.
Sure.
And I'll go back to my C, which is valid. So I will add it to my result string. I will also have um, one empty placeholder in my string because I do want to add my opening bracket back to my result string. Uh,
Mm-hmm.
so this is a tricky one because should I mean this can be a possibility of invalid one too. So for now I'll just take the index as my second index equal to 2, which is the possible index where I can add my open bracket again. So this would be an empty character. I'll go to my closing bracket. I'll see whether stack is empty or not. If stack is empty, I should skip this element. If stack is not empty, I'll see whether the last element in my stack is does it makes a pair with my closing bracket. Yes, for this case, yes. And I should also add my closing bracket, and I should also add my the last pair. To add my last pair, I can say I'll just look up my index where I should add it back. The index is 2.
Add it
I'll
back.
add my
Okay.
character here. There could be a case where this is not a valid one. For example, I don't have this closing bracket, and this would be an empty one, and I would be adding D, CD, and the stack would be not empty once my current index is out of bounds. So I do want to make all my I do want to get rid of the stack. So for each element in my stack, I do look up the current index in my result string. The result string is the index is 2. One way I can do is I can say replace all my empty characters, kind of say replace all empty characters to a non-character one. So this would become my A, B, C, D, and I can also get rid of all the stack elements. So
Okay.
does it make sense? I mean, this is not a valid or an,
Sounds like
not.
okay. Walk me through.
Yeah,
Walk
this
me
is a
through.
walk-in.
I see what you're trying to do. Walk me through this whole solution. Like let's remove some. Walk me through this. So what is this supposed to output?
Yeah.
Like I see
So
your
I'll take the
solution, it
result
just
string.
seems complicated.
Yeah, I'll take an empty string. I'll take my current index, which is L. L is alpha, so I'll add it to my result string. I'll look up my first open bracket, so I'll add it my stack. So stack would have open bracket, say open bracket, and also my index, which is possibly to be added. So the current index in my result string is 1,
Sure.
and I go to my next index, which is t. This is alpha, so I'll add it to my result string. I
Sure.
go to my next one, which is, so again, this is open bracket, so I should add it to my stack. And while adding to my stack, I should also change my index, which is now 0, 1, 2, 3.
Sure.
And next character is C, which I can just add it to. And next character is closing bracket. So I'll check whether stack is empty, not empty, and I'll check whether the last element can make a pair.
Mm-hmm.
Yes, for sure this can be. So I'll just add my closing bracket to my string, and I'll also add my, at third index I'll add my opening bracket.
Wait, you're gonna add?
And I'll
Wait,
also
rewind here. You're adding open bracket here. Oh, because it has
because
a
I do know
match.
the index. Yeah,
I see.
yeah. At closing bracket I do have a pair which I can make, and
Okay.
I'll just pop it out.
Sure.
I'll go to next character, which is this is alpha. This I'll go to next character, which is closing bracket. I'll see whether this can be a match. Yes.
Okay.
I'll close the bracket. I'll also add the bracket, opening bracket at the index which I have. So I'll add it back. I'll go to next character D. I'll also add E at, and once I go to last index, which is closing bracket. At this time the stack is empty, so I can't make a matching pair. So I'll just skip this out, and I'll go out of bounds.
Okay. And then what?
And I'll just return the string, result string back.
Code. What if there's... This one closes this. This closes here. Wait, what happened with
Yeah.
this? What did you do with this one? Oh, you see there's nothing left in the stack? Or I mean, yeah, go ahead and let's go ahead and implement this.
Sure, yeah.
I
Give me
see
a
what you're trying to
second.
do. Yeah, it makes sense.
Give me a second, my mouse is not working. Am I audible?
Yeah, I can hear you. I can hear you.
Got it. Okay. So I'll just create a stack with an empty string. And I'll also have one empty string. I should return it back.
Sure.
Yeah, for each index in range, my length of string, I should see whether if my the current index is not equal to, I mean, this can be like not in either of my closing or open bracket. This makes sure that this is just an alpha character. I'll just add it to my string.
Okay. What's this like how fast is this operation right here?
Which operation? Oh,
Like
this not in.
right here, this res plus equal. index.
Um,
And I have like a
this
8.
is off one because we do need to reorder. I can think of like a list append.
Like pretend we plus C.
Yeah,
So there's gonna be O of 1 operation.
it's not O of one, it's O of n because we do want to traverse and add it to my last element.
Or I mean like just this simple operation right here, right? A B B C C plus C. Like what's the runtime
Yeah.
here?
This is O of linear time
This? Why?
because I do want to reorder my string. I just want to. Uh, I'm not sure on on terms of Python, but in any other language, I do want to form a new string, a new array, or new reference point. I do want to add the current one, and since string is like immutable in Python, I'm not sure on that part.
Okay. So since this is immutable, right? So to create this, like that's actually gonna be an O of n operation, right?
Yeah, yeah,
So I'm just saying that this is gonna make your algorithm very inefficient, I think, for really large
yeah,
strings.
yeah. Mm. Yeah, makes sense.
So how would you get around that?
Um, the other approach I was also thinking is like since we are using stack, we can add the characters back to my stack itself. Each alpha characters too, and let me do a quick check in my paper, like if possible. So, hmm, what
Yeah.
else can be done?
You probably have like 3 more minutes for coding. So
Yeah, yeah.
what are you
Hmm.
thinking? Where are you stuck now?
I'll just go with stack approach itself, but the other approach, what I'm also thinking is like I can say I can make since I want to loop through strings
Mm-hmm.
for each index in my string, I would see whether um, the same approach. If it's open bracket, I would add it to my stack.
Sure.
I should also only add my index because I don't want the opening bracket again in my stack. I do know if there is a stack value, it's an opening bracket. Or if my current index is closing bracket, and if stack is not empty, I can just pop this out as the same approach which we taught about. Else, I can make what else I can just make the current index equal to empty character. This is
Sure.
the quickest approach because rather making the replace like we were anyways doing this
Okay.
replace empty string to empty character,
Yeah.
sorry, space to empty character, rather we can make it in my list itself. And uh, the other else block is like this is alpha character, so I can just skip this continue block, and once I do all this, so for example this example I do have a b open bracket, and okay, this should. I mean, this would have yes, this would have AB open bracket and CD, and my stack would have the index like index equal to 3, which is the opening bracket, because for closing bracket, while adding closing bracket, the stack was not stack was empty, so I skipped this character. But for opening bracket, I add it to my stack for that current index. So I want to make this character to an empty character. So uh, for indexing in a stack, I can make the current index to an empty character, and I can send this out. Should I send this as a string? Okay, I should send this as a string. I'll make this. Uh, yeah. So what I'm doing here is like whatever characters there or whatever index there after the first traversal in the stack
Yeah.
would anyways make this characters in that result string as an invalid parenthesis, as seen in this first input array. For for index, I mean the closing bracket, the we are anyways uh, seeing whether the character stack is empty. If stack is empty, we are anyways making this open closing bracket to a empty character, and we are also adding this opening bracket to my stack. So there is no matching after the first traversal. So I, for any characters or any opening bracket which don't have any matching, I do
I
want
see.
to invalidate those.
I see. Okay. Yeah. Cool. All right. So how do you think you did?
I mean, I think I complicated the second solution, the second problem. I didn't thought of this invalidating the characters in. I mean, I've seen most of the interviewers where they say we should not change the input string or input list. Rather, we should form a result string and we should return it back.
Yeah.
It is subjective because most I mean in other language like C++ or Java, the inputs are given as a reference, so we should not try to change the inputs reference. Rather, we should form a result string. I was going in that direction, but
I see.
that would have complicated the stuff. uh, the first approach, I was thinking like union find, union set algorithm in my back of mind, and that caused some complications. So
Okay.
I thought like I made it easy and hacky way, but I'm not sure most of the interviewers do like that approach too.
Yeah. Okay. I see. Yeah. I think your solution was good. Like, I think you're definitely probably a pass on the interview. Let's see where my notes are. I think good understanding. You're able to figure out that it's a graph question. I've asked people this question before, and they couldn't figure out the first question was the accounts merge. Let's go back to accounts merge. Like, I've asked people this question before, and they weren't able to get to the same solution you were. So you're like one out of, I think you're one. Yeah, you're one of the first people to identify the DFS solution right away. I think you're just making some mistakes building your adjacency list, picking the wrong variable names,
Yeah.
picking bad variable names.
Yeah.
So I think definitely like make sure you have that more tight. Like don't like you're missing, you're like changing variable names and stuff while you're coding. It's confusing. But
Yeah.
see, DFS code was good. This code was good. Yeah. Otherwise, I mean the code works. I think you did good job with the thought process though, like asking clarifying questions and talking through the approach. Yeah, I give you a pass on the first one because you got working code. It's not an easy question. I've seen people fail that question. So for this one, you overly complicated the second question.
Yeah.
Good with the thought process. Yeah, again, some bad variable naming, I think. And I think you overcomplicated it. Intuition was almost there, but I think, like with the runtime thing, like you're trying to modify a immutable string, and that always makes the runtime like balloon.
Yeah.
Because when you start trying to update immutable string, if the string is long, it's like O of n operation for. Yeah, and if you did a bunch of updates in that would have made your algorithm really slow. But I think
Yeah. Makes sense.
so just make sure that you remember that when you're modifying immutable objects, you'll create a full copy and it'll become O of n. But I think one thing too is one thing I would say is your interviewers will also mark you based on if the solution you propose is the same that you coded up, and I think the solution you proposed was different than what you coded up each time. Like you kind of learned on the fly. So it was a bit different, right? You proposed one solution. When you got coding, you kind of iterated on it a bit. So I would make sure to just think it through more up front and just have a more solid plan up front. And just work on simplifying the code a bit more.
Makes sense. I think I do also feel overcomplicating the variables name, because for that account merge, I was trying to make sure that each variable name is kind of meaningful, but over the time it made me use graph across other code bases. Makes sense.
Okay. But cool. All right. Thanks for taking the time with the interview. Hope that was good for you and that was good practice. But overall, I think it's a pass. You saw both the questions within the time limit. Just that would be my only feedback.
I'll sure take that.
Let's see. Yeah. Okay. Cool. All right. See ya.
Have a good day. See you.
Too.
Bye-bye.
Bye. Yo, chat. I mean, it's a pass. He solved both of the questions in the span of what we needed to be done. That accounts merge is not an easy question. I've heard like people failed it and like. Paul was mentioning that he might be cheating. Like I couldn't really tell that. Like, what I did see is what he proposed. The solution he proposed was different than what he coded up. That part is like where I'm like, what's kind of happening here? But definitely could clean it up. Definitely could make it more simple. How long did he take? Still under 20 minutes on that question, so it's fine. Changing var names and stuff. Yeah. I think his just communication. If anything, the communication definitely could improve a bit. Bring this down. Okay, we're gonna get CFA CFA in here. CFA, hop on the chat. Chat saying no pass. Honestly, I didn't get the sense he was cheating, but I was really deep into it. But I don't know. I'll give him the benefit of the doubt on this one. Yeah, honestly, when you're in the middle of the interview, it's hard to see if someone's cheating or not. Yeah, Alex is saying he's completely changed his solution. Yeah, I think that's one marking criteria. Yo, John, join the Google Meets. Okay, we're gonna test John's coding skills. He's been coding for a little bit now. Yeah, you could solve it with union find. Solvable with union find. Yeah, my main thing with the last person interviewing was just it just changed up the solution quite a bit. That's the main thing. Need to regenerate that link. Yo, CFA. Wait, let me get you on the stream.
Yo,
What's up, man? Let me get you in the stream.
okay, let me. Oh man, I don't even have Discord or anything on my laptop.
Why do you need Discord? Why do you need Discord? No, I'm gonna.
I don't know.
I can get you. I can get you on the stream. Watch. Just watch the stream.
I'm gonna mute the stream for a sec here, though. I want to see what the chat has to say. You could just use it through the browser too. Oh man, guys, do you know how old I am? Way older than James. So, and the only software that I'm able to use is really just Teams and Teams. That's all I have to say about that one. You should get like a soundboard. Do you know how broke this family is?
Soundboard. Wait, what's happening? What are they saying? Oh, it's echoing? Wait, what? Say it again?
Echoing.
Wait, turn off your stream. Make sure your sound.
Yeah, I turned my
Yo, chat,
stream
you
off.
can't hear him? Yo, you're echoing it, but
Me?
he's not echoing on my side. James is echo. Wait, let me fix this. Hold on.
Maybe your YouTube is on or something.
Wait, the last my other friend on wasn't echoing. Let me figure it out.
The cheating guy's your homie, eh? I think Paul has the right instinct on that one.
Everything's good now? Everything's loaded? Oh, wait. Give me a second. Oh, I see. Okay. Now, I just had to turn off one of the screen share. Okay, talk now, John.
Hey everyone, John here. Was that good?
Okay, talk now.
Hey everyone, John here. In today's video, we're going to be going over blah, blah, blah.
It's fixed? Yo, better, way better. Okay.
Okay, perfect. I don't. Who is AT the same guy as Alex, the one that was on the stream with like the crazy podcast style setup?
Yeah, AT's that Alex.
That's the guy?
Yeah.
Bro, he showed you up on your own channel, man.
Yeah,
His setup was literally
Bro,
like
look at your setup. Look.
my setup.
What is he
My
doing?
setup's bummy, man. I can't show you my room.
Yo, chat, how's the sound?
Billionaire hedge fund owner. Oh man.
Good. It's good now.
18.
Okay. I just had to
Okay,
fix. Who's
perfect.
Casper? New person in the thing. Amazing. Jonathan, what's up? All right.
Woo! All right. Give me like a lead code super easy. Don't do a lead code hard, you know?
Wait.
I'm a lead
Let me
code
filter out
soft
your
type of guy.
background. Let me filter out your background. Perfect.
Oh man, I've been on the road for literally 60% of the last 3 weeks, maybe more. So we haven't been talking. Oh, this is so shit. I'm looking at the YouTube channel. This is so freaking funny. Oh crap! I'm gonna not swear, honestly.
Dude, move your mic away from your face. It's like flashing in and out on the background removal.
Is that better?
Yeah, move it away from your face. All right. Let me move us here. Yo, looks like we're in the same place.
Yeah, that's sick.
Yo, did you see? Oh, you were in the flight when my Y-Combinator friend hopped on.
Oh man.
I'm gonna drop a dedicated video for that though. It's
Yeah,
pretty funny.
yeah. Yeah, we'll link up with them soon.
Yeah. He's gonna show me his YC app. Okay, yo,
Give him
introduce
days,
yourself.
give him-
Introduce yourself to the chat quick before we get into it. Wait. I'm gonna start the video quick. Okay,
Give him days between two dates. Lead code easy.
bro, that's not a
Hey,
hard, easy
Alexander,
question.
man, I tried asking ChatGPT to give me days between two dates. It thought for like 4 minutes before it came up with the answer. I don't know if I'm better than that.
Yeah. Okay, I'm gonna start this video. You can record it too if you want to drop it on your side.
Nah, I'm good.
Okay, 3, 2, 1. Hey everyone. So today I have my brother, CFA, John Peralta CFA.
Hello.
We're not beside each other right now. We're actually in different locations.
Yeah, he's on the west coast. I'm in the Midwest.
You're in the Midwest right now, but yeah.
I don't know. Is that considered Midwest, like prairies?
I don't even know.
Do people know what the prairies are in
You're
America?
a mountain time, so I don't think Denver is considered Midwest.
Oh man, I'll send you a pic next time of the Rockies from the plane. You'll be like, it's real nice, honestly.
Okay.
I'll send it in a family chat. Or
So
something.
we're about to put this guy through a coding interview, like I do with all my candidates in this channel. Just give a quick introduction on yourself, little bit of background. How many leak code questions have you solved? Where are you at with your coding journey? Pretty much that, and then we'll find some good questions for you.
Sure. My educational background, I'm a finance major. I hold the CFA's Chartered Financial Analyst designation. I've done a couple roles in my career. I've worked as a financial advisor for about 4 years. Prior to my current role, I was working as an asset liability management analyst at a credit union for about 3 years. So in that role, I was pretty much managing like loans, deposits, and a bunch of finance stuff with that. In my new role, so I'm not really new. I've been 3 years working in real estate asset management. I got into coding about 4-5 months ago, mostly Python, mostly vibe coding, mostly with AI. So mostly working with AI and then trying to build a equity research analyst that's AI based. How many lead code questions? Probably less than 40, honestly. Probably less than 40, I would say.
So you've been vibe coding?
Yeah, I'm a vibe coder. Cause yeah, like I obviously I've never ever I don't have a background in tech. I have a background in finance. I just got into tech for fun, really. Like I'm not really trying to switch careers or anything like that. I just kind of enjoy your content and I want to be on your stream from time to time. So I do lead code.
Okay, cool. So let's just work through a very simple question right now. So I'm gonna give you a very specific question and tell you to solve it in a specific way. I just need to see your coding
What
skills.
model do I use? I'm just okay. What model do I use for vibe coding? I don't use I don't vibe code the same way as other people do because I try to learn as I vibe code, if that makes sense. So I don't use Windsurf. I've tried what do you call it? GitHub Copilot. I've I never really enjoyed it. What I do is I use ChatGPT to brainstorm my ideas, and then I take the code that ChatGPT writes, and then I put it into the terminal, refactor it. That way, I can learn a little bit as I use AI versus just like having AI write the code for me. Hit. Hopefully, it works. Like I don't vibe code the normal way. Learn NeoVim. Oh man.
Okay. Let's get into this. So this
Okay,
is
yeah,
this is
let's
the
run.
first prompt.
How do you even get into that?
Oh shoot. Let me send you the link. Give me a sec.
Send it to Gmail or whatever.
I'll send it here.
Not gonna lie, Amazon Q is terrible. I have an insider scoop on Amazon Q actually. Where'd you send that? Oh, Castle Ridge Rabs. Replit. I have to sign up for this?
Just sign in. So
Sign in with what though?
just regular email.
Okay, no, I got it.
You're a vibe
Is this
coder. You identify as a vibe coder or a real coder.
I identify as like a I don't identify. I identify as a hobbyist. I don't know if that's even fair to say, but I've definitely vibe coded my way through a lot.
What the hell is vibe coding?
What is vibe coding? I don't even know. It's just something that people complain about on social media, seemingly. Like they're like, "Oh, vibe coding, like it creates terrible code. There's gonna be peace out." Got to wake up at 3 a.m.
Okay,
But
work through this first question.
write a program that prints the numbers from 1 to 100, but for multiples of 3, print fizz instead of the number, and for multiples of 5, print buzz. For numbers which are multiples of 3, print fizz buzz. Bro. Okay, what's my approach to this? I'm gonna run a for loop for I in range length of for I in range 101, I think. Use the modulo function, like use a if, elif, else block or whatever it's called, and then the first if statement, if it's a 3 and a 5, I'll put fizzbuzz. If it's a 3, if the remainder is like not equal to 0 for 3 and 5, I'll print fizzbuzz. Then elif, if it's multiple, if modulo 3.
Okay, wait, write it down.
What?
Just write down
Write
the
it
notes
down.
here, like what you're thinking. You're
Oh,
saying
I
a
can
bunch.
write at
Yeah.
the same time? Oh man.
And remove the AI help. It's down here in the AI complete.
Where's the AI help?
Bottom left.
Disable that.
Yeah, AI autocomplete. Remove it.
Is it good now?
Yeah.
No, it's still helping though.
Where?
It's helping me. Like I could tell it's helping me. Like when I print.
But it's just auto completing. It says print and it's showing the different options, right? That's fine.
Yeah, it
It's
says
not,
values. Oh, that's not
fine.
cheating.
That's not cheating. That's like auto. This is a regular autocomplete. And
Oh,
Paul's
man.
asking how much experience. Oh, Mahdi, how much experience? Like, not that
Like,
much.
Pretty much little.
I mean, 3 to
none,
4
man.
months grinding.
I'm a
lab.
finance guy by trade.
Yeah.
Like,
Okay.
I'm a portfolio manager. I'm not a quant.
One thing I'll just say up front right now is like you said a lot. Like write it down. Like write down the notes when you're saying it. Like what you're gonna do. Like at a high level, just jot down some notes so
Okay.
it's on the editor.
Okay. So I'm gonna use a for loop. Use a for loop,
Sure.
and then use the modulo function to determine if a specific number is a multiple of 3 or 5. Use else, if, elif, else code block to figure out what to print out of the 3 options, and then use an and statement. Does that even make
What's
sense?
an
Is
and
that good enough?
statement? Use an and statement. Okay.
For this fizz buzz, right? For numbers which are multiples of 3 and 5, don't I have to use an and statement for that?
Okay. Yeah. Go ahead and write out the code. I think it makes a bit of sense what you're trying to do here.
Oh man, if I was born 10 years
They're
earlier,
saying this
I
would
would
get
be
you in
way
FANG
richer.
back in 2010.
Really?
There's been a lot of inflation of lead code skills, but
Dude,
go ahead.
finance is way worse.
Don't get distracted.
If I modulo 3 is not equal to, wait, if it's a multiple of 3 and I modulo 5 is equal to 0, return, or like I'm supposed to print it out?
Yeah, print it out onto the screen.
Print every single one?
Yeah. So we're gonna write a program that prints numbers from 1 to 100.
Okay. I just never ever did something like this where it doesn't just run. Like you don't return a list or something. I never really wrote this type of code before. Print is this how people usually do interviews?
Yeah, you're mocking one right now.
Dang. I modulo 3 print. What am I supposed to print? Is else. Oh. What's the chat saying? Am I getting roasted?
No, you're good right now.
Oh, perfect. Would this run?
Okay. Walk me through the code.
Wait. Print 5. Buzz. Else. Print I. Then I gotta put a 1 here. What the heck? Why is this linting? Oh. Okay, walk me through the code.
Wait. Okay, yeah. Walk me through the code.
For I in range 1 to 100. So the way Python works is when you have a range, I don't know, like this is just how the range function works. It just doesn't include the last number. And then it always includes the first number. So this part just prints from 1 to 100. If I divided by 3, this modulo function returns the remainder of I divided by 3, if it's not equal to 0, it's like not, what do you call it? It's not divisible by 3. And then same thing here, right? So then you're supposed to print FizzBuzz. And then I use the and statement that I was talking about right here.
Yeah. Okay. Why did you order these in this specific way? The
Yeah.
statements.
Yeah.
What? Why? Why'd you order it in this specific?
I just
way?
ordered it because I just ordered it based on what I was thinking at the time. Like I just figured it would be hard. Like if I did if you say if I modulo 3 is equal to 0, it won't run the code block right away. Does that make sense?
Basically, what I'm asking is, let's refactor your code.
Like this it won't, like, if you don't put the and statement first, it'll only run, it won't check for the second condition of the and statement.
So you're saying it'll print fizz when it should have printed fizz buzz for that number?
Yeah, like if you don't, yeah,
Okay.
pretty much. That's the reason why I did that
Okay.
first.
Nice.
But really, I think I lucked out with that because I just put it on the notes, like you said, use an and statement, and then that's kind of what I went through first. But then looking at the code now, it wouldn't run, right? Because, like, for example, the way that I wrote it, elif I modulo 3, it would only run if, like, you wouldn't run the code blocks after that if it passed, right? And then
Yeah.
it wouldn't check the and statement.
Yeah. Okay. Perfect. No, good job. Okay. Now I want you to refactor this code, and I want you to return me a list where every index starting from, like, it'll be like a list of, like, okay, what's 1? 1 is just 1, right? Because it's not divisible by any of this. 2 would be 2.
Does my code even run?
I mean, okay, run some test cases on it. Test your code.
Okay. Yeah, do whatever you said you were gonna do. Or tell me to do
It
what
works.
you-
It works for sure. We don't need to.
All right,
we
all right.
need to look at it, but, like,
I'm
okay,
not
we
used
want
to
you.
this
We
stuff.
want. I want you to refactor your code so that you return me a list of all the elements from 1 to 100, and it'll like, in the list would be the result. It would be like, this would be fizz. It'd be like 3, 4.
Okay,
you see what I
yeah.
mean? It's
Yeah,
like
no, I know.
buzz. Nice.
I'm just gonna not even put a thing in there. Answer dot append is Man, why are you typing so hard?
I'm writing notes.
Oh, that's what you do? Okay. Dang. I think I need to learn NeoVim so I don't have to be copying and pasting like this. I think you're supposed to do this. Is this not a thing? Array. Something like that.
Don't type it. Don't type it. This guy's getting fancy. Okay, right.
I'm just trying to
Okay, run the code. Like,
surprise some people.
run the code.
Do you
like,
want me to print it
out
too, or
onto
no?
print it onto the console.
All right.
We don't print these anymore.
Okay.
He's out there no more.
Oh, whoa. Oh man. My interviewer literally out here, what's it called? Doing something for me. All the negative signals.
Nah, it's good. You did good. Okay, yeah, you refactored your code.
Do I hit it?
Nice. Cool.
Did it work?
Yeah. What's your runtime runtime and space complexity here?
In this one?
Yeah.
O(n) time, O(n) space.
O(n) time, O(n) space.
Yeah. So O(n) time, because I only go through the list one or like the range once, and then O(n) time, because like actually, yeah, O(n) space, because I just like make a new list for every single I in the range.
Okay. But like, if this only goes up to 101 and that's the max, or does that every single time, like what would that change your runtime complexity here? Of this function fizzbuzz?
Will it change the runtime complexity?
Yeah, that this is bounded by 101.
No, it won't change. It'll still be O(n) time and space.
Yeah, like a O(101) operation. Right?
Okay. Yeah.
Like O(n) means it grows linearly with the input.
Yeah.
Like, is this growing at all, this function?
No.
So if it doesn't grow, it doesn't grow linearly with the input.
Like, I don't get what you mean. Because, like, for example, here, I'm not inputting any. Maybe
Yeah,
I'm
there's
just
no
getting
input.
confused here. There's no input.
Okay.
So it's like let's say, though, I input in a range.
So every time you call this function, will it ever get longer, or will it always just stay
Yeah.
the same?
No,
When will it get
grow.
longer?
If you put a bigger range.
Yeah,
So
but
it grows
is bounded.
linearly, right?
basically, okay, what I'm just trying to say is it's a constant time operation.
Oh,
You'll always run 101 times.
Yeah. But if you change the range, like if I were to put range in here, right? If I put a
Like an N there, right?
range, right? And then I put range here. Now it's O(n). But that's kind of what I was talking
Okay.
about.
Yeah. Okay. Yeah. I'm
Right?
not docking you
Then
on
you
that.
can-
Like, yeah, you do it. I
Yeah.
wouldn't dock you on that. I just need to just like understand that part. Actually, I'll give you a bit of a dock on that. So,
Dang.
small
It's
ones
okay.
on runtime complexity, but otherwise good.
All right.
Okay, we're gonna go through. Not bad, not bad. We're gonna go through the second question.
Yeah, people. Oh man, I'm a self-described no hire.
No, that was actually good. Okay.
That was not bad.
Yeah.
Is
yeah,
this
that-
an
that's
easy
good, that's
question?
good.
Like, what is that lead? What is that
This
level?
was like it's an easy question, but like given your background, like we're ramping it up, right? We're not gonna. I think for like intern position, that's not bad. I've seen people get asked that and still fold. Honestly.
Dang.
So this is my next question. So gonna be given a random, like given a integer x, right?
Dang, Jonathan. Hey, yes, hire for a junior dev.
Okay, John, pay
Oh
attention to
my
this.
god.
We're given an integer x. Return true if x is a palindrome. False otherwise. Right. So it's like, let me just give you some cases. Input equals 3. What's the output here?
True.
Why?
It's a
Paul said
palindrome.
hire for unpaid intern.
Oh man, dude, I feel like I already done this question before, but yeah, that's a true. Because
Okay,
like
input.
it's the same backwards and frontwards.
Okay, 1, 2, 2, 1. output.
Yeah, that's a true.
Okay. What about -1 to 131?
Given an integer, would this be false? Because it's a negative symbol at the
Yeah.
end.
Okay.
All right.
So you're given an integer. Write me a function that takes in a random integer and just returns true or false. If it's a
Alright.
palindrome or not. Yeah. Go ahead.
Okay. Oh man, unpaid intern. I can't even live with unpaid. Is palindrome, and then candidate. Let's just call that I don't know. Oh man, I went straight to coding. Oh god.
Yeah.
So basically,
Talk about
basically,
your
oh god. This is if you had to ask me what my strengths and weaknesses are, my biggest weakness is I just I'm like a results driven guy to a fault. I want to see
I
results.
mean, you
from
caught yourself. You
Great.
caught yourself anyway. So
Yeah,
okay, go
yeah.
ahead.
So what I'm gonna do is I'm gonna do 2 pointers. For example, here, right? I'm gonna do how do people make a pointer? Like P1. Right? I'm gonna put a pointer here first. Something like that. Oh man.
Just do this. I'll show
bad.
you one thing. Go back. Wait. Let me go to this. Like just you could just like. There's too much characters. Just do like a left and a right or something.
Oh, okay, that's how you do it.
Yeah.
Okay. But yeah, you basically gave me the answer at this point, right?
Not
Start
really.
with 2 pointers, one on the far left and then one on the far right.
Sure.
Right? That's what you're saying?
No, I didn't say
Yo,
anything.
Harold, what's up? One on the left and one on the right, and then do a while loop while the index of the left pointer is less than the right pointer. If those equal the same, then continue, else return false right away. And then that'll be that would be O1 space O then time.
Sure. Okay.
All right.
So how are we gonna do this? Like, what's the code gonna look like?
What's the code gonna look
So you do
like?
2 pointers. Station them.
Yeah, I'm just gonna put an input here. Is that a thing? Integer. Let's just put that. Given an integer x, integer x. Integer x. So I'll do pointer 1, pointer 2, 0.
Yeah, we're given an integer.
Oh
I'm spelling
god.
that wrong.
I'm ESL. Pointer 1, pointer 2, length of. Wait, since it's an integer, I have to make it a string, eh? Because if I can't just run length on that, so I have to do. So now instead of O1 space, it's O van space. Or no, I don't even know how that works now. Like how would it? How
That's
would I
fine.
even
You
count?
convert it to a string. That's cool.
Okay. Subject integer. Let's do as string equals string integer. Length of as string. While pointer 1 less than pointer 2, if pointer 1 has string pointer 1 is equal to as string pointer 2. What do you call it? Pointer 1 plus equal to 1, pointer 2 minus equal to 1, else return false, and then return true.
Okay, walk me through this. Let's dry run this code on for me.
Why'd you add so many lines at the end? Is that just a
Oh,
normal
sorry,
senior
my
dev
bad.
thing?
No.
Okay.
Dry run me
Okay.
the code. Dry run the code.
Dry run you the code.
Yeah.
So you put in an integer here.
Sure.
I turn the integer to a string.
Sure. So let's work with this one specifically. So we call your function is palindrome on this number.
Okay. Yeah.
Okay, now dry run me, like what's happening here?
So this becomes a string, right?
Sure.
This becomes a string on this line,
Sure.
right? And then I initiate a pointer 1 and a pointer 2, which starts at the the extreme left and then the extreme right of the string. My bad here. And then while pointer 1 is less than pointer 2, so while the left and the right here aren't crossed yet, I do this thing where it basically checks if they're the same. If the elements are the same.
Okay.
And then if they are, I just increment the pointer 1 to the right and then the pointer 2 to the left. If they're not equal the same, I just return false. And then if the entire while loop completes, it just returns true.
Sure. Okay. Test it out on some examples and let's see.
Okay. Like, do you want me to get fancy with this one? Just
What do you
do
mean fancy?
I don't know, for I.
No, just write out like 5 or 6, like 3 test
Okay.
cases with random numbers, and I want to see that you can capture edge cases.
Like, this should be could you see it when I run it?
Yeah. So what should that be?
Like, it didn't even print on my console. Oh.
It's printing right there.
Oh crap. Is there a way to get this down here? Oh, here. Hell yeah. Oh. Man, I never tried this replit stuff. It looks pretty cool. Print 3 ran, right?
Yeah.
What was the other one that you wanted to try? 1, 2, 2, 1. Let's do -131. It ran false, so that's right. Oh man.
Okay. Put 131.
It ran true.
Nice.
Oh man, the social developer guy wants to get cooked. Give him a lead code. Super
Okay.
hard.
Cool. Yeah. All right. We're going to the final question. You're higher so far.
Oh man, did I say the Oven? Did I say it right? I said Oven space oven run time. Oven space oven time.
Mm-hmm.
Right?
Okay. We're posting in this new one. Wait, let me fix this.
Whoa. Dang.
Let me fix this.
Wonder if you can do some magic for O1 space. Dang. These guys getting fancy with that. Yo, could you explain to me why a hash map's O1's like constant space or constant time when you search it? How does that even work?
How does it work? Oh, everyone's saying exceptional hire. Bro, I'll get into hash map theory before.
Is this normal? Like, I feel like these guys are playing right now though.
Like, are you familiar with a hash function is? A hash function? Like what hashing is?
No, I'm not.
Okay, I'll explain this
Let's
finish this interview question. I'll do a video on that. I didn't realize that it was
do one on like why is the dot sort function n log n and why is searching with the hash map O1 time.
Okay, yeah. Message me that. Yeah, that makes sense. Okay. So this is the next question, right? I'll let you go ahead and read that. It's more string manipulation, but we're pretty much given a string sentence that consists of words separated by spaces. Each word consists of a lowercase and uppercase, only of lowercase and uppercase letters. We want to convert each sentence into Goat Latin. And these are the conditions to converting it to Goat Latin.
Okay.
So if a word begins with a vowel, append MA to it. So let's see. Right here, right? I starts with a vowel, so we append MA to the end of it. If a word begins with a consonant, anything not a vowel, remove the first letter and append it to the end. So S right here, right? We moved it to the end here.
Wait, where are you at? Oh, my bad.
So here, I'll break it down right here. I, right, turns into IMA because it's the first rule.
Yeah.
Right.
Your output's tweaking though.
What
you
output?
put 2 A's on it.
Yeah, that's the last condition.
Oh.
Speak, right? Since it's a consonant, it's not a vowel. We take the first letter and throw it in the back. Right? Remove the first letter and append it to the end. Then you add the MA. Right? And then the final condition is add one letter A to each of the word based on its index in the sentence, starting with 1. So since this is the first index, we just add 1 A. Since this is the second index, we add 2 A's. Does it make sense?
What? No.
Okay, I'll let you read the question.
Maybe
digest the question and work through the examples and reason about it. You got 30 minutes on this question.
Damn. Holy crap. 30? Is this a medium?
No, it's an easy question. Or we'll give you 20 something.
Hell? Paul, man. The reason why
Just
I don't know
answer this one.
Okay, yeah.
Focus
I just
on the
don't
thing.
know about crypto because it's not a real asset class, right? You are given a string sentence that consists of words
Okay, go.
separated by spaces. Each word consists of lowercase and uppercase letters only. We would like to convert the sentence to Goat Latin, a made-up language similar to Pig Latin. The rules of Goat Latin are as follows. If a word begins with a vowel, A, E, I, O, U, you append ma to the end of the word. For example, the word apple becomes apple ma. If a word begins with a constant, not a vowel.
Consonant.
Okay. If a word begins with a consonant, not a vowel, remove the first letter and append it to the end. Then ma. Then add ma. So if a word is not in that A-E-I-O-U thing, then add ma, remove the first letter, and then append ma to it. Okay. So I'm just gonna start making. Can I start making what do you call it? Notes here.
Yeah, write notes at the
This is
bottom.
actually kind of hard.
Kind of
to be
explain
honest.
example one here and why. Just like walk through the example. Figure out why this outputs this.
Why this outputs this?
Yeah.
Like I'm just gonna go sentence by sentence,
Sure.
right? So like what I'm thinking is I'm just making my notes here. You're given a string sentence that consists of words segregated or separated by spaces. So I need to firstly take the string and then manipulate it into a list of the individual words. That's what I would do from the jump, because then I'd have a problem like what that last dude had with what do you call it, immutable thing, whatever, right?
Sure.
And then that makes it easier for me to do this part of it, like the Applemon stuff. Like the main problem that will not get me the job is I actually don't know how to separate the string into a list. But I'll figure out a way. It might be janky, but I think that will be hard for me.
Okay, like there's a split
Oh,
function.
okay. Now I know. Uh, you are given a string that consists of words separated by spaces. So I'm gonna dot split. Use the dot split, and then I guess you put in a space or something like that. I'll figure out the syntax.
Sure.
You're given a string sentence that consists of words separated by spaces. Each word consists of a lowercase and uppercase letters only. Immediately, what I think about that is I'm going to have a hard time.
What? Stop looking at the chat, bro.
Yeah. I'm trying to look for hints.
Nah, don't look.
But yeah,
Turn that thing over.
okay, let me
Yeah,
turn
turn
the
it over.
chat off. Okay, I'll remove the chat. What was I saying again? The problem that I'm going to have is I'm gonna search for this, but I don't know if like I might be like I'm probably gonna make a list, and or I'm gonna make a hash set, so it's O1 space lookup.
We're saying if a word begins. Okay, walk through
Yeah,
this input right here.
so like what I have to do for this input is I have to split this into a list like this, right?
Yeah.
So I have to do I speak goat Latin, right? And then seemingly what I have to do is I have to go into each one and then pull the first letter, and then see if it's in this if it's in this list of A-E-I-O-U, right?
Sure.
The problem with just searching it like that is I'll have to check whether or not, like I'll have to search this I as a lower in my hash set. The reason why I'm using a hash set is I want once like I want constant lookup.
You want constant
time
lookup.
lookup.
So you're gonna
Yeah.
convert this I into a hash set.
No, I'm gonna initiate a hash set with A-E-I-O-U.
Okay,
So I'm gonna have
sure.
like a hash set like that.
Okay, sure.
Vowels equals this. Right?
Sure.
And then that'll give me O1, like that'll give me constant lookup time.
Sure.
But yeah, so what I'll have to do is I'll have to look up the I dot lower, or like the first element of each string, and the dot lower of that, and see if it's in the vowels. And if it is, do whatever logic this is. So if a word begins with a vowel, append ma to the end. So I'm just gonna put that there. If, whoa, what the heck? So if in vowels, then do append ma, right?
Sure.
Something like that.
To that one.
I think that hits this one. If a word begins with a constant, not a vowel, remove the first letter and then append it to the end.
Yep.
And then ma. So then that would be O when runtime.
Doesn't matter. Don't focus on that part. Like if you wanna.
Oh, I don't.
Don't
You don't care about that.
Don't care about that.
Yeah, that would be like pretty hard though. Like I would just take that initial list, and then take a slice of the first, like everything except the first. Put that first index, then add ma to the end of it. Elif not in vowels. Append. What do you call it? Like I would do a slice, so string, and then do like 1, 2, like that, and then concat string dot 1, I think, and then ma to it, and then that's what I'll do. And then that specific letter becomes this type of thing.
Sure.
Right?
Okay. What about the last? Okay. When we Okay. What about this last part? Add one letter.
Add one letter.
Yeah. Add one letter.
For example, add one letter A to the end of each word per its word index in the sentence.
Yeah.
Starting with 1. For example, the first words get 1A added to the end. Okay, so I have to set up a counter at like I have to set up a counter seemingly. I don't know if I run that at the end.
Yeah, you could do whatever, but
yeah, I might just run that at the end.
Do you see here, right here? This has an extra A. This has 2 extra A's.
Is that?
Like my output here. So yours is only gonna. This has 1 A. This has 2 A's, right?
Yeah.
So get it.
Yeah,
into
no,
the
I
right
get
output,
that. Yeah. So I just have to do a count of each, and then I'll just set up a counter, and then that way I could do this in like faster.
Okay. Okay. I think the code makes sense. Go ahead and implement that.
Oh man. Oh, I'm itching to know what the chat's saying. God. Okay, let me put I speak Goat Latin as the initial input, right? Honestly, I should have just wrote the code. Input equals this. Define They're picky with the names, so how do I get this? To goat Latin. And put in the input. All right. Okay, the first challenge is going to be firstly take the string and then manipulate it into a list. Let's do test equals answer or input dot split, and then check this, and then hopefully
What's test? Oh, you're
I'm just testing if that actually runs. Like, I don't even know if that outputs a list or something. I don't even know what that does actually.
Okay. How are you gonna test it?
I just run the code, and then hopefully it works. It doesn't run because I didn't call the variable. Just run it. It worked. Perfect.
Sure.
So I'm gonna do for LM in
For time, we have about 10 minutes left.
dang. Oh god. For
You get the nerves kicking in. You're going to...
for let's call this sentence for words.
We can't
For
just do
word
3-hour videos like we were
and
doing when we
words.
first started the channel.
Oh man, for word and words, and then initiate. Bro, you had me put it up here. I could have just had it down here. What if you call your interview, bro? Like, that's bad, right? That's
A
bad
lot of
manners.
Gen Z people are doing that these days. I think it's not professional.
Dang. I see. But I'm like a boomer or whatever. So if I do for word and words, I check if word what word like what did I say? I said this in vowels. What did I say here? For if word in vowels, if in vowels dot append ma, right? So I'm gonna put word equals, oh, and I want to put a counter equals 0. Word, let's see, words counter equal to words counter is equal to word, what did I say here? Word dot concat word and then ma.
Concat's a function?
Is it? Dang, I'm talking Excel, right?
You can just
It's
do word
joining.
plus MA plus.
It's okay. I got it.
Sure. Does that work?
Does that? I feel like it does, right?
It doesn't work.
It doesn't work?
Yeah. Just
What?
do a simple like word plus like.
Oh. Word plus ma. Counter. Oh, wait. I have to do counter plus. Wait. What the heck? Plus counter plus 1. And then I have to put as many A's. Add one letter for A. Plus counter 1 times A. Is that even a thing? Oh man, 10 minutes though. I just have to run with that. For word in words, if word, blah, 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 in vowels, dot lower. Elif, or no, but just do else, right? Then what did I say up here? Else. Dude. Words. No, man. Okay, how do I get this? Elif not in vowels. I'm just gonna hopefully.
Yeah, how are you gonna push it to the back?
Words. Counter equal to word 1 like this plus word like this. And then add this. Is that gonna run even?
So 1 and then this to 1. And then what? What's happening? What are we returning?
Elif. I think I have to do an elif here.
Elif what?
No, I don't. I think this will run. I want to try it and then see an error and then iterate.
Sure. Go ahead.
Frick, what the heck? Return.
Return none.
Words.
I mean, we want to return a string.
Yeah, I know, but I just want to check.
Okay.
What? Why does my goat not work though? Like this is what I'm trying to get at, right?
Okay, what's this right here? What is this doing?
So I'm taking the 0 to 1. So I'm taking the first letter of every word.
Okay.
Right?
What
I mean, I could
I
just do
disappeared.
it. I could just do this, honestly. So, right?
Okay,
But this
I
is small.
disappeared.
What? What? What are you doing? What? What's happening?
You see the output. The output is here.
Where?
On the right.
What?
You don't see the
Okay,
console?
yeah, it's no, I see it at the bottom now. I deleted the YouTube thing.
Yeah, you see the output, right?
Yeah,
Like, open up the console for yourself and check it.
yeah. Yeah. I put the wrong thing in though. I speak Gold Latin. Let me change the input up.
No, like that input is the right input, but it's just outputting the wrong result.
What? How? I speak Gold Latin. Like I don't even increment the counter though. Plus equal to 1. Counter plus equal to 2. I'm a Pixma. Oh, somehow this is wrong though. Oh. What? Do I not put the ma in here? Like it looks right, but it's not right.
What's wrong?
Like I don't have a ma here.
Where?
Right here. Holy, my ears are ringing from the pressure. What the heck? I must speak sma ot gamma atin lama. Hell yeah, Iran. Right. Iran, right.
Okay. It doesn't look correct. Though it's coming up in a.
It doesn't look correct.
I mean, it looks
How is
correct, but
that?
we need to return a string at the end.
Oh. Dot join words. Oh god. There you go. Heck yeah, Iran. I got too excited. Now that's a negative signal, eh?
Yeah, keep your cool. Keep your cool during the interview.
Oh man.
Just kidding.
I'm not used to pressure situations. It's not like basketball. I just need more time in the
Okay.
in the
I'm running it on
games.
the. I'm running it.
Running it on what? Like how are you running it?
Like on lead code. You can open up the. You can open up the chat or open back up.
Oh, I
open
can
up.
open up
Open up and
YouTube?
look and look.
Holy, that was high
about to run
pressure.
it.
Did I
We'll see. I'm about to click submit. You looking? You're watching?
What?
You're watching
I'm watching what?
the stream? Boom!
Wait, where? Oh man. Oh hell yeah. What did it say? Oh, beats 100%. Is that capping? Is it because
No.
you're in SF and you're close to the server?
No. No, honestly, good job, man. Chat, how do you think he did?
Oh man. Did I use all the right words? Like I use the good buzzwords like hash map, hash set?
Yeah. Okay, let's walk through this. Let me make notes here.
Holy, I feel like when you said that there's 10 minutes remaining,
You just got scared?
yeah, I got
Exactly.
scared.
That's exactly what I had to
tweaked.
do.
I tweaked when you said it was 10 minutes left.
Somebody said we're converting you from unpaid to paid now.
Who said that?
J-Hung. Paul,
Oh, man.
what are you giving this
That's
guy
lit.
for that interview?
Holy. What? Like those were easy questions though.
Yeah.
Was my code verbose?
Nah, the code is good, man. Honestly, you're getting a pass for an intern.
No way. Really?
Yeah, honestly, that was a good
That
job.
was-
For an
that was
intern, that's
hard. I feel
definitely a
like-
good, strong, solid hire. Solid hire, I would say.
Was the start of it like a hard? That was hard though.
What
I
do you mean?
feel like I had to really get into this part of it was tough.
Which part?
Like I don't know what Goat Latin is, so I didn't even know, dude.
Yeah.
I was bad at English. I was like, what the heck is a consonant?
Yeah.
And then I kind of had a problem with that. But then I just realized if it's not in the hash set, I'm good.
Yeah.
That's kind of how
Okay.
I kind of ran it.
Okay. Let me give you. How do you think you did? I always ask people that.
I thought I did pretty good because I actually managed to solve every single question pretty quick.
Yeah. 3 questions in the span of an hour. Yeah.
Yeah.
What else? Like, what
Yeah.
do you think? Where do you think you struggled with? I'm just trying to see how you felt the interview was.
I think I struggled with talking about my logic before writing up the code. That's my main thing. Like I still, because I write a lot of Excel, I like concat is an Excel function and I just didn't know how to do that concat thing unless you told me. I didn't know how to do the dot split method. Like I probably seen the dot split method before. I just don't remember it though.
So just syntax stuff.
Yeah, that type of thing. But yeah, I think the main piece was like thinking about the logic and then writing out the notes as I think is a definite pain point for me.
Yeah. Okay. Sounds good. Yeah. For Q1, definitely a pass there. I think you have
What
a
was Q1?
fizz buzz. Fizz buzz.
Okay, yeah.
So good understanding of the if else conditions. You ordered them properly. Candidates mess that up too when they order the if else statements first. So if it's module 3, it just keeps hitting that, but
Yeah.
it should have not. It should have like printed fizz buzz instead of fizz kind of thing. That's like the main gotcha with that question people fail on.
Did I get that?
Yeah, you got that. You understood the modulo operation. I mean, that's
Yeah.
also yeah. So I
I
see.
think somehow
Understand
that's like
basics.
something I started with. Yeah.
You understand. You understood how to loop from 1 to 101. Understood that it's exclusive or to the last number. That's why you wrote 101. So I think that's also not trivial. Knowing how to loop a certain amount of times.
Nice.
I told you to extend the function so you're able to refactor it. I don't know. Overall, good job on the first question. Definitely a higher on that. You definitely
Heck
know how to code.
yeah.
Small minus on the runtime complexity. Like if something is a constant, if it's gonna run
Yeah.
101 times, every single time you run it, it doesn't grow at all. So it's just
Yeah.
constant time, right? But
Okay.
so just remember that. Q2, checking if a palindrome integer was a palindrome. Yeah, I think good intuition on converting it. You can't just run it on a string, or you can't run it on integer. You can turn it into a string. Code was clean, giving you a pass on that as well.
Nice.
Q3, yeah, Q3. I think you said that you struggled with talking about the logic before writing code, but you did do that though. Like you did talk about it before writing the code, so I wouldn't dock you there. But because you caught yourself, the important part is catching yourself. So you're about to do it, then you're like, oh, caught
Yeah.
myself, and then you did
Yeah, I
it.
don't remember how I feel like I was in the zone on that. So I don't even remember. Honestly, this was 1 hour long.
Yeah, you're locked in, huh?
Damn. Yeah, like that flew by quick time,
Yeah. Yeah,
to
good
be honest.
good way like you're able to digest the code, like what it's saying. It's a lot of words. I've already folded people with this question before, so you're able to solve it, which is good.
Oh,
People who are
dang.
actually comp sci majors, so like I
Dang.
think yeah, good job on that. Let's see. Yeah, I think good intuition with stuff like using a hash map here. What if you
Yeah.
didn't use a hash map? How would it
What if I
scale?
didn't
Like
use a
would this
hash
make
map?
it? So like, if you didn't use a hash map, right? You turned
Like
it.
if I use a list,
Yeah, if you turned it into a list
it would be oven runtime
or OVEN, but it only has 7 operations here. 1, 2,
07 run.
3, or
Yeah.
6. 1, 2, 3.
Yeah.
So is that the same as this?
Maybe yeah, it is
Yeah, they're
actually.
both constant, right?
Yeah.
So it's,
Okay,
but I would
I'm
still turn it
done.
into a hash map. This is still better because it's still like it is constant in runtime, but in real life it's still suboptimal. But
So just always use a set. Like from my understanding, you always should use a set.
yeah, you
I
should use
just
a
watched
set.
that on a YouTube short. You just use a hash map if you can and a hash set if you can.
Yeah, but like just know that like pretend here, right? Because you're trying to turn this into a ov1 operation when you turn it into a hash set, right? Checking if vowel is in vowel, checking if the first letter is in vowels. You're trying to turn this operation to ov1, isn't it? That's what you're trying to do.
Yeah.
It's like, but what if this was just a list? Then like it would just be a ov6 operation here.
Yeah. It would still be constant, so it's like doesn't affect big O.
Doesn't affect big O, but it does affect real life. So I would just, but like you see what's happening here, right? That makes sense.
Yeah.
Yeah. Otherwise, I don't know. Good job. Like you implemented it well. Like this is good syntax here for generating a bunch of A's
Yeah.
and appending it to the end.
Yeah.
I think you have good debugging skills. You're figuring out that the counter, that's what was happening when you read the output. You figured out the MA here. you're doing a weird thing where you just love to slice. So you're like slicing even though you're grabbing one element. So it says like
Yeah.
if you're grabbing one element, just grab the index.
Okay.
You could probably
Yeah, I
clean
just
this.
wanted. I
Yeah.
thought it was like a styling thing, cause like, see here, I do that, so I figured that I would do the same thing here for legibility or whatever. But yeah, no, I get what you meant. Like that's the same thing as me. Like remember when I first started lead code, I would always like do the -1 at the end. That's just something I gotta fine tune out of my system.
Yeah. So what did this say? Add one letter. Wait, what are we saying? Remove the first letter. So you could have did this. Like, I think this would still work. So you took the first letter of word and you moved it to the back.
Yeah.
That would still work, but like, yeah, that's the same thing as this, anyways. But
Yeah, that's what. Yeah.
one thing was like you could just move this counter out here. These are small nits, just so it avoids duplicating the count. Like,
Oh
put it
yeah.
in the word.
No, I see that now.
Otherwise, yeah, good job. You passed the interview. We're gonna.
Woo! What did the
That's
chat
crazy,
say?
man.
I have to read what the chat say.
No, the chat. Yeah, I'm gonna stop the
You
recording
think
here.
you think it's good? You think I did good on it?
Dude, yo,
like-
you're showing a lot of promise.
Let
You're
me
already
can you
solving these questions.
look at my lead code.
Send me the account.
on stream. It's just John Peralta CFA probably. Let me see. I don't know. I use my GitHub though. I got my first badge the other day. I got a pandas badge.
Damn, you
But
solved 61 questions?
But yeah, like it's 60 questions, but I do SQL at like Squeal and pandas. So it's kind of cheating. Like
No,
my
that's fine.
stats are
It doesn't
padded
matter.
because like I did the learn pandas intro to pandas and that was like 15 questions and then I do the Squeal version that's like another 15 I think.
Dude, you're getting good, man. Just
But I
keep it
only
up.
really did like 4 mediums.
Just keep it up, bro.
But yeah, I'm a vibe coder. I started off vibe coding. I don't really vibe code though. I don't know what people say.
Is Ali still in here? Ali is still in here? Ali's saying, I'm writing my CFA level 1 in June. Does John have any advice?
Where is he at?
Where you at?
Like where are you at in your studies? Like you're writing it in June, so that's 2 months. Honestly, start spamming problems. Start doing problems this deep in. Don't even read the textbook anymore. Or like everything that's not solving problems and doing end of chapter questions, doing mock exams is a waste of your time. That's my advice. So start like you should get to like 2,000 questions or more by June.
2,000 what? CFA questions?
Yeah. That's what I would say. And then only go refer to the textbook if you really don't know a concept. And then that's all I have to say about that one. Just start spamming questions hard.
Nice.
No clue what vibe coding means and no clue why people have started saying it in the past 2 months. Yo, I didn't even know what vibe coding was. Like apparently the way vibe coding is basically just spamming the chat, like spamming the AI until you get working code and then hopefully that runs. And then I really don't know what vibe coding is, but like really my approach to using AI for coding is I think about a solution in my head. I write that out in pseudocode and then it outputs the Python code and then I refactor the Python code and then put it into my code base if I think it works.
I see.
But yeah, Ali, what year are you? Because like I don't think level 1 you really need to study that hard. Like the textbook, it should be matching your curriculum and then just start spamming questions from there. And then Paul is CFA exam multiple choice. I think level 1 and level 2 are multiple choice, and then level 3 is long answer plus what do you call it? Long answer plus multiple choice. But yeah, the pass rates of the CFA are like way lower than the pass rates of the lead code, seemingly.
Probably.
Yeah, right? Because like, how many hours does it take to get good at lead code? Like 100?
100 hours? I don't know.
Like 100 only, or
No, like
100 is light?
probably like 1,000.
Oh,
Like to
okay,
be
yeah,
able
that's
to do
like
hards
CFA
is even
level
more.
then.
To
That's
do
like
hards,
CFA then.
to do hards from scratch, I don't even know. Maybe it take more than that.
Yeah, I feel like that's CFA levels.
All right. Okay, that's the stream. Finished off strong.
Woo!
John gets his first hire.
That's a first hire.
His first
I think
hire
I think
rating.
I think like if you asked me a question that required like a linked list or something like that, I would have folded though. I think that's something that like not good at.
Yeah, go struggle.
But
Go
like
practice that then for
arrays and
next time.
strings.
We'll do more array and string ones, but then
Yeah.
we'll go into linked list ones too.
Yeah. Oh dang, man. Holy, that was an hour. I can't believe it.
All right,
Oh
that video is
man. I
dropping
hope I'm
tomorrow,
better than
man.
Patrick right now.
Yeah, I'll put Patrick through one soon, but
Yeah, run Patrick through one.
let's see if Patrick's in
But
here.
yeah.
All right, John. I'll talk to you later, bro. Oh, he's
All
in
right,
here.
okay, peace.
Okay, peace, bro. Peace. Yo, chat. How do you think he did? How was that? Holy crap. 9-hour stream. Yo. Yeah, did pretty good for background, honestly. Like, that was really good for background. But yo, chat. Okay, I'll look at this last person. It's 2 minus 1. Nice. Pretty good, pretty good. Going crazy. But everyone, thanks for coming on the stream. We're gonna do more of these with more people. We got like that was a whole new batch of people. A lot of fun interviews. I mean, what did we do during this stream? Like, I mean, we got my friend from YC to hop on. We were helping some high school grad like work through his resume. Richard from Waterloo came in. Yeah, maybe. Or more hards. Pop out more hards for sure. 13 hards is not enough there. That's the main thing. But yeah, that was a sick stream. We'll get this to 9 hours, so we'll kill like 2 more minutes. But what's everyone up to tonight? Everyone's just gonna sleep. That was I'm happy with that stream. Lots of good content and diversity in what we were doing. Had like beginners, had experts. Didn't get the OGs, Paul and Alpha. Oh, actually, Alpha was in there too. But Paul, we're gonna get you on it on the next one, doing more coding. We'll see where your skills are at. But I'm gonna get a bunch of people. We're gonna do more of these. That was pretty fun. I might move these to Saturday. Yeah, I might move these to Saturday so I can hang out with friends on Sunday, go eat food and stuff. I missed out on a good. We were about to go to like a nice Mexican restaurant, but I was like, nah, I gotta stream. But this is real fun, so I had to like. We just need to get more people. Nah, but I had a good day yesterday. Oh yeah. Let me show y'all like some of the stuff that was happening yesterday. How do you reduce the volume here? Reduce the volume. Ooh, that was loud. Yo, there's like a pop-up rock band that pulled up. It's crazy. Trying to get this. Let me see. I'm gonna show y'all some of the stuff that was happening yesterday. Like, get this synced with the cloud. Oh, it's all good. I'll drop a video on it for the other one. But yo, everyone, thanks for hopping on the stream. It's been 9 hours. See y'all on the next stream. Have a good night. Hope y'all learned something. We'll run this again a different time. Peace.